Hello, 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 hello. Hello, 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 hello. Can you hear me? Am I audible? All of you? Hello, hello, hello. Very good evening, all of you. Am I audible? Am I visible? Quickly, all of you. How are you all doing? All well? Hello, Ayush. Hello, Kavitha. Hello, Ria. Hello, Anil. Hello, Vamsi. Hello, Rachna. Hello, Jiva Jiva. Hello, let me think. Sony, Arsha, Widge. So, can you hear me? Quickly in the chat, thumbs up. So, here we go, here we go, here we go. Ta-da! Namaskar, Adab, Sat Sri Akal, Vanakkam. Very good evening to all of you. And first of all, smile. You are in the beautiful family of Physics Wallah. As I can see, a lot of students are there. Sai, Gaurav, Parveen, Akshita. Very good evening to all of you. So, what's the agenda for today's marathon? What we are going to do in this marathon? This is going to be one short discussion of the complete physics of class 11th. The level would be for JEE mains and NEET. Okay. So, what we are going to do? We are going to cover more than 200 numericals and concepts in this session. This is your friend Sontu. Say hello to Sontu. Sontu is saying hello to you. Okay, and he is asking, are you ready? So tell him, are you ready? Just say, are you ready or not? So this is going to be the roadmap of today's session, today's marathon. First of all, in the first slot, we are going to cover basic mathematics. That means trigonometry, differentiation, integration, vectors. And apart from that, 1D, 2D kinematics and Newton's laws of motion. After that, we'll be having a break of 10 to 15 minutes. And then we'll begin with work, power, energy, center of mass, rotation, gravitation. This would be covered in the slot number 2. After that, the mechanical properties of solids and fluids and thermal science. When I say thermal science, what I mean when I say thermal science, I mean calorimetry, I mean heat transfer, thermodynamics, KTG. Okay, the complete thermal science. And after that, we'll be dealing with the concepts of oscillation and waves, one of the most important segment for NEET and JEE mains. Okay, this is one of the most important segment, oscillations and waves. Okay, so if you talk about the duration of the marathon, so honestly, I don't know that how long it's going to be, but one surety is there that we will be completing each and every single concept in detail, no matter how long it takes. So let me know that, are you ready? Are you people actually ready? See, I don't know. Honestly, I don't know that it's going to be 6-hour class or 8-hour class or 10-hour class. But one surety is there that we'll be dealing with every single concept in detail with numericals. So give me a thumbs up if you all are ready. Okay, that's the spirit. So let's get started. Okay, here we go. The first concept, the first topic that we are going to deal with in the lap number 1 is the basic mathematics. So beginning with the basic mathematics, first of all, what do we see in basic mathematics? We deal with the concepts of trigonometry. So before dealing with trigonometry, we should know that what basically angle is, what actually angle is. We are talking about the angular measurements. That means you need a fixed reference. Let's say this is a fixed reference. Okay, that's cool. And what you're doing, you are measuring, let's say this is your sense of rotation, theta. So what is the unit that we deal in order to measure angle? We deal with radian. Okay, and what's the relation between degrees and radian? When I say that this is the complete space, tell me one thing, that if you have to divide the complete space, in how much angle do we divide a space, or let's say a plane that's divided into 2 pi radians? Okay, so just remember that 2 pi radian corresponds to 360 degree. Okay, 2 pi radian corresponds to 360 degree. That's cool. So pi radian corresponds to 180 degree. Pi by 2 radian corresponds to 90 degree. Sometimes the students face problem in this. Sir, what is pi by 3? Just divide it by pi by 3. Just divide it by 3. Pi by 3 is 60 degree. Pi by 6, 30 degree. Okay. Basic concept. Let's take the discussion ahead. If we talk about the trigonometric ratios, first of all, what is the trigonometry? What are the trigonometric ratios? We deal with the trigonometric ratios when we talk about a three-sided figure. That's what we call as a triangle. That's cool. So what are the basic trigonometric ratios? What are the basic trigonometric ratios? This is what we call as base, perpendicular, hypotenuse. Quickly, all of you. Sine of the angle theta. What is the sine ratio? That's opposite divided by the hypotenuse. That's cool. What is the cos ratio? What is the cos ratio? That's base divided by the hypotenuse. That's fine. What is the tan ratio? What is the tan function? Tan function is simply sine by cos. So what it turns out to be, the hypotenuse gets cancelled out. This is perpendicular divided by the base. Okay. Basic discussion, basic quick recap we are having. After this, if I talk about the quadrant system, so we divide the space into 4 quadrants, isn't it? In the first quadrant, if we talk, all the trigonometric functions are positive. In the second quadrant, sine. Third quadrant, tan, and then cos. So you might have studied that mnemonic, all school to college, or add sugar to coffee. Okay, so just remember this way. How do you remember this? Like my teacher told me that all school to college. Okay, because you are studying in school, you'll be going in college after this. So all school to college, or add sugar to coffee, one and the same thing. Okay, so if I talk about the second quadrant, who is going to be positive? Sine and the reciprocal of sine. Sine and the reciprocal of sine. Who's the reciprocal of sine? Cosec. In this quadrant, tan and the reciprocal of tan and the reciprocal of tan. That means cot. Cos and the reciprocal of cos. That means sec. Okay, basic discussion. Some basic formulas that we are going to deal with. First concept, that if you change the angle in multiples of 2 pi, so the trigonometric function doesn't change. What I'm saying, that if I talk about sine theta, or if I talk about sine 2 pi plus theta, then what do I mean by this? This is sine theta. Tell me one thing, if you are talking about sine theta, you are in the first quadrant. For example, you are in the first quadrant. If I say sine 360 plus theta, so how much have I traveled? I have traveled 360 in addition. That means I can draw the figure something like this. Let's say this is sine theta. Sine theta, you're talking about 30 degree. Okay, that's fine. Okay, sir, that's fine. This is theta. Now, the next thing that I'm asking you, that what is going to be sine 360 plus theta? Again, in which quadrant you are going to lie? If you move 360 degrees and again you add theta, you are again in the same quadrant. So is it going to change the function? Definitely no. Is it going to change the function? Definitely no, it's not going to change the function. So when you add or subtract 2 pi, 4 pi, 6 pi, 8 pi, it's not going to change the function. That's why we are writing the formula something like this. That's cool. After this, if we change the function in multiples of pi, now try to understand. Like sine of 180 minus theta. Tell me 180 minus theta means which quadrant? All of you in the chat. First quadrant, second quadrant, or third quadrant? Palak Priya, Riya Soni, Nageshwar Rao, Neelu, Gaurav, Sai. What am I asking? I am asking that if you do 180 minus theta, you are in which quadrant? Very basic question, just to check that are you alert or not. Are you mentally present in the class, all of you? I want the answer from everyone. In which quadrant we are going to be? Very good, Rachna. Very good, Diksha. Some of you are completely alert. That's good. Very good, Hassan. Very good, Shweta. That's great. That's cool. Very good, Riya. Ravindra. Okay. So when we talk about 180 minus theta, in which quadrant we are? Sir, this is 0, this is 90, this is 180, and you are saying 180 minus theta. That means you are in which quadrant? You are in second quadrant. And in second quadrant, who is positive? all school. Who is positive in the second quadrant? Sine is positive. That means 180 minus theta is going to be positive or negative? Are you getting what I'm saying? 180 minus theta is going to be positive or negative? Definitely it's going to be positive because sine is positive over here. Yes, yes, it's going to be positive. Very good. Good response, all of you. After this, if I talk about cos, I'm hiding the answer. If I talk about cos 180 minus theta is going to be positive or negative? Cos 180 minus theta is going to be plus cos theta or minus cos theta? All of you in the chat. I'm asking about cos. It's going to be plus or minus, plus or minus, plus or minus, plus or minus, plus or minus. Quick, all of you. You are giving the answer for sine. Now I'm asking for cos. All of you. Kushal, Rahul, Rachna, Joel, Dora. Yes, some of you are giving the correct answer. See, when you talk about cos function, 180 minus something, the function doesn't change. But you are in the second quadrant. In the second quadrant, the value of cos is positive or negative? The value of cos is positive or negative? That's negative. These are basic discussions. Okay, if you're not very clear with these basics, you're going to face difficulty in the numerical solving. So just clear your basics right here, right now. It's a very good opportunity for you. Okay, that in one shot you're going to discuss every single concept. So just be alert in the class. Now we are talking about tan. So no need to think much about tan because tan is sine upon cos. Tan is simply sine upon cos. 180 minus something, cos is negative, tan is also going to be negative. I hope that this basic discussion is very clear. So let's take the discussion ahead. Beta, you will get the PDF on the app. You will get the PDF uploaded at the app, PW app. Okay. You just have to download it completely free of cost. No formalities, nothing. Just download and keep the PDF with you. Okay. Also keep on writing the important things that you feel during the notes, during the lecture. Now we are going to change the function by pi by 2. Okay. If we change the function by pi by 2, try to understand what is the fundamental behind this discussion is. We are not getting very much into the detail regarding the mathematics, but yeah, some basics we should know. This is the quadrant system. Okay, this is the quadrant system. Let's say you are in the first quadrant. And the angle is 30 degree. Add 90 to 30. How much do you get? Add 90 to 30. 30 plus 90, 120, isn't it? In which quadrant you are? If you are in first quadrant, I say that add 90 degree to the angle theta. Now you are in which quadrant? You are in which quadrant? Quickly in the chat. Don't take this much time. Basic questions I'm asking you. It proves that how alert you are during the class. Very good, Kaushal. Very good, RR. 120, that means you are in the second quadrant. You are in the second quadrant. Isn't it? Yes. So if you add 90 to your function, your quadrant changes. Okay. Same with the second quadrant. If you are in the second quadrant, you add 90 degree, you get into the third quadrant. You are in the third, you get into the fourth quadrant. That means the nature is going to change. Nature of the function is going to change. So every time you add or subtract 90 degree from any trigonometric function, the function is going to change. Now the question arises, we don't have to mug up all this. Okay, we don't have to mug up all this. Just basic thought. If you add 90 degree to a function, to an angle, okay, let's say sine of 90 plus theta, it's going to give you what? Cos plus or minus? Y plus, y minus. Question is plus or minus. Okay, sir, that's going to be plus. Now the question is why? Why is it plus? Why it's not minus? Because even if you add 90 degree to your angle, then what it's going to be? It's going to be in the second quadrant. In the second quadrant, sine is positive. Yes, so it's going to be plus. If you talk about the cos function in the second quadrant, cos is negative, so it's going to be minus sine theta. If you talk about tan is sine upon cos, so by default it's going to be negative. Simple. Okay. Sine 90 minus theta is going to be plus cos theta, because in the first quadrant every function is positive. Cos 90 minus theta is going to be plus sine theta, because again you are in the first quadrant. Simple. Okay. And again, this is positive because tan is nothing but sine upon cos. So let's take the discussion ahead. So here we go. Here we go. Here we go. Here we go. If you change the angle, if you replace the angle by minus theta, that means let's say you're writing sine of 30 degree. What sine 30 degree? Sine 30 degree is 1 by 2. I say that take sine of minus 30. So what it's going to be? It's going to be minus times of sine theta. Minus times of sine theta. That means simply minus of 1 by 2. Cos minus theta is going to be cos theta only. Cos minus theta is going to be cos theta only. That means if you take the same example, cos 30 is root 3 by 2. Cos minus 30 is also root 3 by 2. Okay. Where in the place of cos we have written cot? Here. Where? Okay. Okay, that's fine. Good observation. Let's take the discussion ahead. Okay. If you talk about the tan of minus theta is going to be minus of tan theta. Okay. Akshita is saying, please little slow. Akshita, this is very basic discussion. We need to take this discussion at a higher pace, or else we won't be able to complete the big topics which are remaining. Okay, like rotation, thermodynamics, oscillations, waves. Okay. So let's take the discussion ahead. Just keep on writing the basic discussion. Yeah. Now we are talking about coordinate geometry. What basically is coordinate geometry? We are talking about the location of a point. If I ask you that this is the pen, where is this pen? If I ask you, where is this pen? So how are you going to answer? You're going to say, sir, it's in your hand. I will ask, where is my hand? Where am I? Okay, so in order to answer these questions, you need a reference system. Okay, what do you need? You need a reference system. So we divide this 3D space. This 3D space is divided by 3 axes. Okay, we divide this 3D space by 3 axes. Okay, we divide a plane by 2 axes. This is a plane. Sir, what is a plane? This whole, this drawing that I'm making, na, this is a plane. The moment I keep my hand on this board, I am in the same plane. This is 2D. This whole is 2D. The moment I leave this pen and come over here, this is 3D. 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 Okay. Enough of dance. So now what we are saying? We are saying that okay. If we want to divide the 3D space, what do we need? We need a coordinate system. And how many axes would be sufficient to divide the 3D space completely? These 3 axes. Okay. People are saying going mad. Who is going mad? I'm going mad. See, these are the axes, X, Y, and Z axes. Okay. X, Y, and Z axes. That's cool. So now if I want to locate a point, let's say this is a point. So we need a reference now. So this is the 0, 0, 0. This is the origin. This is our reference. Okay. People are saying, please cover up to advanced level. In one day, you want every level to be covered. NEET, JEE means advanced. Everything should be covered in one session. That's cool. I like your confidence. Okay. But your confidence hurts me over here. Anyways, come here. This is the origin. And this is the point that we need to locate. Let's say point P. So how are we going to answer? We are going to say that this point is at some X distance along the X axis, some Y distance along the Y axis, Z distance along the Z axis. That means this point can be represented as X, Y, Z. Okay. That's cool. Now, apart from this, what can we do? You have seen the distance formula in 9th or 10th class. Okay. I hope you have attended the 9th and 10th class. Then you are over here. Now, some students, you know what they do? KG1, KG2, direct 11th. I have seen students like this. And after they come into 11th, they ask, sir, what is distance formula? We don't know. So what you have done in 9th and 10th class? Anyways, this is the origin. Let's say these are the 2 points. X1, Y1, Z1. X1, Y1, Z1. And this is what? This is X2, Y2, Z2. Okay. You want to find the separation between these 2 points. Okay. So what is the separation going to be? So let's find out the separation along the x-axis. Okay, what's the separation along the x-axis? That's going to be x2 minus x1. What's the separation along the x-axis? x2 minus x1. Similarly, what's the separation along the y-axis? y2 minus y1, z2 minus z1. Okay. Tell me one thing. That this point is simple. See, listen all of you. This is 3. This is 4. This is 3. This is 4. Okay. Or let's say this is a line. This is a line. This is 3. This is 4. What is this distance? What is this perpendicular distance? What it's going to be? What is this perpendicular distance going to be? Simply root over 4 square plus 3 square. Pythagoras theorem. We all know this, isn't it? Pythagoras theorem. That's going to be 5. Very good, Kanchan. Very good, Nanha Kachua. Oh my God. What is this name? Please write your original name. Okay. Very good, Kaushal. Very good, Vikas. Yeah, so what I was saying that in order to find the separation between these 2 points, what we can do, we can find out the distance formula. Now, what we have said that if we want to find out the separation, we need an origin. That's the reference. Okay. What is the reference? What is the origin? It's simply a fixed point which is convenient to you. You can take anything as the origin. That's up to you. Okay. X's or X's, we have seen that in order to divide the 3D space, we require 3 X's, X, Y, and Z. In order to divide a plane, you need 2 X's, X and Y. Now, if you want to locate a point, what you have said that, okay, if you are locating a point, simply what are you going to say? You're going to say that what is the location of that point along the X-axis? That's going to be X1. Okay. What is the location of that point along the Y-axis? That's going to be Y1. So that point P can be represented as x1 comma y1. Simple. If I talk about the distance between the 2 points, so what have you said? If I talk about the distance between the 2 points, then what can you say? You can say that, okay, sir, there is a point P, there is a point Q. What are the coordinates of point P? X1 comma y1 comma z1. What are the coordinates of point Q? X2 comma y2 comma z2. Okay, that's cool. So what is going to be the separation? Shrijan is asking my name for a long time. My name is Kshitij Kanik. Okay. So can I continue now? Mr. Shrijan Gupta. Okay, that's cool. Manik is giving the correct spelling of my name. Very good, Manik. Very few people write my correct spelling. Now you need to find out the separation between PQ. So what is going to be the separation between PQ? That's going to be root over, tell me quickly, x2 minus x1 the whole square plus y2 minus y1 the whole square plus what? Plus z2 minus z1 the z2 minus, this is under the complete root. Quickly write this. Basic discussion. Okay. What are we writing? Root over x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Okay, that's fine. Let's take the discussion ahead. Another important discussion that's coming today. Yeah, some of you are asking regarding the PYQs. So I have taken the questions, mixed PYQs of NEET as well as JEE mains. Okay. So come over here. Slope of a line. Now see, this is a very important concept because from the discussion of slope, we are going to discuss the differentiation. This is the starting of differentiation. Okay. This is the basic concept of differentiation, slope. So basically, what is the slope? See, let's say you have two paths. You have two slides. Slide number 1, slide number 2, and slide number 3. Okay. You are in a park. This is you standing over here. And you saw a small kid, a very small chotu. You asked the chotu that please come here. He was not coming. So what you did, you took that baby and you made him sit over here. Okay, you made that kiddo sit over here. And you asked that, are you scared of this slope? You asked him that what's happening, all well? He's saying, yeah, all well. No worries. After that, you made him, okay, you are not scared at this point. So what you said, let's sit at another slope. Let's go and sit at another slide. You made him sit at the slide number 2. Now ask that kid that, are you okay? Is everything fine? How is the life going on? He's a bit worried now. But still, the kid is courageous. He's saying that, no, I'm not worried. I'm not afraid. So you said, okay, you're still not afraid. So what you did, you held that kid and you made him sit over the slope number 3. Now what he is doing? He's shouting. He's calling his mother. Okay. So this is the third slide. So on which slide the kid was maximum afraid? Definitely slide number 3. Definitely slide number 3. That means the slope of slide number 3 is maximum, isn't it? The slope of slide number 3 is maximum. Clearly you can say that slope of 3 is greater than slope of 2, greater than slope of 1. After this, what happened? The mother of that kid came and then Sontu was afraid. This is Sontu. After this, Mr. Sontu was afraid. He ran. Okay. He's just running, something like this. So yeah, after this, it is very clear that yeah, the slope is nothing but the inclination. Now the question arises that how do we measure this slope? How do we measure this slope? Let's say you have two lines. This green line or whatever color it is, and this pink line. Okay, you have these two lines. Okay, line number 1, line number 2. So we say that the slope is simply the ratio of change in y coordinate. Listen very carefully. This is y axis. This is x axis. Okay. So if I go from one point to some other point, how much change in the x axis has been observed, corresponding to how much change in the y axis is observed. If I ask you that while going from point A to point B, while going from point A up till point B, this is B dash. Okay, this is B dash. This is line number 1, this is line number 2. If you walk delta x distance along the x axis, how much distance are you going to get covered along the y axis? In this situation, delta y1. In this situation, delta y2. Delta y1 is greater than delta y2, yes or no? The distance that you cover along the y-axis, let's say this is you. You go and stand on the line number 1. Go and stand on the line number 2. Okay, so you can clearly say that the distance traveled for same delta x along the delta y is greater in case of line number 2. So slope of 2 is greater than the slope of 1. And what is the slope? That's simply change in y coordinate divided by the change in x coordinate. I hope that this point is absolutely clear. Okay, so this is the slope. And now what we are going to study? We are going to study the differentiation. So basically, what is differentiation? What actually differentiation is? This is the instantaneous change along the x and y axis. Now there are two types of changes. Okay. See, this is a comparatively bigger change when I say about delta. When I make this symbol, this is delta. And this is d. Okay. So what this is differential operator. What it represents? This represents comparatively bigger change. This represents bigger change. And this represents smaller, very small, minute, instantaneous change. Okay, that means let's say you have a function. Now what is a function? Function is simply the variation between two phenomena. Try to understand that how much do we eat and how much our weight is gaining. It can be a function. You are eating 2 chapatis, your weight is 60 kg. You started eating 4 chapatis, 62 kg. Eat 8 chapatis, 70 kg. This is a function. How much are you studying? How much marks are you getting? Marks are directly proportional to study. It's a function. Okay. How much workout we do, how much body we make, how much body we build. Okay. This is again a function. Getting the point, all of you? So let's say you have a function. You have a variation of y and x. And the function is something like this. The function might be something like this, a random function, okay. So now you need to compare the minute change. This is the small change, very small change, okay. Very chotu change. You understand chotu change? So this is the chotu change, this is the babu change, not that Sona babu wala babu, small change, small, okay. This is delta x, and what is this? This is delta y. This is oh, what happened? This is delta y. This is what just happened? What happened? Just a second. Oh, yeah, this is delta y, okay. So simply you need to find out a small change, small ratio of change between y and x. So what we are going to write? We are going to write that the slope of this small part, zoom it, okay. What we are doing, we are zooming it. So when you zoom this now, then this small curve tends to be nearly a line. What are we doing? We are zooming it 1,000 times, 10,000 times, okay. Don't ask with which cell phone do you have this much powerful zoom. Just let's say you're zooming. So this part looks like this. This is the instantaneous change in x, and this over here is the instantaneous change in y. So you represent the slope, the instantaneous slope, as dy by dx, and this is read as differentiation of a function y with respect to x. This is read as the, how do we read this? We read it as the differentiation of a function y with respect to x. See, I said that the break would be given something nearly 7 p.m. okay, till we complete Newton's laws of motion. Okay, so manage your whole planning accordingly. Okay, so let's go. Now see, the point is, what is a function? Let's say this is y and this is x. If x is not changing, if y is not changing with x, that means for different values of x, you have same value of y. Is there some slope in this situation? Definitely no. So it's a constant function. What do we call it? We call it a constant function. This is constant, y is constant. But let's say you draw a line something like this, might be like this, or like this, or like this, or anyhow you draw it. So in all the situations, y is changing along with x. Y is changing along with x. Okay, getting the point? Yeah. So what are we saying? We are saying that if you want to find out the differentiation at any point, you can simply do dy by dx. Now some general differentiations. Quickly get started. Tell me, what is the differentiation of sin x? Cos x or minus cos x? Basic. I want to check your basics. Quickly answer it. Very good, very nice, that's great. This is simply cos x. What is the differentiation of cos x? Sin x or minus sin x? Basic discussion. But still some of you are going to give wrong answer. Very good, very nice answer, very good response. This is simply minus of sin x. Tan x, cot x, tan x. Yeah, definitely we can find out the differentiation of tan x. We'll be studying the method. You can find out by chain rule, you can find out by division rule. Okay, what's tan x going to be? What is cot x going to be? Complete the functions. Very good, all of you. Okay, tan x, some are saying the differentiation of tan x is cot x, and some are saying it's sec square x. Very good. Very nice. How many of you are saying? Some are saying sec x tan x, some are saying sec x, some are saying sec square x. Oh my god, quickly, what's the differentiation of tan x? Oh ho. If you face difficulty in finding the differentiation of tan x, what is basically tan? Tan is sin x upon cos x. See, no need to mug up. This is what happens when we mug up things. Okay, basic things we are facing difficulty. Okay, a lot of you have given the wrong answer of 10x, differentiation of 10x. So can we write 10x as sin x into cos x to the power minus 1? Just tell me, can I write this? Can I write this? Can I write this? Definitely yes. Definitely yes. So if I differentiate it, do we have two functions? Do we have two functions? Just keep on listening. Just keep on listening. Now we are going to apply product rule and then we are going to apply chain rule. Two rules at the same time. Okay. Two rules at the same time. Which two rules? Product rule and the product rule and the chain rule. So when I apply product rule, basically what is product rule? We have two, let's say there are two students in front of me, both want to study but different subject, different topics. So what I'm going to do, I'm going to teach one student. What the other student is going to do, he is going to sit and watch my face. Okay, then I'll teach this second student. What is the first student going to do? He is going to sit and watch my face. This is what's going to happen over here. If I differentiate sine, the first function, the differentiation of sine x is cos x. What is the other function going to do? That's going to sit and watch my face, isn't it? If I differentiate the second one, the first one is going to sit and watch my face. Now the question arises, what is going to be the differentiation of cos x to the power minus 1? What is going to be the differentiation of cos x to the power minus 1? Differentiate it. Now here we need to apply chain rule. Now quickly I'm telling you what is chain rule, although I'll be giving in detail. Just listen carefully what I'm saying. Who's the first function? Power is the first function. Who is the first function, students? Every single word is very important. Who is the first function? Power is the first function. Okay, so first function is the power. Differentiate the power. Differentiate the power. Now sir, what is the differentiation of general x to the power n? That's simply n into x to the power n minus 1. Are we aware about this? Are we aware about this? So what's going to be the differentiation of x square? 2x. What's going to be the differentiation of x to the power 10? 10 x to the power 9. What's going to be the differentiation of x to the power 100? 100 x to the power 99. What's going to be the differentiation of x to the power minus 1? Minus 1 x to the power minus 1 minus 1. Okay. Is this point very clear? Is this point very clear? Units and dimensions is coming. Target MBBS. Have some patience. Every single topic would be covered. Don't worry. Yeah. So if I say that you have to differentiate the power over here, this is going to be minus 1 bracket to the power minus 2. And who is inside the bracket? Cos x is inside the bracket. Now differentiate the inner function. Differentiate the inner function. What is the inner function? Cos x. The differentiation of cos x is going to be minus sin x. This minus gets plus. This is sin x. So what is the final differentiation? Final differentiation is sin x divided by cos x the whole square. Oh my god. That's cool. So the differentiation of cos x to the power minus 1 is sin x divided by cos x the whole square. And what is the sin x doing? Sitting and observing the face, just watching the face. He's got nothing to do. Okay, this first function has got nothing to do. Okay, so what is the result? My dear students, my lovely students, please tell me. Samiksha is saying speed up. Have patience, Samiksha. Cos and cos to the power minus 1 gets cancelled out. This is 1. This is sin square x divided by cos square x. So what are we left with? We are left with 1, that means cos square x plus sin square x divided by cos square x. That means 1 divided by cos square x. This is sec square x. I don't think that you're going to get confused in this again in your life. Okay, so I hope that this point is clear. Now simply you can fill up the table. Just remember the differentiation of log x is going to be 1 by x. Differentiation of e to the power x is going to be e to the power x. Okay, just fill up the rest of the table. This is a task for you. Okay, differentiate and actually find it out using this chain rule. Yeah, so here we go. Simple questions 1, 2 and 3 quickly. You can get the notes on the app. I have said this previously also. Quickly, the answer for the first question. All of you get started. The first question. y equal to x to the power 1 by 2. Root is x to the power 1 by 2. Quickly do this. What is it going to be? This is simply going to be dy by dx is 1 by 2 x to the power 1 by 2 minus 1. That means this is 1 by 2 root x. This is the answer. I hope that this point is absolutely clear. After this, the second question, keep on matching your answers. X to the power 5, y is simply x to the power 5 plus x to the power 4 plus 7. So differentiate it. What is dy by dx? What is dy by dx? That is 5 x to the power 4 plus 4 x to the power 3 plus the differentiation of constant is 0. That's cool. Do the third one. Third one. Target MBBS is saying basic aata hai, speed up. So what you can do, you can simply join the session after 2 hours. Okay, when I'll be teaching rotational motion. Okay, so I'm going to follow the roadmap that I have given, that I'm going to start from the basic and I'm going to conclude the whole discussion. If you feel comfortable, you can simply sit and observe the session and be a part of the session. Okay, just don't sit, give the answers. So y equal to x square plus 4x to the power minus 1 by 2 minus 3x to the power minus 2. So what is it going to be? dy by dx, what is it going to be? My dear students, quickly tell me. 2x plus this is going to be x to the power minus 1 by 2. Okay, so what is it? It is minus 2 x to the power minus 1 by 2 minus 1, that means minus 3 by 2. This is plus 6 x to the power minus 3. So these are the answers. I hope that this point is absolutely clear. So let's take the discussion ahead. Here we go. Another important concept that's coming in front of you is the concept of maxima and minima. So if you observe this curve that I have drawn over here, this yellow curve, so very clearly you can see that there are 2 points. On these points, one is the maximum, another is the minimum. So this is the point of maximum value. This is the point of maximum and this is the point of minimum. Isn't it? Yes. 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 Web, don't worry. I'm teaching from the basic. Even if you have not studied some chapter, you will be understanding. Okay, so just have patience. This is maximum, this is minimum. So it is very clear that at the point of maxima or minima, the slope is 0. What I am saying at maxima or minima, what is going to happen? The slope is going to be 0. Slope is going to be 0. Okay, that means dy by dx is 0. dy by dx is 0. dy by dx is 0. Okay, sir, that's cool, that's fine. dy by dx is 0. Now, how to figure it out? For both these points, the dy by dx is 0. So the question arises that for both these points, dy by dx is 0. So how to figure it out that who is maxima and who is minima? In order to figure it out, you need to do what? You need to double differentiate it. Okay. If the double differentiation at that point is greater than 0, it is a point of minima. Remember this. If the double differentiation is less than 0, it's a point of maxima. Clear? 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 Is this point very clear? Let's take the discussion ahead. So here we go. A simple question coming in front of you. Simple question coming in front of you. ABCD. Listen. For every question, there is +4 -1 marking for every MCQ. Okay, there is +4 -1 marking. See, I have taken some illustrations and some numericals. Okay, so the first numerical is coming in front of you. ABCD, just give the answer. At the end of the session, I'll be giving your scores and I'll be writing your name on the leaderboard. Okay, so 30 seconds for this question. Time starts now. 30 seconds for this question. All of you get started. Time starts now. Timer is not coming. No worries. I'm checking the time manually. Get started. No, Prathamesh, you cannot skip circular motion. It's a very important unit. Okay. Quick, all of you, be quick. Give the answer. A, B, C, D, A, B, C, D, A, B, C, D. Uh-oh. Okay. Anyways, timer is not coming. No worries. Last 5 seconds. 4, 3, 2, 1. And here we go. Time up. Time up. Time up. Time up. A lot of you are giving the answer as A. Let's check that what's the answer. Minimum value of this function, you need to figure it out. Okay, so what's the function? Function is y equals to 5x square minus 2x plus 1. So first of all, we know that the maxima and minima both have the same condition. That means the slope is 0. dy by dx equals to 0. So let's figure it out that what actually dy by dx is. So dy by dx is, this is nothing but 10x minus 2, make it equal to 0. So you got the point of maxima or minima. Now we don't know whether this point is the point of maxima or minima. So in order to figure it out, what we need to do? We need to again differentiate it. We again need to differentiate it. So let's differentiate it again. So if we differentiate it again, that means we find d2y by dx square. d2y. This is 10. This is positive. d2y by dx square is positive. That means what is this point? It's the point of minima. It's the point of minima. Okay. Now he's not asking you the point of minima. He is asking the minimum value. So in order to find out the minimum value, you need to substitute this value into the function. So substitute it. What do you get? You get y equals to 5 into 1 by 5 square. That means 1 by 25 minus 2 by 5 plus 1. So how much is it? This is 1 by 5 minus 2 by 5. That means minus 1 by 5. Okay. Minus, this is 1 by 5. Yeah. Minus 2 by 5. That means minus 1 by 5 plus 1. So how much is it? It's 4 by 5. It's 4 by 5. Lot of you just gave the answer of that point of minima. Okay. Listen, all of you. Lot of you gave the answer of the point of minima. He's asking the minimum value. Getting the mistake, all of you? Excuse me. Are you getting what I'm saying? All of you marked as A. So make it minus 1. All of you who did it wrong, make it minus 1. You gave the answer for the minima, point of minima, and he is asking the minimum value. Okay. So I have seen your responses. No need to do cheating. No one will cheat. Okay. So the answer is 4 by 5. That means C is the correct answer. Okay. So the minimum value of the function is at this point. This is the point of minima. I'm clearly writing this is the point of minima. Now see, a lot of students were saying, sir, please speed up. We know the basics. And they made the mistake in the very first question. Minus 1. Okay. So I don't want you to do this in your exam. Okay. Someone is asking 10 how? Where 10? Oh, this 10. Very good question. But your question is hurting me over here. It hurts me over here. Okay, listen. If this is 5x square, you need to differentiate it. Okay, you need to differentiate it. dy by dx, what is it going to be? It's going to be 5. The differentiation of 2x, x square is going to be 2x. Now the question is, what is 5 into 2? Very tough question. 5 ones of 5. 5 twos are 10. That's 10. So the answer is 10x. I hope that this point is absolutely clear. That's why we have a 10 over here. Okay. Let's take the discussion ahead. Here we go. Integration. It's simply the reverse operation of differentiation. In differentiation, what are we doing? We are differentiating a function. We are observing the small changes. And now in integration, what are we going to do? We are going to add up all these changes. That means if you talk about a function, okay, let's say this is a function. Let's say this is y, this is x. Okay, that's fine. This is y. x, and this is the function, something like this. Okay, so if I talk about a small change, that means if I talk about differentiation, the small change along the x or the y axis, okay, this represents the small change. Okay, that's fine. Now what am I asking you? What I'm asking you, that what happens if I add up, all these small changes, do I get the area under the curve? Do I get the area under the curve? If we add it up, do we get the area under the curve? Yes. So basically integration of a function. Integral of a function, this snake means integration. Okay, this is going to give you the area under the curve. This is going to give you the area under the curve. Now simply it's the reverse operation of differentiation. So what you have said in differentiation, the differentiation of x to the power n was n into x to the power n minus 1, isn't it? What it's going to be over here, this is simply see, x to the power n, the differentiation is n into x to the power n minus 1. Okay, if I ask you what's the differentiation of x square, what are you going to say? Quickly give me the answer. What's the differentiation of x square? What are you going to say? You're going to say that the differentiation is 2x. If I ask you what's the differentiation of x cube, what are you going to say? That the differentiation is 3x square. Yes, that's cool. Okay, but if I ask you what's the integration of x, if the differentiation of a is b, listen very carefully, if the differentiation of a is b, then the integration of b should be a. Okay, the real meaning, Shrijan Gupta is asking, the real meaning of differentiation is simply the calculation of slope. Listen now carefully, all of you. If the differentiation of a is b, the integration of b is again going to be a. Okay, so if you integrate b, you're going to get a. That means if I integrate x, it's going to give me what? X square by 2. It's going to give me what? It's going to give me x square by 2, isn't it? Divide it over there. Similarly, if I want the integration of x square, it's going to give me what? It's going to give me x cube by 3, because the differentiation of x cube is 3x square. So the integration of x square is going to be x cube by 3, isn't it? Yes or no? So the integral of x square is going to be what? It's going to be x cube by 3. So can I compare the general expression? If you integrate x to the power 1, you get x to the power 2 by 2. If I integrate x square, it gives us x cube by 3. If we integrate x to the power n, what it gives? It gives x to the power n plus 1 divided by n plus 1. Okay, that's cool. So let's take the discussion ahead. Here we go. Some basic integrations. X to the power n is simply x to the power n plus 1 divided by n plus 1. Now the differentiation of sin x is minus sin x is cos x. So the integration of sin x, that's going to be what? Plus a constant c. This is going to be plus a constant c. This is going to be plus a constant c. This is going to be plus a constant c. Okay, why? Because these are the differentiations. Let's take the discussion ahead. Now there are two types of integrations. Definite and indefinite integrations. Definite integral is the integral in which you have the limit. Try to understand. This is y, this is x. Okay, you have the limits. You know that from which point to which point are you going. You know that you are going from some initial point x1 to some final point x2. So this is going to give you the area under the curve. So you can say that the integral of x while going from where? x1 to x2. This is the definite integration. This is going to give you the definite integration. Okay, definite integral. A simple question coming in front of you. Read this question. Fast. Quick. Fast, all of you. What this question says, you need to integrate this function. Integral of x square minus cos x plus 1 upon x dx. So how many functions are there? There are 1, 2 and 3 functions in addition. So first of all, integration of x square is x cube divided by 3. Integral of cos x is sin x. Integral of cos x is sin x. So minus cos x is going to be minus as it is. Integral of cos x is simply sin x, and 1 by x is ln x plus c. This is the answer. This is the answer. How many of you got this question? How many of you got this question? Is this point absolutely clear? That's fine. Let's take the discussion ahead. We have seen that the definite integration gives you the area under the curve. Definite integration gives you the value of the area under the curve. So try this question. Plus 4 minus 1. Plus 4 minus 1. Quick. Quick. All of you. Quickly. Fast. ABCD, ABCD, ABCD. 30 seconds for this question. Time starts now. Begin. Time up. Time up. Let's see what you have done. Let's see what you have done. How many are getting plus 4? How many are getting minus 1? Keep on noting your score in your notebook, okay? Integration, first of all, do the integration, then substitute the limits. Okay, this is x square dx. That's fine. That's cool. So limits are from 1 to 5. So this is going to be what? This is going to be x cube divided by 3. And what are the limits? The limits are from 1 to 5. That's fine. So 1 by 3 upper limit 5 cube is 5 5s are 25. 25 into 5 125 minus 1 cube. 1 into 1 1 into 1 1. That's cool. So this is how much? This is 124 by 3. So the answer is B. Quickly do plus 4. All of you who have given the correct answer. Okay. The next question I am giving. Next question I am giving. Y equals to sine of theta. Okay. That's fine. You need to integrate this, or simply I'm giving the function. Integrate this from 0 to 2 pi. Okay, do this. Options A, B, C, D. 1, 2, minus 2, 0. A, B, C, D. 30 seconds for this question also. Plus 4 minus 1. Plus 4 minus 1. Plus 4 minus 1. Plus 4 minus 1. Okay, begin. All of you. Fast. Zai, 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 zai. All of you do this quickly. 5, 4, 3, 2, 1 and time up. Okay, that's fine. That's cool. The sine theta, first of all, the integration of sine theta is going to be what? Integration of sine theta is going to be what? That's going to be minus of cos theta. That's fine. Limits 0 to 2 pi. 0 to 2 pi. So minus, take the minus outside. Okay, this is going to be cos of upper limit minus cos of lower limit. Okay, that's fine. So what is it going to be? What is the value of cos 2 pi? 2 pi is 360. What is 360? What is 360? Cos 360. Quickly, how much is it? That's 1 minus 1. So how much is going to be the answer? That's 0. So how many of you gave it D? This is correct. Now, is it justifying the discussion? That means the area under the curve should be 0. Is the area under the curve going to be 0? See, this is the function of sine. This is 0. This is 180 and this is 360. So if you compare the total area, from 0 to 360, this is going to be the answer. This is going to be the answer. So just write your marks, +4 -1, whatever you're getting. Let's take the discussion ahead. Okay, let's take the discussion ahead. Now we are beginning with the discussion of vectors. Basically what vectors are. See, we divide the fundamental quantities as a scalar and vector. Okay, so basically what are the scalar quantities? Scalar quantities are the quantities which do not have the magnitude. What do they have? They which do not have the direction. They simply have the magnitude. Scalar quantities have magnitude. Scalar quantities do not have direction. Okay, they do not obey vector laws. Vector laws. So what are the vector quantities going to be? Simply they have magnitude, they have direction, and they are going to obey the vector laws. Okay, that's fine, that's cool. We are going to apply this basic mathematics right now in the kinematics. The differentiation, integration, vectors, everything is going to get applied. If I ask you some examples of these scalar quantities, mass, volume, density, apart from this, work done, isn't it? N number of examples you can give. If I ask you some examples of vector quantities, distance, okay, here displacement, velocity, acceleration, force, torque, momentum, angular momentum, n number of examples you can give regarding the vector quantities. Okay, so first of all, how do we represent a vector quantity? Any vector quantity is represented by this arrow. Any vector quantity is represented with this arrow. Okay, that we have drawn something like this. So what are the specialties of a vector quantity? A vector quantity has magnitude, it has direction, and it obeys the vector law. Keep on writing. It has magnitude, direction, and obeys the vector laws of addition. Okay, what are the different type of vectors do we know? Parallel vectors. Parallel vectors, if the vectors are something like this, let's say this is A, this is B, no matter they are equal or not, they should be along the same direction. They should be along the same direction. Okay, so if they are along the same direction, they are parallel vector. Now I am taking it a bit faster. Okay, equal vector, simply they should be in same direction, they should have the same magnitude. Anti-parallel vector, opposite directions. Anti-parallel vectors, opposite directions. Negative vector or simply opposite vector, equal magnitude, opposite direction. This is A, this is A, this is minus A. This is the opposite vector. Simple. Let's take the discussion ahead. Okay, co-initial vector which have the same point of initiation. These are the co-initial vector. Co-linear vectors drawn along the same line. Co-planar vector, every vector that I draw along this plane, these are coplanar which share the same plane. Okay, is this point very clear? Concurrent vector passing through the same point. Okay, so let's take the discussion ahead. This is a repeated slide. This is the repeated slide. So here we go. Null vector, basic discussion. So I'm taking it a bit quickly so that we can do some more questions. Null vector or a zero vector, simply which has the magnitude to be 0. Unit vector is a very important discussion. Basically, what is unit vector? This is unit vector. How do we represent it? We represent it by a cap. We represent it with a cap. What is a cap? Listen very carefully. Keep on writing. This is vector divided by its own magnitude. So what it represents? It represents the direction. What it represents? It represents the direction. Okay, of the vector. That's fine. Okay, if I give you simple example that find out the unit vector, let's say this is the vector A, equals to 3 I cap plus 4 j cap. What is going to be the unit vector? You're going to ask, sir, what is unit vector? This is the unit vector. Vector divided by its magnitude. How much is going to be the magnitude? How much is going to be the magnitude? The magnitude is going to be root over 3 square plus 4 square, that's 5. So this is 3 by 5 I cap plus 4 by 5 j cap. This is the unit vector. So the question arises that is it actually having a magnitude of unity? Is this vector actually having a magnitude of unity? Yes, definitely yes. Check it. Root over 3 by 5 the whole square plus 4 by 5 the whole square. Calculate this, you're going to get it as 1. I hope that this point is absolutely clear. Okay. So apart from this, we also have axial vectors. Now see, if you talk about omega, alpha, torque, theta, these are the axial vectors. Let's say if you rotate this rod, this is a rod, and you are rotating this rod along the anti-clockwise direction. Okay, so the angular displacement is axial vector. What's the direction? In order to find the direction, use your right hand. In order to find the direction, use your right hand. You're going like this. This thumb is going to give you the direction of axial vectors. Okay, so which rule you need to obey in order to find out the direction for every one of them? Right hand palm rule. Okay, right hand palm rule. What you need to do, simply curl your fingers. Let's say this is the direction. The body is rotating something like this, okay, in this direction. So what you're going to do, you're going to do something like this. This thumb represents the direction which is going to be inside. So what are the symbols for inside and outside? This dot and this cross. Just remember a train. Okay, if the train is going in, you see a cross. If the train is going in, you see a cross. If the train is coming towards you, that means along the station. If you're standing on the station, you observe a train that's coming, you're going to observe the light of that train. That means dot. So this is out and this is in. Okay, so I hope that this point is absolutely clear. Okay, now what's the basic difference between a scalar quantity and a vector quantity? That if you do 2 plus 2, it's going to give you 4. This is the scalar addition. But if you do 2 plus 2 in vector, it can give you 0 also. It can give you minus 4. It can give you plus 4. That means if this is a box, I applied a force of 2 Newton along the right direction and I applied a force of 2 Newton along the left direction. So how much is the net force in this situation? How much is going to be the net force? It is 0. If in the same situation, I change the direction of the forces and I make it something like this. This is 2, this is 2. So how much is the F net in this situation going to be? This is going to be 4 Newton. If I change the direction backward, it's going to be minus 4 Newton. That means 2 vectors can be maximum A plus B, minimum A minus B. Okay, remember this thing. How do we add 2 vectors? We add 2 vectors tail to tail. First of all, join them tail to tail. What am I writing? Tail to tail. Okay, you have joined them tail to tail. So when you join them tail to tail, you can discuss about the angle. After that, the resultant that you're talking about, listen everyone, the resultant that you're talking about is going to be this. How do we find out the resultant? With the parallelogram law. So just complete this figure, make some construction. This is going to be, if this is theta, listen, if this is theta, let's draw a separate figure. Let's draw a separate figure for this. Okay, quickly I'm doing this. This is A, this is B. Okay, the angle between A and B, theta. The resultant over here, this orange line represents the resultant. That's fine. So what is the resultant? Let's say this angle over here is alpha or phi, whatever you want to write, you can write it. Okay, this is resultant, this is A and this is B. So just do the required construction, something like this. Okay, something like this. Okay, so if this angle is theta, this angle is theta. If this is B, this dotted line is B. This is B cos of theta. This is B sine of theta. Okay, Now, if you apply Pythagoras theorem between these three dots, let's call it as P, Q, R. So you are going to get the resultant vector as root over A square plus B square plus 2AB cos of theta. Simple. Okay. Simple. Clear? Okay. That's cool. Now the question arises that what can be the maximum value if A and B are equal? Let's say if A and B are equal, take them equal to some A or X. Okay. Take it as X. So how much is it going to be? How much is the resultant going to be? It's going to be root over A square plus A square, 2A square plus 2A square times of cos theta. Okay. Take A square as common. Take A square as common. So what do you get? What do you get? You get A root 2 bracket root over 1 plus cos theta. No need to mug up the formula like this. No need to mug up the formula like this. This is the expression in front of you. This is the expression in front of you. If you talk about the maximum value, okay, what is going to be the maximum value? It's going to be maximum, first of all, when the angle is maximum, cos of that angle is maximum. That means cos 0 equal to 1. So maximum value turns out to be A plus B. Maximum value turns out to be A plus B. If you talk about the minimum value, what the minimum value is going to be? Can I write A? Min is simply going to be A minus B. If the vectors are equal, so A minus B equal to 0. That means it's going to be minimum, it's going to be 0 when the vectors are equal. If A is here, B is here, net 0. Okay. Let's take the discussion ahead. Okay. See, if you take the vectors in cyclic order, might be something like this. A plus B plus C plus D plus E. The net is going to be always 0. That means in a polygon, if all the vectors are taken in the same order, then the resultant is going to be something like this. That's going to be 0. Vector subtraction does not follow the commutative law. That means A minus B does not equal to B minus A. Vector subtraction does not follow the associative law. A minus B minus C does not equal to A minus B minus C. Just remember this. Okay, and this expression I have given you for equal vectors. This is going to be 2 times of, see, this discussion that we were having over here. The discussion that we were having over here, this is going to be 2 times of A square bracket root over 1 plus cos theta. And if you apply the expression for 1 plus cos theta, you get sine square theta by 2. Okay. Just basic points that you need to know. Let's take the discussion ahead. The rectangular components of a vector. You want to express the position vector. Let's say this is a point x comma y comma z. How are you going to express? Let's say this is the point. How are you going to express? You're going to say that the point is along x1 distance along the x-axis, y1 distance along the y-axis, z1 distance along the z-axis. So how do we write in form of vector? We write that if this is a position vector r, it's going to be root over x1 square plus y1 square plus z1 square. Sorry. This is the magnitude of r. And what is the vector form going to be? That's going to be x1 I cap plus y1 j cap plus z1 k cap. Okay, that's fine. Is this point very clear? Okay, so let's take the discussion ahead. Multiplication of a vector. So first of all, let's talk about the multiplication of vector. So how many products do we know? We know 2 products. Okay, just a second. If I have a vector A, all of you, are you alert? Are you listening? All of you? Listen. If I have a vector A, I multiply it by a constant. Let's say I multiplied it by x or lambda, some constant. If you multiply a vector by a constant, what happens? If this is A, is it 2A? Definitely yes. If I multiply it by 3, is it going to be 3 times of A? Definitely yes. That means the magnitude gets multiplied by that constant. Simple. If I divide a vector by a constant, its magnitude gets divided by that much times. Direction remains same. Simple, isn't it? That means if you have a vector, for example, 2i cap plus 3j cap minus k cap, I'm multiplying it with some lambda. Lambda is a constant. So what is going to be lambda times of A? It's going to be 2 lambda I cap plus 3 lambda j cap minus lambda k cap. Simple. This is what it's saying. Okay. So let's take the discussion ahead. Scalar product of two vectors. What's going to be the scalar product? Quickly. The scalar product is also what we call as the dot product. So if you have a vector A, that's, first of all, let's write the expression. You're doing A dot B. So what is it going to be? It's going to be mod A, mod B, cos of the angle between the two vectors. Okay. That means if this is A and this is B, listen, this is A and this is B, this is the angle between the two. This is the expression for A dot B. Let's take an example. Quickly do this and give me the answer. I am giving A as 2i minus 3j plus k, and let's say B in front of you, B vector in front of you is 3i minus j plus k. Quickly, what's A dot B? What is A dot B? What is A dot B? Be fast, all of you. Be quick. Fast. How much is it going to be? First of all, if I talk about I dot I, it's 1 into cos of 0. That means it's going to be 1. Similarly, J dot J1. But if I talk about I dot J, so how much is it going to be? It's going to be 0. If I talk about I dot K, so how much it's going to be? It's going to be 0. So simply if you need to do this, multiply 2 with 3. It's how much? It's 6 plus 3 plus 1. That means the answer is going to be 10. So I hope that A dot B is absolutely clear. This is how we figure it out. Okay. So let's take the discussion ahead. Some important points. Just go through these points. I'm going to tell you the cross product. Okay. So what is going to be the cross product? Cross product. This is the vector product. This is basically the vector product. Before getting into the cross product, I want to check that how much aware are you about the directionalities. If this is A, this is B, give me the direction of A cross B. All of you. I'm giving some more examples. Okay. A is inside or A is outside and B is over here. Okay. In this situation, you need to give the direction. Case 1, case 2 and case 3. This is A and this is B. Okay. For case number 1, give me the direction. For case number 2, give me the direction. Case number 3, tell the direction of A cross B. What is the direction of? What is the direction of A cross B in the first situation? Quickly, all of you. What is the direction of A cross B? Nimble Physics is saying outside the plane. Sushma Yadav is saying outwards. Vimal is saying 10. I'm asking you the direction. I'm asking you about the directionality in the first situation. All of you tell me the direction. What's going to be the direction in the first case? Outwards. How do we figure it out? This is A and this is B. So do A cross B. Simply A cross B is what it is? It is outwards. That's fine. If I do this, this is A. See, this is A. A is where? A is outside. A is outside. A cross B. Open your finger. Open your finger along the A. A is outside. This is A. This is A. So A cross B. A cross B is where? A cross B is here. Okay, this is the direction of A cross B. This is the direction of A cross B. This is the direction of A cross B. Open your fingers along the direction of A and close it. Open your fingers along the direction of A and close it. Open your fingers along the direction of A and close it along B. Thumb gives you the direction of A cross B. In the third situation, A is inside. In the third situation, A is inside. Quickly, what is the direction of A cross B? In the third situation, A is inside. A cross B. A cross B. What is it going to be? What is it going to be? It's going to be something like this. This is the direction of A cross B. This is the direction of A cross B. I hope that this point is absolutely clear. Let's take the discussion ahead. How do we figure out the value of a cross product? How do we find out the value of cross product? Just a second. If we try to figure out the value of cross product, A cross B, let's do it with an example. What you need to do, you need to make the determinant method. Okay, you need to apply the determinant method, I minus j and k. Let's say A is, tell me any value. Tell me any value for A. What is the value for A? Let's say 3i minus j plus k, and B, whatever you want to tell me, this is 2i. How much? Minus j. Minus j. Minus j we have taken, let's take it plus j plus 2k. Okay. So how much is it going to be? This is going to be 3 minus 1, 1, 2, 1, 2. Isn't it? Yes. 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 Now what do? We take the cross product. We take the cross product. We need to find out A cross B. Okay. So first of all, make a line like this. That's fine. So this is going to be the discussion along the I cap. This is going to be the discussion along the I cap. So what it's going to be? Cross product minus the cross product. Minus 1 into 2. That is minus 2. Minus 1. That's fine. Okay. After this minus j. After this minus j. Make a line along the j. This is 3 into 2, 6. Minus 2. That's fine. Make a line along k. Okay. Discussion along k. Okay. So it's going to be 3 1s are 3. Minus 2. That means plus 2. So this is going to be the answer. This is going to be the answer. Cool. Very good. Very good, Kaushal. Very good, Ramesh. Very good. Very good. Very good. All of you. Let's take the discussion ahead. After this, we need to understand the projection of a vector. Okay. The projection of a vector on some other vector. You're talking about the projection of A. You're talking about the projection of A on B. Tell me one thing. That if this is a cylinder, or if this is a pen, okay, what is the projection of this pen going to be? What is the projection of this pen going to be? It's going to be a straight line. Try to understand. If I ask you about the projection of this pen, it's going to be a straight line. Okay, this is the projection. If I keep on tilting the pen, something like this, is the projection going to decrease? Is the length of this line going to decrease? Isn't it? I have tilted it something like this, so the length has decreased. What if I tilt the pen completely horizontal, something like this? Is it going to be a point? Is it going to be a point? Yes. That means it's nothing but the shadow. It's nothing but the shadow of A on B. It's nothing but the shadow of whom? Shadow of A. On whom? On B. Yes. It's the shadow of A on B. So how do we figure out the shadow of A? This is A. This is A cos of theta. If this is A, this is A cos of theta. The projection is the value of a vector along some other vector. Value of this vector along some other vector. So how do we represent it? We represent it as A dot B cap. Okay, this is A dot B cap. This is the projection of A on B. How much is it? It is A cos theta. It is A cos theta along the direction of B cap. Along the direction of B cap. Okay, is this point very clear? So what do we write? We write it as A dot B cap. This is the projection of a vector on some other vector. Simple. Projection is what? Projection is simply the shadow. Projection is simply the shadow. If this is the pen, this is the projection. Let's say this is the projection. Okay. I keep on tilting this pen, the shadow keeps on decreasing. The shadow that's going to be formed on the screen, that's going to decrease. And if you make the pen exactly like this and you project the light from the front, it's going to be a point size. Similarly, if you observe it, let's say you're throwing the light from top. This is the light which you're throwing from the top. This is the light that you're throwing from the top. Okay, the light you're throwing from the top, and this is the shadow. And this is the shadow. So how much is the magnitude of shadow? A cos theta. What is the direction of shadow? B cap. So this is the projection. This is the projection of whom? Of A. On whom? On B. Projection of A on B. I hope that this point is absolutely clear. Okay. Let's take the discussion ahead. Some examples of the cross product are the torque, which is the vector, R cross F, angular momentum, R cross P, velocity, omega cross R, angular acceleration. Okay, we'll be understanding these topics separately in the individual units. Just now for your knowledge, for your basic knowledge, you should know that these are all vector quantities, and these are the applications. These are the applications of the vectors. Now let's do a question on this. Let's do a question on vectors. Here we go. A simple question. Do this quickly. 45 seconds for this question. Okay. 45 seconds for this question. Begin. Start. It's not a +4 -1 question. It's a simple illustration that you need to do and find out the answer. Do this fast, all of you. Quick. Okay. Fast. Last 5, 4, 3, 2, 1, and here we go. Time up. What the question is saying? The question says that a force is inclined at an angle of 60 degree. A force F is inclined at an angle of 60 degree. Okay, this is theta from the horizontal. The horizontal component of force, that means Fx, is 40 Newton. What you need to find out? You need to find out the vertical component. That means you need to find out Fy. You need to find out Fy. That means F sine of theta. That's fine. Let's figure it out that how much is F. Can we write Fx? Can we write Fx is nothing but F cos of theta. And this has been given to you as 40. So F is going to be 40 divided by cos of theta. That means cos of 60. Cos 60 is how much? Cos 60 is 1/2. So F is 80 Newton. The force is 80 Newton. Now what you need to find out? You need to find out the y component. So y component is going to be F sine of theta. That means it's going to be 80 into sine of how much? Sine of 60. Sine 60 is √3/2. So the answer is 40√3. Okay, Samarth, Bhavirthra, Sushma has given wrong answer. Nimble, wrong answer. Please be alert. Please be attentive in the class. You're making silly mistakes in these questions. Okay, what are you doing? Nanna Kachua, what are you doing? Okay. Prachi, very good. Okay, simple question. It was a very simple question. Okay, so all of you who have got the correct answer, take it as +4. All of you have given the wrong answer, mark it as -1. Okay. Let's take the discussion ahead. So here we go. We are discussing error. Basically, what actually error is. Error is the mistake that we do due to which we get a difference between the true value and the measured value. Let's say I'm measuring the length of this pen. This is 4.2 exactly this is 4.2 centimeter, for example, but somehow I measured it as 4.35 centimeter or 4.28 centimeter. That means there is a difference. there is a difference between the true value, and the measured value. There is some difference between the true value and the measured value. Okay, measured value. So this is what we term as the error. This is what we call as the error. Now, what are the reasons for error? What are the different types of error that we know? Instrumental error, environmental error, observational error. Instrumental error is simply the error that is caused due to the faulty instrument. That means you're measuring with a scale and the scale itself is faulty. Scale is not appropriate. Okay. So if there is imperfect design of the instrument, then this is going to be instrumental. Environmental is going to the change in the environmental condition that occur. Let's say yesterday you were doing some experiment, then the temperature was different. Today the temperature is different. There are going to be differences in certain parameters. Okay. So the difference or the error caused due to environmental conditions is what we call as the environmental error. What it includes: pressure, humidity, dust, vibrations, or magnetic and electrostatic fields. Okay. Observational error, that we didn't pay attention while observing. Human error due to lack of concentration. Okay. So these are the observational errors. First of all, the representation of error. The first and the very basic form of error is called the absolute error. Okay. So this is the difference between the true and the individual measured value. See, let's say if your weight is, how much is your weight? How much is your weight? Tell me, all of you, how much is your weight? 60 kg, 55 kg, 80 kg, 70 kg, whatever the weight is. One day you just went to that weighing machine and you observed that this is, let's say I am 70 kg. I'm just standing on the weighing machine and this is giving 65. So what am I going to do? I'm going to get out and I'm going to step in again. That means we are going to take n number of readings. If we are not satisfied with one reading, what are we going to do? What are we going to do? We are going to take n number of readings. We are going to take n number of readings. Let's say my weight is, someone of you said that your weight is 60 kg. Okay, everyone is giving their weight. Okay, so let's say someone's weight is 60 kg, but you just went and you took your reading and that's not 60. So what you're going to do? You're going to take what? N number of readings as A1, A2, A3, A4. Now the question arises that which is our actual reading? Question arises that which actually is our true reading. So what are we going to take? We are going to take the mean of these readings. We are going to take the mean of these readings. Okay. Let's say your readings are 60, 60.2, 58.8 and so on. N number of readings. And let's say the mean for these readings turned out to be 60.3. I'm just giving a rough example. Okay. Let's say the mean is 60.3 kg. Okay. So the absolute error in the first reading is 60 minus 60.3 with a mod. Absolute error in the second reading is 60.3 minus 60.2 with a mod. 60.3 minus 58.8 with a mod. Are you getting the concept? Are you getting the point, all of you? What am I trying to say? So the difference between the true value and the mean value is simply what we call as the absolute error. This is what we call as the absolute error. Okay. These are the individual absolute errors. Okay. These are the individual absolute errors or the absolute errors in the individual readings. Okay. Cool. Hello, Yogin Parmar. Hello. Focus over here. Yeah. After this, you have n number of absolute errors. So what are you going to take? You're going to take the mean of these absolute errors. So you need to take the mean of all these absolute errors. This is what you're going to term as the mean absolute error. Mean of absolute error. Mean absolute error. Simple. Okay. Arithmetic mean of all the absolute errors is defined as the mean absolute error. Take the mean of all these readings divided by n. Mean absolute error. Simple. Okay. So how do we represent the true reading? The true reading can be represented as the faulty value that has been given to you plus minus the mean of the absolute error. This is how we represent. I'm going to say that my weight is 60 kg plus minus something. What is this something? That something is the mean absolute error. Okay. Sir, how will we know true value for something if? See, the value that has been provided to you. Someone would say that this is the value with some error. Now you need to figure out that what is the error in that particular reading, how much it can be. This is what we are trying to figure out, okay? This is how we represent the reading along with the error. Now the relative error is simply the mean absolute error divided by the mean reading. This is relative error. If you want to find out percentage error, so simply multiply it by 100. This is going to give you percentage error. So relative or fractional error is simply delta A by A. Percentage error is delta A by A into 100. What I have written? I have written that if this is reading, if these are the readings A1, A2, A3 up till AN, AM is going to give you the mean value. AM is going to give you the mean value. That's cool. Okay. Then what you're going to find out? You're going to find out individual absolute errors. What are they going to be? These are the individual absolute errors. These are the individual absolute errors. Okay, that's fine. Okay, that's fine. Up till delta AN. Okay, this is AN minus AM. Okay, that's fine. After this, what are you going to do? After this, what are you going to do? You're going to find out the mean of absolute errors. You're going to find out the mean of absolute errors. That means delta AM. What is mean of absolute errors? The sum of all the individual absolute error, okay, divided by n. After this, what we did? After this we found the relative error, delta AM by M. This is the relative error, and if you multiply it by 100, this is simply what? This is simply the percentage error. So the general formula that comes in front of you, is something like this, that let's say this is the quantity depending upon A to the power M, B to the power N, and C to the power, let's say, LMNOP, P. So delta X by X is going to be what? That's going to be M times delta A by A plus N times delta B by B plus P times delta C by C. Okay. Or let's say this is the quantity A to the power P, B to the power Q, C to the power R. So this is the general formula coming in front of you. So on the basis of this, let's try a numerical. Let's try a simple numerical based on this. ABCD plus 4 minus 1 plus 4 minus 1. Right now I gave you the formula. This is the expression in front of you. Do this quick. Fast. 45 seconds. 45 seconds for this question. Quickly. Begin. A, B, C, D. Fast, all of you. Quick. Plus 4 minus 1. Time up. What the expression has been given to you? A to the power 4, B to the power 1 by 3 divided by C to the power 1, D to the power 3 by 2. So what expression we have seen? We have seen that the powers come in multiplication. Along with the fractional errors. That means it's going to be 4 times of delta A by A plus 1 by 3 times of delta B by B plus 1 times of delta C by C plus 3 by 2 times of delta D by D. That means what's going to be the answer? This is going to be the answer? Yes, this is the answer. A is the answer. All of you who gave the correct answer, mark it as plus 4. Next question coming in front of you, again corresponding to plus 4 and minus 1. Quick. Again. 45 seconds for this question. Begin. 45 seconds for this question. All of you be quick. +4 -1 should be your marking. Fast. Quick, 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 quick. All of you. Yes, Adrika, we have included concepts and even questions from NCERT, Exemplar, which are the numericals that we take, the MCQs. Okay, NCERT Exemplar, a very good book it is for every exam. Yeah, so what the question was that the percentage error in the measurement of mass, that means delta M by M into 100, it's how much? That's 2%. And the measurement of speed, that means delta V by V into 100 is 3%. Okay, that's fine. What you need to figure out? You need to figure out the error in estimation of kinetic energy. What's kinetic energy? Kinetic energy is half of m v square. That means delta ke by ke into 100 equals to delta m by m into 100 plus 2 times of delta v by v into 100. That means the percentage error in kinetic energy equals the percentage error in mass plus twice the percentage error in volume. That means it's going to be percentage error in mass 2% plus 2 times of how much it is? How much it is? This is 3. So 3 to the 6. 6 plus 2, that means 8. So the answer is D. How many of you get the correct answer? Add +4 to your scores. Add +4 to your scores. And here we go, here we go, here we go. Lap 1 is completed. Lap 2 we are beginning. Let's begin with the kinematics. Okay. So this is you who is running, completed 1 lap. And now we are starting this lap number 2. Kinematics. So basically what is kinematics? Kinematics is the branch of physics in which we deal with motion without getting into the cause of motion, What is the cause of motion? This basic definition is very important because it tells us that we are not going to discuss about the force. We are going to discuss only the motion. So we are not concerned that whether the object we are talking about, is it a point object or is it a train or is it a bus or is it a bird? That makes no difference to us. Okay. Yeah. So in order to discuss kinematic, we need to discuss the kinematic parameters. Okay. Quickly, we'll be seeing the kinematic parameters. If you want to discuss a language, if you want to study a language, what do? You understand the basics. Okay. The alphabets. Similarly, if you want to study kinematics, you want to study the basic. What are the basics? The kinematic parameters. Vernier caliper, screw gauge, units and dimensions we'll be covering at the end. Don't worry. Okay, we have added that. Vernier caliper, screw gauge, units and dimensions, law of homogeneity, everything we have added. Okay, that is in the session. Don't worry. Now what I was saying, I was talking about the kinematic parameters. Okay, so what are the kinematic parameters? There are 6 kinematic parameters. Distance, displacement, speed, velocity, acceleration, and time. We can discuss the whole kinematics by studying these 6 parameters. If we are very pro with these 6 parameters, we can discuss the complete kinematics. Now what we need to do, we need to study the 1D and 2D motion separately. So let's get started. First of all, we need a frame of reference. If I ask you that this is your friend Sontu standing over here, is he at rest or motion? Give me your answer. Rest or motion? You are observing from your frame. Only. Is this person at rest or at motion? What can you say? If I am standing over here, am I at rest or motion? We cannot give this answer because this would be an absurd statement. Why? Because we need to understand that with respect to whom are you talking? With respect to whom are we talking? Let's say there is some friend of Mr. Sontu. Let's say this is Montu, friend of Sontu. Who is he? Mr. Montu. Okay. So what is he doing? He is standing and observing Sontu. Both are at rest. So this is at rest. But there is a person who is going in this beautiful car. Okay. Something like this, standing like this. Okay. And the car is moving. Now this person observes Mr. Sontu. Definitely the answer is not going to be the same. Okay, that means we need to be very clear that with respect to whom are we talking, with respect to whom are we discussing. Okay, so we need a concept of frame of reference in order to discuss that with respect to whom are we discussing. So there are basically there's nothing like rest or motion unless and until we discuss that with respect to what frame are you talking. So if you want to discuss the motion and rest, you need first of all the first requirement. The first requirement is a set of reference, is a set of origin. Let's say this is your set of reference. Okay, you said that this is my frame of reference, and this is a stationary frame of reference. So now if a person changes his or her coordinates from the coordinate A to some coordinate B, you say that there is some change in the coordinate. That means there is motion. Now this motion can either be 1D, that means a straight line motion. It can be 2D. This is 1D, this is 2D, and this is 3D, and this is 3D. Okay, this is 1D. Just a second. Is this line 1D or 2D? All of you, just a second. Is this line that I'm drawing, this white line, is 1D or 2D? All of you, is it 1D or is it 2D? Very basic question. Is this white line 1D or 2D? All of you. Some are saying 1D, some are saying 2D. Quickly, all of you. Prachi, Rahul, Kaushal, Rakshita. Got the question? That if this is the white line, you are going along the white line. If some person starts walking along this white line, so he is following what kind of motion? 1D motion or 2D motion? 1D motion or 2D motion? This person is going along this white line. This person. 1D or 2D? 1D or 2D? 1D or 2D? 1D or 2D? Tell me quickly. Oh ho 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 ho. Oh ho 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 ho. All of you are giving the wrong answer. All of you are giving the wrong answer. This is 1D motion. This is 1D motion. I have clearly represented the 2D motion as a curve. This is a 2D motion. This is a 2D motion. This is a 2D motion. Till the moment you are moving along the same line, no matter along which direction, it's 1D motion. Now this is 3D motion. Don't get confused. Okay. If you say that this is 1D, this is 2D motion. If you say that this is 2D motion, I simply change the frame of reference. I simply change the axis. If I simply tilt the axis from this to this, your answer is going to change. If I change the axis from this system to system number 2, now you're going along this, the y value remains same. You're going to say, sir, this is not 2D. This is not 2D, this is 1D. Your answer cannot depend upon the choice of axis. Remember one thing, if you're along the straight line, your answer is 1D. If you move along a curve, 2D, and 3 coordinates are required, that's simply 3D. Okay. So first discussion that we are having is distance versus displacement. Quickly give me the definition of distance. Quickly give me the definition of distance. It's the actual path. It's the actual path that you take between 2 points. It's the actual path that you take between 2 points. Okay. Now see, this is Mr. Sontu. Again, Sontu came. He wants to reach some point starting from A. Okay. This is 3. This is 4. How much is the distance in this situation? How much is the distance, the actual path in this situation? That's going to be 3 plus 4. That's going to be 7. That's fine. That's cool. Okay. But if you talk about a condition, this is Mr. Sontu standing at point A. He want to reach the point B because some of his friend is standing at point B. Okay, this is Shinty standing at point B. Oh, is he going to follow is he going to follow this path? Definitely no. Why? He is going to follow this path. He is not going to follow the actual path. He is going to follow the shortest path. He is going to apply the concept of displacement. That means something like this, okay? Reaching this point fast. So this is the concept of displacement, okay? You're never going to forget the concept of displacement now. So how much is it? How much is this displacement? The displacement is going to be root over 3 square plus 4 square. This is going to be 5. Okay, sir. Okay, so displacement is always lesser than, or at most it can be equal to the distance. That's something that we know. Distance is a scalar quantity while the displacement is a vector quantity. Distance depends on the path while displacement is independent of the path. It depends only on the initial and final positions. Yes, we know. For a moving body, distance cannot have 0 or negative values. The displacement can have any value. 0, positive, negative. Okay. If the path is a straight line without change in direction, then the magnitude of distance and displacement are same. We know this. Okay. Okay. So let's do a simple question on distance and displacement. Quickly, you have to give the answer. Plus 4 minus 1. Plus 4 minus 1. Question. Fast. Draw this. This is a circle. Okay. Starting from point A. Okay. Starting from point A. A person starts from point A, reaches point C. Reaches the point C. Starting from A, the person reaches the point B, C, D. Okay. Find the ratio of distance and displacement. Find the ratio of distance and displacement. Find the ratio of distance and displacement. Fast. Okay. Quick. You need to find out the ratio of distance and displacement. How much is going to be the distance? This much. How much is going to be the displacement? This much. So let's figure out the distance. Quickly, all of you. Fast. How much is the distance? The distance is going to be, is this distance 3/4 of the circumference? Is this distance 3/4 of the circumference? So can I write the distance is nothing but 3/4 times of 2 pi r? Can I write this? Please tell me quickly. Yes or no? Is this displacement, is this white line representing the displacement? Is this line representing the displacement? Yes, sir. So how much is the displacement? This is r. This is r. So is the displacement root 2 times of r? Is the displacement root 2 times of r? Yes or no? Definitely. Yes or no? Definitely. So what's the ratio of distances to displacement? Find out the ratio of distances to displacement. This is simply 3/2 times of pi r divided by root 2 r. So the answer, the ratio of distances to displacement is going to be 3 pi r by 2 root 2 r. This is going to be 3 pi by 2 root 2. 3 pi by 2 root 2, 2 root 2, 2 root 2, 3 pi by 2 root 2, 2 root 2, 2 root 2. Okay. I hope that this point is absolutely clear. Very good. Next question that I'm giving you, corresponding to plus 4 minus 1. Plus 4 minus 1. Okay. A person starting from point A. Write it down. A person starting from point A makes three complete rotations along the circle. Okay. Person starting from point A makes 3 complete rotations. Rotation number 1, 2, and 3 along the circle. 3 complete rotations. How much is going to be the displacement? Quickly. 3 times of 2 pi r, 0, 2 pi r, 6 pi. Tell me quickly. Fast. Very basic, very simple question. The answer is going to be 0. Okay, because the initial and final position is same. No matter how many rotations you make, it is going to be 0 only. That's fine. Okay. After this, the next concept of speed versus the velocity. What is speed? Speed is simply that how much distance do you travel in a given amount of time. Speed is simply how much distance do you cover in a given amount of time. That's fine. What are the different forms of speed that we know? Uniform speed, non-uniform, that means variable. That means the distance that you cover in first second is not equal to the distance you covered in the second second, not equal to the distance you covered in the third second. Okay. So if the distance that you are covering in different time interval is different, it's going to be non-uniform. Average speed is simply total distance divided by total time. Instantaneous speed is simply dx by dt. Okay. Similarly, uniform velocity, that's the displacement upon time. Okay. Non-uniform, the displacement is changing. In the given intervals, displacement is not same. Average velocity, delta x divided by delta t. Instantaneous velocity, dx divided by dt. Simple. Okay, basic thing we already know. Velocity is a vector quantity, so it can be positive, negative, or 0, isn't it? Positive, negative, or 0. Direction of velocity is always in the direction of change in position. Direction of velocity is always along the direction of change in position. Now the third point that I want to ask you, can the velocity change at constant speed? Yes or no? Can the velocity change at constant speed? Yes or no? Only yes or no. Quickly. Can the velocity change? Can the velocity change at constant speed? Fast. Yes or no? Can the velocity change at constant speed? Fast. Definitely yes. How? Definitely yes. Definitely yes. Definitely yes. How? By changing the direction. By changing the direction. By changing the direction. Okay. By changing direction. Okay. Is this point very clear? Definitely yes. The velocity can change by changing the direction even at constant speed. I am giving you an example for this question, for this concept. Okay. Let's say the question is something like this. All of you draw a circle. Okay. You started from point A. You started from point A. This is velocity v. You reached point B. You reached point B. You reached the point B. The question says, find the magnitude of change in velocity. Option A, 0. Option B, C, D. V, 2V, minus 2V. A, B, C, D. A, B, C, D. A, B, C, D. Plus 4 minus 1. What? Fast, all of you, quickly. Mrunali, give the answer. We'll come to the next question. Be fast with the answers. Quick, all of you. Only 20 seconds for this question. Begin. 20 seconds. Fast. A, B, C, D, A, B, C, D, A, B, C, D. A, B, C, D, A, B, C, D, A, B, C, D. Fast. 3, 2, 1, and the time up. Answers are coming, mixed responses are coming. What I said, I clearly asked you about the change in magnitude. Magnitude of change in velocity. Okay. Magnitude of change in velocity. What is the change in velocity? See, if I ask you about the initial velocity, what is the initial velocity? This is the initial velocity. What is the final velocity? This is the final velocity. So if I ask you what's the direction of initial velocity, if I ask you what's the direction of initial velocity, what it's going to be? This is the direction of initial velocity, and how much is it? It's v. The direction of final velocity is below. So what is change in velocity? What is change in velocity? That's velocity final minus velocity initial. You need to find out the magnitude of change in velocity. That's fine. What is the final velocity? If this is v, this is going to be minus v because it is in the opposite direction. Yes or no? Definitely yes. This is minus v. Minus of v. That means the magnitude is 2v. So the answer is C. All of you who gave the answer as C, all of you who gave the answer as C, please mark it as +4, and the rest of you mark it as -1. So let's take the discussion ahead. Okay, here we go. Now we are beginning with the projectile motion. Okay, that means what kind of discussion we are going to have? We are going to have the discussion for a particle which is simply thrown. Let's say this is a bottle. This is the bottle. If I throw this bottle, if I project this bottle, which is the only force that's acting in the situation, all of you, if you project an object, if an object is under free fall, if the object is under free fall, the only force that's going to act is the force of gravity, isn't it? The gravitational pull. Yes or no? So can we say that if you project an object, something like this, at different instants, the only force that's going to act on the object is mg, something like this, and the direction is going to be along the tangential, along the tangent to the curve. The direction is going to be along the tangent to the curve. Simple. Okay. So the direction of instantaneous velocity for a particle is shown in front of you, which is following a parabolic path. Okay. When a particle is moving on any path, the magnitude of instantaneous velocity equals the instantaneous speed. Okay. If you're talking about the magnitude of instantaneous velocity, it's going to be equal to the magnitude of instantaneous speed. A particle may have constant speed but variable velocity. We have seen the case. The particle is along circular motion, constant speed but variable velocity. At every single point, the direction is changing. Yes or no? Yes or no? Definitely yes. When a particle moves with uniform velocity, then its instantaneous speed, magnitude of instantaneous velocity, average velocity, and magnitude of average velocity, everything is same. Okay. Come here, all of you. See, the most important art in life is the art of ignorance. Getting? So there are going to be negativities in your life. Someone is going to say you something, someone is going to come. Don't waste your time on the people who are coming from the bus stand. Okay. They'll come after that. They have work to do. They have to go at the bus stand. They have to do the loading and unloading. They take money. They just come over here. They make some comments. That's okay. That's a part of life. Okay. That would keep on going. You follow the discussion over here. Okay. See. So what are we saying? I am saying that if the body is moving even at constant speed, its velocity can change, and it changes if the body is in circular motion. Okay. Now the next thing that I'm saying, that if the body is moving along a straight line, if the particle moves with uniform velocity, what is uniform velocity? Direction and magnitude both remain same. That means a particle is moving along straight line. Then what? Then the instantaneous speed, magnitude of instantaneous velocity, average speed, and magnitude of average velocity, everything remains same. I hope that this point is absolutely clear. Okay, so let's take the discussion ahead. Next discussion that's coming in front of you is the discussion of acceleration. So what is acceleration? Acceleration is rate of change of speed. Nopes. Rate of change of velocity. Okay. Again, what can be the different types of accelerations? Uniform acceleration, non-uniform, average, instantaneous. We'll be understanding the concept with a question. Okay. We'll be understanding. Just 20 minutes more, I'll be giving a break. After 20 minutes, I promise I'll be giving a break. Don't worry. Okay. Just 20 more minutes. I'll be giving a break. Okay. At 7:20. Pakka. Yeah. So do this question. Plus 4 minus 1. This is a question coming in front of you. Quickly. At 7:20, I'm giving a break to you. Before that, we need to do some more questions and couple of more concepts. So just have patience for 20 more minutes. The displacement of a particle starting from rest is this much. This is the expression for displacement. Okay. This is the expression for displacement. Gautam, I'll be explaining centripetal acceleration in circular motion. Okay. So just come to the concept and do it and give me the answer. The time in seconds at which the particle will attain zero velocity again. Again, they are saying again. That means already it is having a zero velocity at some time. Again, you want zero velocity. Okay. So plus 4 minus 1. Plus 4 minus 1. I think 45 seconds should be sufficient or 30 seconds should be sufficient. Time starts now. All of you begin. What is going to be the answer? That fellow ran away. After getting roasted, left the chat. Oh my God. That's okay. That's fine. So here we go. Last 5, 4, 3, 2, 1 and time up. That's cool. So now see, the displacement has been given to you. This is 6t square minus t. Are we aware about the fact that velocity is nothing but ds by dt? Definitely yes. So what's going to be the velocity? The differentiation, this is going to be 12t minus 1. Isn't it? It's going to be 12t minus 1. So, just a second, there is some, just convert it as t cube. Really sorry, this is t cube. Convert it into t cube, okay? I'm giving you 10 more seconds to again give your answer. This is t cube. I'm giving you 10 more seconds. Now do the question. The answer would definitely change. Fast. Notes will be available on the app. Don't worry. Time up. Okay. I have changed the equation. There was some mistake in the equation. I have corrected it. So now see, s is equals to 6t square minus t cube. That's fine. If you differentiate it, you get 12t minus 3t square equals to 0. Is this the expression that you're going to get? So what it says that 4t bracket t minus 3 equals to 0. That means either t equals to 0 or t equals to 3. Either t equals to 0 or t equals to, this is how much? This is, really sorry, this is 3t. This is, just a second. Take 3t as common from here. So what are you going to get? You're going to get t plus 4. Okay, minus t plus 4 equal to 0. So either t equal to 0 or t equal to 4. So these are the points. These are the time intervals at which the velocity is going to be 0. These are the time intervals at which the velocity is 0. If you talk about t equal to 0, so is velocity 0 at t equal to 0? Is the velocity 0 at t equal to 0? Substitute 0. Yes, it is 0. Is the velocity 0 at t equal to 4? Velocity at t equal to 4 is going to be 4 into 12 minus 3 into 4 square is 16. So yes, this is 0. That means initial velocity is 0 and after 4 seconds the velocity is again 0. If I give you the general condition, if I give you the general case of this particular body, what is it going to be? it's going to be the case, in which the body turns. Try to understand. Initial velocity is 0. It reached the maximum value. Now it is 0. And after that, what would happen? It would change its direction. That means the body is going to change its direction. Okay. If I again differentiate it, what do I get? Although it's not required, but we are just dissecting the question. If I again differentiate it, what do I get? I get 12 minus 60. 12 minus 60. That means you can clearly see that initially the acceleration is going to be positive. After certain time interval, the acceleration is going to be negative. That means initially the body is going to accelerate, and after that the body is going to decelerate, and the body is going to come to 0. This is something that you need to understand. Getting the point? It's not just about solving the question and getting the answer. Anyhow, you got the answer. This is the answer. But this is something that you need to know. This is something that you should, it should give you the feel that what is actually happening. This is displacement, velocity, acceleration. Anyways, let's take the discussion ahead. Another question coming in front of you is this. Read the question. The displacement x of a particle moving in one-dimensional motion is related to the time by the equation this. Okay, what is the displacement and time equation being given to you? Root x plus 3. X is in meter and t is in second. The displacement when the velocity is 0. You need to figure out the displacement when the velocity is 0. So I am giving you 1 minute for this question. Plus 4 minus 1. This is a p by q. Sakshi, which part? Which part, Sakshi? Previous question or this question? Previous question or this question? In the previous question, what I said, this is displacement. If you differentiate the displacement, you get velocity. They are asking that when is the velocity 0? So equate it with 0. You get the time as t equal to 4. We gave the answer. Now I said that what happens if you again differentiate the expression? You get acceleration. What is acceleration? 12 minus 6t. Now I am saying that if time increases, keep t equal to 0. I am saying keep t equal to 0. If you keep t equal to 0, Sakshi, listen, and all of you who are having some issue with this question. If you substitute t equal to 0, acceleration is 12, t equal to 1, acceleration is 6, t equal to 2, acceleration is 0, t equal to 3, acceleration is minus 6. That means acceleration is changing its direction. Initially acceleration was positive, and after some time, after 2 seconds, acceleration is negative. That means it's retardation. So initially the speed is going to increase, velocity is going to increase, and then it's going to decrease and come to 0. This concept you should feel. Okay, is this point very clear now with everyone, not only with Sakshi? Okay, that's cool. So now 1 minute for this question. 1 minute for this question. The time starts now. All of you begin. All of you begin with the question quickly. Here you go. Okay. Quick. Fast. Be quick. You're having 1 minute time. Okay. 5, 4, 3, 2, 1, and time finally up. Okay. So first of all, what you need to figure out? You need to figure out the displacement when velocity is 0. You need to find out the displacement. Okay. You need to find out the displacement. When you need to find out the displacement? When the velocity is 0. So we need to figure out the function of velocity. We need to find out the velocity. So the thing is that you need to find out velocity. So in order to find out velocity, let's generate the expression for displacement. It's going to be t minus 3. Yes or no? It's going to be t minus 3. So can you write x equal to t minus 3 the whole square? Can you write it like this? All of you, can you write it like this? Can you write it this way? Definitely yes. So if I differentiate it, Gautam Paul, negative acceleration means the velocity is going to decrease. Try to understand. Just a second. There was a doubt, so I'm telling it. Velocity is increasing, acceleration. Velocity is decreasing, retardation. Finally, what's going to happen? Velocity is going to become 0. After that, what's going to happen? It's going to change its direction. Imagine that I throw this ball. See, if you're running and there is a wind that's blowing along your direction, so it's positive acceleration. After some time, the wind changes its direction. You're running forward, the wind is coming from opposite side. Your speed is going to decrease up till 0, and then your direction is going to change. Now let's get back to the question. Okay. So what is dx by dt? Dx by dt is velocity. This is dx by dt. So how much it is? This is 2 times of t minus 3. 2 times of t minus 3. Okay. So you need to figure out the displacement when the velocity is 0. So when the velocity is going to be equal to 0, tell me. The velocity is going to be equal to 0 at t equal to 3 seconds. Velocity is going to be 0 at t equal to 3 seconds. Okay. Now you need to figure out what? You need to figure out what? People are going to say that, oh, this is 3. There is no answer like 3. They are asking you the displacement at this time. They are asking you about the displacement at this time. So substitute the value of t over here. So what is the value of x at this time? That's going to be 3 minus 3 the whole square. That means 0. So the answer is 0. The answer is 0. The answer is 0. Is this point very clear? Cool. Mukesh, no one is forcing you to attend the class. Is there someone who is saying that you have to sit in the class or else we'll file a case against you? You have to pay some fine. It's not like that. You find it boring, you can go sleep, dance, text someone. Whatever you want to do that, na? Doing this. Just rest everyone. Just focus over here. Okay. So this is the answer. A is the answer. So all of you who got the correct answer, mark it as +4. Those who gave the answer wrong, just mark it as -1. Let's take the discussion ahead. Here we go. The next point that's coming in front of you. See, when the particle moves with a constant acceleration, then its path may be a straight line or simply a parabola. If the particle is moving with constant acceleration, what we always feel, we feel that, okay, the particle is going to be along the straight line only, but the path can be parabolic also, because if you observe the projectile motion, this is the projectile motion. Okay, this is the projectile motion, which is the continuous force that acts along the motion. That's the mg. Okay. Is this point very clear? Let's take the discussion ahead. Someone is saying, please explain the previous concept once more. What happened in the previous concept? See, what happened in the previous question? They were asking that what is the displacement when the velocity is 0. The question was, what is the displacement when the velocity is 0? So first of all, find out when the velocity is 0. In order to find out the velocity, what we did? We described the expression for displacement. That was what? That was t minus 3 the whole square, isn't it? This was the expression, na? For x equal to t minus 3 the whole square. If this is the displacement, what is going to be the velocity? The velocity is going to be dx by dt, yes or no? The velocity is going to be dx by dt. That's 2 times of t minus 3 to the power 1, isn't it? So this is going to be equal to 0. That means t equal to 3. So this is the time. At this time, the velocity is going to be equal to 0. And what are they asking? They are asking you the displacement when the velocity is 0. So simply substitute the value over here. This is going to be x equal to 0. Now I hope that the point is absolutely clear. So come to the next question, and here we go. This is the next question in front of you. Again, +4 -1. Again plus 4 minus 1 quickly. X has been given, Y has been given, the speed of the particle at any time. 45 seconds for this question and the time starts now. Be quick. Just break, I'm giving you the break. 5 more minutes. 5 more minutes, I'm giving the break. Don't worry. You're getting the break in 5 minutes. Just 5 more minutes. Then I'll be giving a break. Okay. Be quick, be quick, be quick, be quick. Fast, 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 fast. Here we go, here we go, here we go, here we go, here we go. Last 15 seconds. Last 15 seconds. Quick. Okay, time up, time up, time up. See, what are they asking? They are asking the net speed of the particle at that time interval. You have the expression for displacement, that's alpha times of t cube. You have the expression for y, that's beta times of t cube. So if I ask you that what's the velocity along the x direction, are you going to differentiate it and are you going to say that this is alpha times of 3t square? Yes. If I ask you the velocity along y direction, this is beta times of 3t square. Yes. So if I ask about the net velocity, so what is it going to be? It is going to be root over vx square plus root over vy square. Yes or no? Definitely yes. So how much it turns out to be? It turns out to be root over alpha into 3t square the whole square plus beta into 3t square the whole square. Okay. So what the answer is matching? T square is going to come out. 3 is going to come out. So root over alpha square plus beta square B is the answer. I hope that this point is absolutely clear. Let's take the discussion ahead. Let's take the discussion ahead. All of you keep on marking your scores. Okay. So now what I was saying that if a particle is moving with constant force, its motion can either be a straight line motion or it can be a projectile motion. Now, if we talk about a projectile motion, this is simply a motion along two independent directions, which we can represent something like this. I don't want you to understand two-dimensional motion as two-dimensional motion. You have to understand it as two individual one-dimensional motions. Let's say this is u, this is theta, the x direction velocity u cos of theta, the y direction velocity u sine over theta. Okay, that's cool. We are going to discuss three parameters: time of flight, range, and maximum height. Time of flight, range, and maximum height. These are the three things that we need to discuss. After that, we'll be discussing the equation of trajectory. If I want to find out the time of flight, okay, what can we do? People are saying time over just 5 more minutes. I am saying now you will get a break. Don't worry. If we want to find out the time of flight, can I say that this is the initial point O, this is the point B, and this is the point C? That's fine. Point B. So if the time of ascent is T, time of descent is D, I can say that the time of flight, total time, is going to be 2 times of small t. That means if I consider the region O2A, all of you be very clear, be very attentive, focus at one location, that's over here. If you want to find out the time in going from O to A, we are applying V equal to U plus AT along the y direction. That means Vy equals to Uy plus Ay into T. What is the speciality of the highest point? The speciality of the highest point is that it's highest. What this statement means? It means that at the highest point, particle is not having the tendency to go up further. That means if this is the highest point, slow motion, stop, let you. If this is the highest point, at this point, the vertical component of velocity is 0. At the highest point, the vertical component of the velocity is 0. Is this point very clear? Yes. So at highest point, Vy is 0. Uy is u sine of theta. Acceleration is always g downwards. That's fine. Minus g into t. So you can say that the time of ascent is simply, it's simply how much? U sine theta divided by g. Okay. So what is the time of flight t? That's going to be 2 times of u sine theta divided by g. Do we need to mug up this formula? Definitely no. We have derived it quickly, isn't it? That's very cool. After this, if I talk about the range, what is the range going to be? Range, see, I am clearly saying that the only force acting in the situation is what? The only force acting in the situation is mg, and the direction of that force is downward, So can I say that along the x direction, along the horizontal, acceleration is going to be 0? That means the force along x direction is 0. That's fine, that's cool. So can I say that the distance along horizontal is simply speed along x into time? Okay, that's fine. So can we write that the speed along x is u cos of theta and the time of flight is 2u sine theta divided by g? Okay, so can we write it as u square 2 sine theta cos theta is sine 2 theta divided by g? So this is the expression for range coming in front of you. Very simple, very direct. Okay, that's fine, that's cool. How can we find out the range? How can we find out the height, maximum height? Now applying the expression between O to A. Okay, we are applying the expression again between O to A. That's fine. Which expression? V square equal to U square plus 2AS. Along which direction? Quickly. Which direction? Y direction. Very good. Cool. Vy 0. Uy u sine theta the whole square minus ay, that's g, into height, that's h. So you can say that the maximum height is u square sine square theta divided by 2g. I hope that this point is absolutely fine, absolutely clear. Is this point cool? Okay. After this, the equation of trajectory. Okay, so what we have seen? We have seen the time of flight. We have seen the range. We have seen the maximum height. And now what we are going to see? See some basic points. When a particle moves with variable velocity, then acceleration must be present in the situation. Yes, that's cool. In our situation, the velocity is continuously changing. There is acceleration along the downward direction. When a particle continuously moves along a curved path, its uniform speed, then the acceleration is non-zero. Yeah, one and the same thing. Okay. After this, just a second. After this, let's come to the point. Just a second. Yeah. Range. What is the range that you have said? Quickly. U square sine 2 theta divided by g. If I talk about maximum horizontal range, when is the range going to be maximum? The range is going to be maximum when theta is equals to 45 degree. That means you project a particle at 45 degree. So the range is going to be something like this. And how much is that range going to be? That range is going to be u square by g. That's fine. Okay. Comparison of two projectile for equal ranges. If you compare two projectile for equal ranges, you can say that, let's say this is h, this is h dash. Okay. One angle is theta. Another angle is I said uncle. Sorry. Another angle is 90 minus theta. Okay, just a second. What I'm trying to say, if one angle is theta, another angle is 90 minus theta, tell me what are the ranges? Tell me what's going to be the range in this situation. Fast. I'm observing your answers. What's going to be the range in this situation? What is going to be the range in this situation? All of you fast. At the angles of theta and 90 minus theta. This is theta. This is 90 minus theta. Can we figure it out? Tell me, is it going to be same? Hindu Murthy is saying same. Sujitha is saying same. Rest all of you, what are you saying? Quick, quick, quick. Let's figure it out. What is the expression for range? The expression for range is u square sine 2 theta divided by g. That's fine. So either you take theta, or you take 90 minus theta, 180 minus 2 theta. Both the expressions are going to be same. That means for complementary angles, the range remains the same. That means if you take a pair of 15 and 75 degree, okay, if you take a pair of 20 and 70 degree, 30 and 60 degree, 45 degree, it's going to be same. Okay, so here we go. We have a question coming. Let's try a question. After that we'll be doing some more concepts. Simple question coming in front of you. Plus 4 minus 1, plus 4 minus 1. Be quick. Plus 4 minus 1. Fast, all of you. Quick. I am giving you 45 seconds for this question. 3, 2, 1, and the time starts now. Time didn't started. It starts now, all of you. I am giving you break after 2 questions. 1 question, and after this 1 more question, and after that I'll be giving you the break. Okay. See, you are sitting. Try to understand, you are sitting. But I am continuously speaking for the past 2.5 hours. And I just had water once. You are sitting and you need to do the question. Think about me. Be quick. Yes, I'll be writing your names on the board. Oh, velocity units are wrong. No worries. Second, meter per second. Okay. Okay. Let's see what you have done. Initial velocity of a particle has been given and the retardation has been given. Okay, retardation has been given. Distance covered in the 5th second. Let's say this is the distance covered by the particle in 5 seconds and this is the distance covered by the particle in 4 seconds. So if I want to find out the distance covered in 5th second, can I say that the distance covered in the 5th second is going to be the distance covered in 5 seconds minus the distance covered in 4 seconds? Can I say this? Definitely yes. So how much is it, the distance covered in 5 seconds? ut plus half at square. So what is u? How much is u? U is 10. 5. Acceleration is negative because it's retardation. Half of 2 into t square, that means 5 square, 25. This is the S5. What is the S4? That's simply u t minus half a t square. Find out the value. Give me the answer quick. Quick. Give me the answer. Definitely you can give the answer by the nth second formula. What is the formula for nth second? U plus a by 2 to n minus 1. You have both the concepts. Apply whichever you find better. And get the answer. What is the answer? Very good. That's 1 meter. 1 meter is the correct answer. One more question. After that, I'll be giving the break. One more question. After this, I'll be giving the break. Means one more after this and then I'll be giving the break. Okay. One more question after this and then I'll be giving the break. Only 20 seconds for this question. 20 seconds for this question. The time. Oh, what happened? The time starts now. 20 seconds. Fast. Fast, all of you. Quick, 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 quick. What is it saying? Which one of the following graph, which one of the following curve do not represent the motion in one dimension? Which cannot represent the motion in one dimension? Quick. 5, 4, 3, 2, 1. And the time up. So A can definitely represent the velocity is increasing, velocity is decreasing, time is increasing, yet it represents. Velocity is increasing with time. Cool. Velocity positive, velocity negative. This is velocity versus time graph. That's why it's cool. It's fine. If it would have been speed versus time, it would have been wrong. Okay. This is also okay. This is wrong because the time can never decrease. Okay. After your 16th birthday, it is not possible that your 15th birthday would come. 17th birthday would come now. So this is wrong. Okay. This is wrong. This is absolutely wrong. So anyways, let's do one more question. Let's do one more question. Read the question what it says. Read the question what it says. R represents horizontal range. H represents maximum height of the projectile, then the angle of projection. Angle of projection. What is going to be the angle of projection? A, B, C, D. Only 20 seconds for this question. Time starts now. 20 seconds for this question. The time starts now. The time has been started. Quickly give the answer. Give the answer, all of you. Okay, okay, 3, 2, 1, and the time up, time up, time up, time up, time up. What is the expression for range? Range is u square sine 2 theta. That means 2 sine theta cos theta divided by g. What is the expression for maximum height? Maximum height is u square sine square theta divided by 2g. If you divide h and r, if you divide h and r, what are you getting? This gets cancelled out, this gets cancelled out. Okay, so this is going to be how much? H by r. This sine theta gets cancelled out. Okay, so what are you going to get? You're going to get 10 theta upon 4. Okay, 10 theta upon 4. This 2 comes out over here. So you can say that 10 theta is equals to 4 times of h by r. This is a basic thing that you can remember. A basic formula that you can remember. This is very important. Okay. So definitely the answer is going to be, tan inverse of 4h by r. So this is the answer. Okay. Plus 4 minus 1. Plus 4 minus 1. Adrika is saying that she lost the scores. So I'm giving you the break. Now in the break, what you can do, you can find out the scores, that how much marks are you getting. Okay. All of you calculate your scores. We'll be meeting after a break of 15 minutes. That means the time is this much, 5, 10, 15. Okay, we are going to meet over here. We will meet. Zai, 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 zai. Okay. Okay, okay, okay. So. Hello, 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 hello. Hello, hello, hello. Can you hear me? All of you? Am I audible? Am I visible? Now, am I visible? Hello. Welcome back. So, let's get started with the discussion. Let's get back. So, here we go. The break is over. And we are resuming with the discussion. So, some more discussion regarding kinematics, and after that we'll be starting the NLM. Okay, so what we have seen that if a particle is moving with the presence of a constant force, then what happens? Then its path can either be a straight line or it can be a parabola. Yes, we know. If you talk about the direction of average acceleration, you have discussed the acceleration. Acceleration is change in velocity upon the time. Acceleration is rate of change of velocity. So if you talk about the direction of average velocity, that average acceleration, that's going to be along the direction of change in velocity. Acceleration opposite to the motion, that's what we call as the retardation. Yes, we know, isn't it? So after this, equations we have also seen some numericals on these equations. Yes, we know. Let him speak. Okay, let him comment. You focus over here. Okay, now see. So we are talking about the various graphs. Okay, so what are the graphical representations corresponding to different situations? If I ask about this graph, okay, if I ask about this graph, all of you focus over here. Pay attention at this point. Don't waste your efforts in unnecessary giving, even comments to someone other. Just focus over here. Okay, so if this is the expression, if this is the graph in front of you for displacement and time, and this is the graph in front of you, so what these graphs represents? Okay, or let's say the graph number 1 and graph number 2, what do they represent? The graph number 1, graph number 2, what it represents? What the graph number 1 represents? What the graph number 1 represents? Graph number 1 represents what? It represents rest. Okay, what the graph number 2 represents? It represents motion. What kind of motion? It represents a uniform motion. Okay, if I draw the displacement time graph, something like this. Okay, so first of all, what the slope of displacement time graph is going to represent? Can we say that the slope of displacement time graph represents what? It represents the velocity. Okay, if you talk about the displacement time graph, the slope represents velocity. So if you talk about this slope number 1 and slope number 2, clearly you can say that the slope of 2 is greater than 1. That means the velocity of 2 is going to be greater than the velocity of 1. Definitely yes, that's cool. Apart from this, what it represents? It represents the body is at rest. This represents the body is moving with uniform velocity, isn't it? Because the displacement is changing at a fixed rate along with time. That's fine. After this, in this situation, the velocity is increasing or decreasing? In this situation, the velocity is increasing or decreasing? Tell me quickly. For this situation, third case, velocity is increasing or decreasing? The velocity in this situation is, you can clearly see that the slope is decreasing. Okay, so the velocity is decreasing in this situation. That's fine. In the next situation, what can you say? In the next situation, Stop spamming, Deepanshu Beniwal. बच्चा है क्या बिल्कुल जरा सा? You just coming and giving random comments. Mad or what? Grow up, child. Grow up. Focus over here. In this situation, what can you say? In this situation, what can you say? You can clearly say that this is the slope number 1, this is slope number 2. Definitely the slope is increasing, so the velocity is increasing. Slope is increasing, so the velocity is increasing. Okay, that's cool. Let's take the discussion ahead. What this graph represents, if you talk about the area of the displacement time curve, what the area represents, if you talk about the area of displacement time curve, so it's going to represent the term of displacement into time. This represents no physical quantity. Okay, so the area has no physical significance. Remember this thing. But from this given graph, you can see that the slope is negative. Slope is negative. Can you say this? Definitely yes. So the velocity is negative, but yes, it is constant. But yes, it is constant. Okay, let's take the discussion ahead. These are the different graphs. Rest, uniform motion, increasing velocity, decreasing velocity, and this is constant negative velocity. All the 5 graphs I have just given together. Okay, is this point clear? Okay, let's take the discussion ahead. We know that the slope of velocity time graph. Now this is the velocity time graph. Listen, if you talk about the velocity time graph, if you talk about the VT graph, what the slope of VT graph is going to represent? What the slope of VT graph is going to represent? Let's say this is the first situation in which the slope is 0. This is V, this is T. What it represent? It represents the constant velocity. Okay, fine. If this is the situation, what it represents? VT graph, what it represents? It represents uniformly increasing velocity. And what is the slope of VT graph? Slope of the VT graph is change in velocity divided by the change in time. That is nothing but the acceleration. That means the slope of the VT graph represents the acceleration, and in this situation, acceleration is constant. Okay. If I draw the graph something like this, if I draw the graph something like this, this is V and this is T. So what it represents in this situation, the velocity is increasing, but also the rate of increase of velocity, rate of change of velocity is increasing. That means in this situation, acceleration is variable and acceleration is increasing. Okay, acceleration is increasing. Okay, if you draw the graph something like this, so in this situation, the acceleration is going to decrease. Okay, basic discussion. Okay, let's take the discussion ahead. We know this is constant velocity, uniform motion. This is increasing velocity, uniform acceleration. That means constant acceleration. Slope represents acceleration. We know this. Acceleration is constant. We have seen this graph. Acceleration is decreasing. But it is not retardation. Velocity is increasing. It is not retardation. Retardation is negative acceleration, which decreases the velocity of the body. Getting the point? This is see, acceleration is still positive. Initially it was 10, now it is 8, then it would be 7, 6, 5, 4. It is not negative. It is not -5 or -4. This is decreasing acceleration but not retardation. This is simply increasing acceleration. Okay. What it represents, what the area under the VT graph represents. If you talk about the area of the VT graph, so what is it dimensionally? This is going to be displacement upon time into time. That means it's going to represent displacement. That means the area of the VT curve is going to represent the displacement. It represents about the displacement, the change in position. Okay, let's take the discussion ahead. AT graph, simply this is A, this is T, uniformly increasing acceleration, constant acceleration, simple. Okay, if you talk about the area of the AT curve, it represents what? It represents change in velocity. Yes, Nageshwar Rao, ask your doubt. Ask your doubt, don't worry. Quickly, what's your doubt? Please tell me. Yeah, so we have discussed the motion under gravity for projectile motion for 2D. What about the motion under gravity for the case of a straight line motion? Let's say this is you standing over here. Who wants to stand over here? Who wants to stand over here? Let's say Ishika is standing. Okay, Ishika is standing over here. Ishika, let's change the hairstyle of Ishika. She is going to say I'm not having spikes. Let's say this is Ishika standing over here. What she's doing? She's throwing a ball. Okay, she's throwing a ball up with certain amount of velocity. The ball goes at the top. Okay, so you need to find out the time of flight. You need to find out the time of flight, the time of going up, and the time of coming down. That means the total time is equal to twice the time of ascent or descent. Simple. Okay. Okay. So in this situation, you have thrown the ball with some initial velocity u. So tell me what's the speciality of the highest point? Ria, what's the speciality of the highest point? It's highest. That's the only speciality that the highest point has. That means the highest point has v equal to 0. Okay. So you are going to apply v equal to u plus at. 0 equals to u minus gt. So from here you get t equals to u by g, or simply the total time of flight is 2u by g. Okay, that's fine. Okay, that's fine. That's fine. Okay. Now see, in the next situation, who wants to stand in the next situation? Let's say Ria is standing in the next situation. Okay, happy. And who else? Who else? Kostav is standing over here. Kostav is observing the motion of the ball that's thrown by Ria. Okay, so this is u equal to 0. The ball is dropped. Okay, at any given instant, you want to figure out the displacement. So what are you going to write? Let's say at t time, anytime t, not t time, small t time. Okay, the displacement is s. So s equal to u, that is 0, t plus half g t square. That means you can say that the displacement at any time t is proportional to t square. Can we say that? Definitely yes. Harsh Diman, can we say this? Definitely yes, we can. So what are the different outcomes that we are getting? In case of uniform motion under gravity, speed with a ball is projected up. Speed with which a ball is projected up, the ball comes back with the same speed. That means if it is thrown with the speed u, it's going to come back with the speed u and the direction is opposite. Isn't it? Definitely yes. Next point, magnitude of velocity at any point on the path is same whether the body is moving upward or downward. That means if you talk about the speed at this point in the upward motion or in the downward motion, if the point is same, speed is going to be same. War in Squares is asking how long the lecture is going to be. Even I don't know. We will be covering every single point, every single concept, no matter how long it takes. It might take up till 12 or 1 or 2. We don't know, but we'll be covering every given point. Okay. So let's take the discussion ahead. Next point. We have seen that S is proportional to T square. Okay. S is proportional to T square. If you want to figure out the displacement in any nth second, that's simply u plus a by 2, 2n minus 1. S nth is u plus a by 2, that means g by 2, bracket 2n minus 1. Okay, so remember this basic discussion. After this, if a ball is dropped from a building of height h, okay, listen. Now who wants to stand up on the building? Adrika. Okay, Adrika is standing over here. Adrika is standing over here. what she is doing, she is standing on a building of height h, okay, and if this ball is thrown upward, if she throws a ball upward, try to understand what she has done. She has thrown a ball upward, something like this, okay, and in the second situation, the ball is dropped, okay, in the second situation the ball is dropped with the same speed downward. That means u speed up, u speed down, okay. So the time taken in the first case, if that is t1, time taken in the second case is t2. So the net time, see, from the same building, if two balls are thrown, one upward and the other with the same speed downward, okay, so these are the times t1 and t2. So you can say that the time t is equals to, if the ball is dropped, then the time t equals to root over t1 t2. Just remember this basic concept, okay. Let's take the discussion ahead. We have derived the expression for projectile motion. We have done this, okay. We have seen the different cases. So now if we talk about projectile, we can discuss the projectile individually along the x and the y directions. If I ask you what is the initial velocity, along the x direction, that's u cos of theta. If I ask you what is the acceleration along the x direction, that is 0. What is the displacement along the x direction, that is equal to range. If I talk about the vertical motion, what is the initial motion along y direction, that's u sine of theta. If I ask about acceleration along y direction, that is g downward. And how much is displacement along y? You are going up and you are coming down. The displacement along y direction is 0. The displacement along the y direction, all of you, the displacement along y direction is 0. After this, what we do? We simply apply the equations of motion and find out the required results. What is the time of flight? We have derived 2u sine theta divided by g. After this, the range, maximum range, everything we have found, everything we have compared. Okay, so we are taking the discussion ahead. We are finding the equation of trajectory. Basically, what is the equation of trajectory? If I ask you that this is a projectile, okay, who wants to stand over here? Let's say Yogin is standing, okay. This is Mr. Yogin standing, and what he did, he just kicked a ball. And the ball went something like this. You want to figure out that at any given time, if the ball is having y displacement, what is the x displacement of the ball? That means if you are aware about the y coordinate, how much can be the x coordinate? This is found by the equation of trajectory. We are not deriving the equation of trajectory directly. Remember, x tan theta bracket 1 minus x by r. This is the range. R is the range, and this is the relation between x and y. Okay, so I hope that this point is absolutely clear. Here we go. Yeah. Now, relative motion. If you talk about the relative motion, let's say this is you. Who wants to be in this car? Who wants to be in the truck number A? Okay, let's say Arvind Raj. Arvind Raj is standing in the truck number A. Mr. Arvind Raj is standing in the truck number A. Okay, and in the truck number B, Nageshwar Rao, okay, is standing in the truck number B. Let's say truck number A and the truck number B both are moving with the same speed of 10 meter per second. So can I say that in 1 second both are going to cover the same displacement? So the final location of both of them after 1 second is going to be same. So what is going to be the relative velocity of A with respect to B or B with respect to A? That means if a person from A observes B or a person from B observes A, he is always going to say that the relative velocity or the relative speed is going to be 0. But now another person is coming in the game. Okay, let's say Mr. Harsh is coming. Harsh Dhiman is coming in the picture. Okay, in a truck number C, like this. Zai, 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 zai. Now the displacement that Hertz travels with respect to A and B is going to be different, isn't it? Can we say this? Yes. So basically the concept is, if this is the origin and let's say two people are standing at the origin, person A moved, person A moved, person B also moved. But how much B has moved with respect to A? How much B has moved with respect to A? Okay. Okay, sorry, Kirti. Kirti is moving, okay? So, Kirti is moving. This is Kirti. And this is Riya. Okay? This is Kirti. And this is Riya. So, how much Kirti has moved with respect to Riya? That's going to be XB minus XA. That's going to be XB minus XA. So, the net displacement of one person with respect to other, that's simply this much. That's simply this much. Okay? XB minus XA. If I differentiate the expression, do we get the relative velocity of B with respect to A? That's VB minus VA. Yes or no? Yes or no? Quickly. Definitely yes. Another situation coming in front of you. See, this is car number A, and this is car number B. Okay, moving towards each other with 10 meter per second and 5 meter per second. Okay, the separation between them is 150 meter. Okay, find the time required to cross each other. Option 10 seconds, B option 5 seconds, C option 15 seconds, okay, D option 0. ABCD quickly. Okay, another question I'm forming. This is the police jeep. And this is the thief running. Okay, this is the thief running. Okay, now see, the separation between police and the thief is 100 meter. The speed of the police is 20 meter per second. The speed of the thief is 10 meter per second. You need to find out the distance the police jeep covers before catching the thief. This is the question from HC Verma. Before catching the thief. Quickly do this. Quickly do this. Quickly, all of you do this fast. Rupak Saha is saying correct. Do this question fast. Chinchang Sign. What's your real name? Chinchana Sin. Oh, I just read Chinchang. Okay, so timer for both the questions. Time starts now. How much is this? First question. 5 more seconds. 4, 3, 2, 1. And the time is up. So in this situation, what is going to be the relative velocity of A with respect to B or B with respect to A? That's going to be 10 plus 5. That's 15 meter per second. Yes or no? That's going to be how much? That's going to be 15 meter per second. So how much is going to be the time required to cross each other? Time is simply the relative separation divided by the relative speed. Yes or no? That means 150 divided by 15, that is 10 seconds. Simple. For the next question, first of all, when the police is going to catch the thief? At what time the police is going to catch the thief? Tell me. In how much time is the police going to catch the thief? The police is going to catch the thief in how much time? This is 100 meter. Okay, so what is the relative speed? The relative speed is 20 minus 10, that's 10. 20 minus 10, that's 10 meter per second. Okay, that's 10 meter per second. Okay, and the distance is 100, so time is going to be 100 divided by 10. This is simply 10 seconds. 10 seconds. Okay, time is going to be 10 seconds. And in this 10 second, how much the police is going to travel? The police is going to travel a distance of 20 into 10, that means 200 meter. This is the answer. How many of you got the same answer? How many of you got 200 meter? Got this? That's nice. That's nice. That's awesome. That's cool. Okay, so let's take the discussion ahead, and here we go. Here we go. Here we go. Here we go. Now, the Rain Man problem. The thing is, let's say this is who wants to walk in the rain. Now, who wants to run in the rain? Who amongst you want to run in the rain? Let's say Sai. Okay, Sai. This is Sai standing over here, and what he's doing? He's normally standing over here, and the rain is falling something like this. Okay, rain falls like this only. So he's having an umbrella. So what he's doing? He's simply holding the umbrella. He's simply holding the umbrella something like this. He is holding the umbrella something like this, isn't it? But in the next situation, what he does? He throws the umbrella and he starts running. He throws the umbrella and he starts running like this. Okay, so what's going to happen? Because of his own motion, this is the velocity of the man and this is the velocity of the rain. Okay, so in this situation, what's going to happen? In this situation, this is the velocity of the man. This is the velocity of the man, and this is the velocity of the rain. This is the velocity of the rain. Okay, velocity of the rain. You need to find out the velocity of rain as seen by the man. Velocity of rain with respect to man. If we apply the formula VAB, that's VA minus VB. That means VR minus VM. VR minus VM. Okay. So can I write VR minus VM as VR plus minus of VM? See, this is very important that I'm writing over here. All of you. Can I write it like this? VR plus minus VM. So if this is VM, what is minus VM? This is minus VM. If this is VM, this is minus VM. That means the resultant is going to be along this direction. This green line is the resultant. Okay, this green line represents the velocity of rain with respect to man. This green line represents the velocity of rain with respect to man. That means if the person is running, okay, that means if the person is running, the rain appears to be coming something like this because of his own velocity. Because of his own velocity. Yes or no? Definitely yes. So what can we say? We can say that if the person wants to hold the umbrella, he should hold the umbrella at an angle theta, and that relation of theta is going to be tan theta equals to what? Tan theta equals to opposite upon base. That means what is this? This is what? This is VM divided by base. This is VR. Okay, this is VR. Okay, so simply VM divided by VR. So at this angle, you have to hold the umbrella. Simple. Okay. Sinchana sin, at this angle you have to hold the umbrella. Is this point very clear? Yes. And what's the resultant? That's root over VR square plus VM square. The resultant is going to be root over VR square plus VM square. Okay. So here we go. Now the river boat problem. Okay, or the river man problem. Hey, who wants to swim now? Who wants to swim? How many of you know swimming? How many of you can actually swim? Let's say this is water. This is a river. Okay. And this is the direction of flow of river. This is the direction of flow of river. Okay. This is the direction of flow of river. And if let's say someone of you, Manika. Okay, Manika is coming over here. What is she doing? She's swimming. Okay. She knows swimming. So she's swimming. Now, if she is swimming along this direction, this is called the direction of downstream. This is called the direction of downstream. So the net velocity of the person is going to be the velocity of river. The net velocity of the person is going to be the velocity of river plus the velocity with which the person is flowing. Okay. That means something like this. If let's say Harsh comes in the situation, and what he is doing, Harsh comes in the situation, and what he is doing, he is flowing opposite. He is swimming opposite to the direction of river. This is river. And this is Harsh. This is Mr. Harsh. Swimming something like this. Okay, swimming something like this. So the net velocity in this situation is going to be V, that means the velocity of person minus the velocity of river. This is going to be the net velocity. This is going to be the net velocity. Okay, this is upstream. This is upstream. Okay, that means you are going opposite to the flow of river. This is downstream. Okay, I hope that this point is absolutely clear. So here we go. Here we go. Now the thing is, let's see. If you go at some angle, if you are going at some angle, okay, if you are traveling at some angle, then what's going to happen in the situation? What's going to happen in the situation? Let's say this is the river. 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 Okay, that's fine. Velocity of river. And the person is traveling exactly in the opposite direction, exactly perpendicular to the river. If the person is going exactly perpendicular to the river, can this person cross the river exactly in the opposite side? If you start traveling along this direction, will you reach the opposite end? Yes or no? Will you reach the opposite end? Yes or no? Definitely no. If you want to reach exactly the opposite end, if you want to reach exactly the opposite end over here, where should you travel? Where should you travel? You should travel somewhat over here, something like this. Like this. Okay. That means if you travel at some angle theta, if you travel with some angle theta, at some angle theta with some speed v, then you might reach the opposite end. And what should be the condition? What should be the condition if you want to reach the opposite end? What should be the condition if you want to reach the opposite end? In order to reach the opposite end, what should be the condition? The condition should be that the velocity, listen, if this is velocity of man with respect to still water, can we say that this is Vm cos of theta and this is Vm sine of theta and this is velocity of river Vr? So if the person is traveling exactly in the straight direction, are the components of velocity going to cancel out each other? Definitely yes. So can we say that Vm times of sine theta, Vm sine of theta equals to Vr? Can we say this? This is the condition of minimum distance of approach. Can we say this? Definitely yes. Apart from this, if the person wants to cover the river in the shortest possible time, if the person wants to cover the river in the shortest possible time, so he should travel exactly in the opposite direction, exactly in the perpendicular direction, and he is going to reach at some other point. This is point A, this is point B, this is point C. So B to C is the additional distance that the person has traveled. B to C is called the drift. the additional distance that the person travels. Okay. Okay. The person is moving with this velocity, velocity of man. This is velocity of river. Okay. This is velocity of river. That's fine. So the question is that how much time is required? Time is simply distance. Let's say that this distance is d. Let's say this distance is d. This distance is d. Time is distance divided by the speed of the person along the y direction. If this is y and this is x. Okay, this is the time. This is the time. Getting? This is the time for the short. This is the case of shortest time. And how much distance additional this person is going to travel while going from B to C? How much distance, how much additional distance, how much unwanted distance this person is going to travel in going from B to C? This distance can be said as x. The drift equals to speed. How much is the speed? Speed is Vx into time t. What is Vx? Vx is Vr. Into time is d divided by Vy. Remember it like this only. Remember the expression like this only. Okay. Remember the expression like this only. Okay. So let's continue the discussion. Let's continue the discussion. So let's understand the discussion with a question. A simple question is coming in front of you. Read the question. +4 -1. Boat takes 2 hours to travel 8 kilometers and back in still water. Still water. Okay, still water. After this, if the velocity of water is 4 kilometers per hour, the time taken for going upstream is 8 kilometers and coming back is quick. All of you, be quick. I am giving you 45 seconds. I am giving you 45 seconds for this question. The time starts now. +4 -1. All of you be quick. Quick. 45 seconds for this question. Fast. Fast, all of you. Quick. 15 seconds more. Okay, here we go. Time up. Okay. Now see, the thing is that what it says, the question says that the boat takes 2 hours to travel 8 kilometers and back. Let's say this is point A. This is point B. You're going from A to B and coming back to A. So how much distance are you traveling? 8 plus 8, 16 kilometers. 16 kilometers in still water. This is the still water. Okay. If velocity of water, that's the second case. Okay. So in the first case, what is the velocity of the boat? If this is the boat, going and coming back. So what is the velocity of the boat? That's total distance. What is the speed of the boat? Not velocity. What's the speed of the boat? That's total distance divided by the total time. That's 2 hours. So this is 8 kilometers per hour is the speed of the boat in still water. Okay, this is case number 1. This is case number 1. After this, if the water is flowing at 4 kilometers per hour, the time taken for going upstream is 8 kilometers. Okay, the time taken for going upstream. That means this is the velocity of water and this is the boat. Okay, so the speed of boat, both in same direction. So the time is what? Time is distance. How much is the distance? 8. divided by the speed along the, oh sorry, this is upstream, this is upstream, this is upstream. What is it saying? Water is flowing 4 kilometers, then the time taken in going upstream, up the stream. So it's going to be opposite. Really sorry, this is going to be opposite. It's going to be something like this. So what is going to be the speed in this situation? How much is going to be the speed, net speed along the upstream is going to be, these are opposite. So this is VB minus VW. That means 8 divided by 4. The time is 2 hours. Okay, the time is 2 hours. Okay. Yeah, and you need to find the time for coming back. So when you come back, so this is the velocity of water and this is the velocity of boat. So how much is the time? Let's call it as T1. This is T2. T1 is the time for going opposite to the flow of water and T2 is the time for coming back. That's going to be 8 divided by VB plus VW. That means it is 8 divided by 8 plus 4. That means 12. So this is simply how much? This is 8 by 12. That means 2 by 3 hours. That means 40 minutes. This is 40 minutes. So the answer is going to be 2 hours and 40 minutes. How many of you got the same answer? Add plus 4 to your score. Those who got it wrong, add minus 1 to your score. Okay. A is not the answer. Dipanshu Beniwal. A is not the answer. 2 hours, 40 minutes. 2 hours is going upstream and 40 minutes for coming back. This is T1, this is T2. He is asking the time for going upstream and coming back. Going 8 kilometers and coming back. He is asking about the total time. So this is the answer, B. All of you who got the answer as B, add it to your score. Let's take the discussion ahead. The next question coming in front of you is this. A very simple question. Find the distance traveled by the body in 4 seconds. Okay, so how much is the distance traveled in 4 seconds? How much is the distance traveled in 4 seconds? Only 20 seconds for this question. Only 30 seconds for this question. Quick. Easy question. Easy question. 3, 2, 1. The time starts now. The time starts now. All of you begin. Quick, 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 quick. Fast. Here we go, here we go, here we go, here we go, here we go. Here we go, here we go, here we go. Aditi, give the answer. I'll take your name. Quickly give the answer. Okay, so time up, time up, time up, time up. The answer is going to be 55 meter. What you need to do, you need to simply find out the area. You simply need to find out the area under the curve. The area under the curve for this graph. Add all of them and find out the total answer. That's going to be D. Okay. So some of you are giving the correct answer. That's cool. So let's take the discussion ahead now. And here we go. Here we go. Here we go. Here we go. Read the question. Another important question. Very nice question. This is +4 - 1. This is a very, very, very nice question. Very important. I'm making 3 stars to this question. This is a PYQ. This question is a PYQ. So read the question. A particle is moving with constant. A particle is moving with constant speed v in a circle. A particle is moving with constant speed v in a circle. Okay, that's fine. Particle moving with constant speed v in a circle. That's fine. Okay, the constant speed is v, 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 v. Okay. The magnitude of average velocity after half rotation. Magnitude of average velocity after half rotation. Okay. What is the average velocity after half rotation? Let's say you are starting from A, coming to B. What is average velocity? What is average velocity? That's total displacement upon total time. Total displacement upon total time. Okay. So I'm giving you 30 seconds for this question. The time starts now. All of you be quick. Quick. All of you get started. It's a nice question. Do this question, try this question. If you do this question on your own, that means that you have learned something. Fast. A B C D A B C D A B C D A B C D A B C D A B C D. Quick. Okay, okay, okay. So time up. Here we go. Average magnitude of average velocity after half the rotation. What is the displacement first of all? What is the displacement corresponding to half the rotation? We know that the displacement is going to be 2r divided by the time. Now what is time? We can say that if the body is moving with constant speed, so the total time is 2 pi r divided by the constant speed v. Can we say this? Definitely yes. So is the time in going from A to B half that of the time in going from A to B? Is t by 2 half the time period? That means it's simply going to be pi r by v. It's simply going to be pi r by v. Okay, so substitute the value of t over here. You get the answer as 2r divided by pi r by v. R gets cancelled out. So the average, the magnitude of average velocity is 2v by pi. That means the answer is B. Keep on adding your scores. Okay. So we are starting with the third lap. That's the Newton's laws of motion. So all of you get started. All of you have your concentrations over here. Your focus at one point. We are beginning with very important part of mechanics. That's the Newton's laws of motion. So here we go. First of all, the Aristotle's fallacy. We are discussing the mechanics with a fallacy. A very big person, a very big philosopher, very big scientist, Mr. Aristotle, but his name is linked with a fallacy. What is a fallacy? Fallacy is a false statement. Okay, it's a false statement. So let's try to understand what the fallacy is. Mr. Aristotle said that if you want to make a body move with constant velocity or constant speed, if you want to make a body move with constant speed, you require a continuous force. That means if this body is moving with a constant speed, there is a requirement of continuous force in the situation. So is this point clear? Is this point true? That means a constant continuous force is required to keep a body in uniform motion. Is this point true? This is not true. Because if I once give this body a velocity, it's going to travel up till infinity. No one is going to stop the body. Body is going to continue its uniform motion unless and until it experiences an opposite force. Unless and until it experiences a retarding force, a stopping force. That means the statement is opposite. What the statement is saying? The statement is saying that if you want to make a body keep on moving, you require a force. And the actual statement is opposite. That means if there is no force, the body would keep on moving. So this is the fallacy. Okay. This is the fallacy. Let's take the discussion ahead. So what is basically a force? A force is simply a push or a pull which changes or tends to change. It's a push or a pull which changes or tends to change the state of rest or of uniform motion. Simple. Okay. What are the effects of a force? A force can change the speed of a body. It can change the direction of a body. It can change the shape and size of a body. Okay. If this is a body, you projected it with some velocity v. The body moved in this path. That means the speed, the direction, the shape, the size, everything can be changed using a force. Okay. Inertia. What is inertia? Inertia is simply the inability to change. What am I saying? Inertia is simply inability of a body to change. Change what? It's a state of rest or a motion. That means if a body is moving with constant velocity, it wants to keep on moving with constant velocity unless and until it experiences some external force. Is this point clear? Okay, so inertia of direction, it is the inability of a body to change its direction of motion by itself. That means if the body is moving in some direction, it would keep on moving in that direction unless and until an external force is applied. Okay. Newton's second law. So basically, what is the law of inertia? The Newton's first law. That means if a body, Adolf Hitler is saying that sir Hindi nahi aati hai kya? Just a second. I should reply in English or Hindi. This is English batch. So the mode of communication is going to be English only, Mr. Adolf Hitler. And who is there? Purvi Chaudhary, class 12th ka one shot. But that is on the competition wala channel. So I'm not aware about the timetable. Please go and check that channel. Okay. Rest all of you, please focus over here. Okay. बाकी लोग ध्यान यहाँ पे रखो. Unless you want to get blocked, please focus over here quietly. Okay, fine. Come back. Cool. See, what are we saying? We are saying that if the body is moving in some direction, it would keep on moving in that direction unless and until some external force is applied. Okay, this is the inertia of direction. Okay. Now the Newton's second law. What this law says, it says that the force acting on a body is proportional to the rate of change of momentum. What is momentum? What is momentum? Momentum is the product of mass into velocity. What it represents? It represents the amount of motion, the quantity of motion, the magnitude of motion that a body possesses. Okay. Yeah. So force is going to be what? Force is going to be d by dt of mv. Now if the mass is constant, what it's going to be? It's going to be m times of dv by dt. So you can say that in the situation for which the mass is constant, that means for constant mass systems, force can be written equal to mass into acceleration. That means Newton is nothing but kg meter per second square. Kg meter per second square. Okay. Okay. Impulse. What is impulse? Impulse is a very large force acting for a very short time. Okay. Big force acting for a very small time. That means if you talk about the impulse, that's simply going to be F delta t or F dt, F delta t or F dt. Tell me what is going to be the dimension of F delta t? What is going to be the dimension of F delta t? Quickly. Fast. What's going to be the dimension? Quick. Very good. Force is simply rate of change of momentum. Rate of change of momentum, delta p divided by delta t. And this is delta t. So this is nothing but, impulse is nothing but the change in momentum. What is going to be the unit of impulse? That is going to be kg meter per second. That's going to be kg meter per second. Okay. Is this point very clear? Yeah. So what are the examples of impulse? First of all, this is the law that we said. This is basically the relation between impulse and momentum. We also term it as impulse momentum theorem. We also term it as impulse momentum theorem. What it says that impulse is nothing but the change in momentum. Impulse is nothing but the change in momentum. I is equals to the change in momentum. So what are we saying? We are saying that impulse of a force equals the change in momentum. This relation is known as the impulse momentum theorem. Law of conservation of momentum. What it says? It says that if the net external force acting on a body is 0, when the net external force is 0, when is it going to 0? It's going to be 0 when the momentum remains constant. So what can you say? You can say that F equal to d by dt of P. Definitely yes. You can say that F equals to d by dt of P. So if P is constant, F equal to 0. If P is constant, F equal to 0, that means I can say that the momentum of a body remains conserved. Momentum of a body remains conserved when the net external force on the body is 0. Is this point very clear? Is this point very clear? That's cool. Focus, 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 focus. Focus, 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 focus. Focus. Over here. Not only in the chat, just here. All of you. You want to study, you want to learn some concepts, then you be here. If you are just here that you don't have to do anything, there's nothing else in your life, so you just came and thought that, okay, we'll just pass some time. So you are doing wrong with the students who are actually, willing to study, who actually want to study over here. There are some students who really are giving answers appropriately, who are making the best use of the time, and out of nowhere some people come and they just start saying anything rubbish, and you're just disturbing everyone over there. Okay, so at least have some humanity. I don't know that what you actually want to be in your life. That makes no difference. You want to be engineer, doctor, cricketer, actor, whatever, but before that, be a good human being and show some humanity. Okay, AKM is saying आप हिंदी बोलते तो अच्छा होता बेटा. This is English channel. Okay, so there are a lot of students in our country who don't know Hindi. Okay, like your brothers and sisters from South, from East India, from northern regions. There are different languages in India. Okay, so the only mode of communication to share knowledge is English. Are they not a part of this country? Okay, so we have to focus on physics. Is this point very clear? And this is the last warning. Listen, whoever you are, the people who are just wasting the time, it takes 15-20 minutes, okay, to track your IDs. I don't want to get into all this, so please don't do this. Okay, just study, and if you don't want to study, let others study. Cool. Let's come back to the point. Now what I was saying that if force is written as rate of change of momentum, if the momentum is constant, that means if the P term is constant, then the differentiation of momentum is going to be 0. dP by dt equals to 0. That means the force is 0. When the force is 0, when the momentum remains constant. That means if net external force on a system is 0, I'm giving you an example. If net external force on a system is 0, let's say this is the system. Okay, this is the bomb which is kept over here of mass m. It just got broken into two fragments, fragment number 1, fragment number 2. Okay, fragment number 1, fragment number 2. So what happened in this situation? The initial momentum of the system was 0. Let's say the final momentum m1 v1, the momentum over here m2 v2. Okay, that's fine. So can you say that whatever the final momentum is in the situation, that's going to be equal to the initial momentum? Why? Because there is no external force acting in the situation. So if the net external force in the situation is 0, if the net external force in the situation is 0, you can simply say that the total momentum of the system is going to remain constant. There are n number of examples that you can give. Let's say you are standing inside a boat. You just jumped out of the boat, so the boat is going to get back. You're just standing inside a boat. Okay, let's say this is a person standing in a boat. Okay, and this is the shore. If the person who wants to stand in the boat, AKM is standing in the boat. Okay, he just jumped over here. So what happened? The boat went back. Isn't it? So the total momentum initial must be equal to the total final momentum. Let's try some numericals on this discussion. Let's try some numericals based on this discussion. We have seen that what is the second law. Just a second. Let's first try a numerical and then we'll take the discussion further. Okay, so here we go, here we go, here we go, here we go, here we go. Yeah. Read this question. Read this question, all of you. A light spring balance hangs. A light spring balance hangs from the hook of the other light spring balance, and a block of mass capital M hangs from the former one. Then, which of the statement is going to be true? Let's say this is one spring balance. Let's say this is one spring balance, and this is the another spring balance. Okay, one spring balance, another spring balance. That's fine. This is the block of mass M. What are going to be the readings of these spring balances? What are going to be the readings of these spring balances? Quickly tell me. What are going to be the readings of these spring balances? A option, both the spring read M. B, the scale of the lower one reads M and the upper one as 0. Reading of the two scale can be anything, but the sum of the readings is going to be M by 2, M by 2. So I'm giving you 30 seconds for this question. 30 seconds for this question. 3, 2, 1, the time starts now. Begin. Begin, all of you. Fast. Quick. Quick, all of you. Be fast. Okay. So here we go. Now see, in this situation, the thing is that if you draw the free body diagram, then what's going to happen in this situation? Let's say if this is the spring, okay, and this is the mass over here. So if the system is at equilibrium, what can you say? You can simply say that mg must be equal to the reading, that means the tension in the system. Definitely yes. So now in the second situation, there are two springs. Okay, there are two springs. Spring number 1, spring number 2, and this is the block. This is the block M. Okay, spring number 1, spring number 2. Okay, so are both these springs in equilibrium? Definitely yes. Are both these springs in equilibrium? This is spring number 1, this is spring number 2. So can we say that for the first situation, mg is equal to the reading in the first one, that's T1? Definitely yes. So if the above system is also at rest, so T1 equal to T2. So we can say that T1 equals to T2 equals to mg. T1 equals to T2 equals to mg. That means simply the answer is going to be what? The answer is going to be A. Okay, the answer is going to be A. Now let's have a look at some conditions, at some situations. Here we go. Just a second. Yeah. So here we are. Basically, what the free body diagram is, first of all, if we talk about a free body diagram, so what is a free body diagram? Free body diagram is the representation of each and every single force acting in this situation. So let's say this is block number 1 and this is block number 2. Block number 1 and block number 2. If this is A and this is B, what are the different forces acting in the situation? First of all, if I talk about the block number B, what are the forces acting on the block number B? This is mg This is normal reaction N1. Okay, that's fine. If I talk about the block number A, what are the different forces acting on the block number A? Let's say this is M1 or MB. Let's call it as MBG, and this is N1. So can you say that for this situation, N1 is equal to mass of B into G? Definitely yes. For the second situation, can you say that this is mass of A into G? That's fine. Apart from this, the normal reaction is the force that acts between two surfaces. Normal reaction acts between two surfaces. So it acts equal opposite between the surfaces. If this is N1, this is going to be N1, isn't it? This is going to be N1. This is going to be N1. That's fine. And the normal reaction between the block A and the ground. A gives a normal reaction, let's say N2 to the ground. Ground gives it back. So this is N2. You're going to write N2 is equals to N1 plus MA into G. So the equation looks something like this. This is N1, which is MB. So this is MA plus MB times of G. That's the normal reaction between the ground and the block A. Is this point very clear? So what we have said regarding the normal reaction, that it acts between the two surfaces. Yes or no? Very good. It acts between the two surfaces in contact. Yes. It acts between the two surfaces in contact. Yes. It is equal and opposite. That means the amount of normal reaction A gives to B, the same amount of normal reaction B gives back to A. Yes or no? If I tilt the surface, what is the direction of normal reaction? Still it is perpendicular to the surfaces, something like this. Still it is perpendicular to the surfaces, something like this. Yes or no? Definitely yes. Is this point very clear? If I resolve the forces in this situation, what can I say? I can simply say that this is mg, this angle is theta, this angle is theta. This is mg cos of theta. That means simply the normal reaction equals mg cos over theta. Can we say this? Definitely yes, we can. Can we say this? Definitely yes, we can. If I talk about a two-body system, let's say the bodies are in contact, something like this. You are applying a force F. This is you standing over here. Okay. You are applying a force F, something like this. This is you standing, applying a force, something like this. Okay. So in this situation, let's say if both the bodies are moving together, if the bodies move together, okay, then what equation you are going to write? You are going to say that the acceleration is equal to the net force divided by the total mass. How much is the total mass? The total mass is going to be m1 plus m2. So this is the equation number 1 for this situation. Yes or no? Definitely yes. What can I say for the second situation? Now the block number 1, 2 and 3, all three move together. So can I say that the acceleration in this situation is going to be force divided by m1 plus m2 plus m3? Can we say this? Definitely yes. Okay, that's fine. Next situation that I'm giving you, let's say if the bodies are tied together. Okay, if the motion is connected through a string. Try to understand, very important discussion this is. All of you focus only at one point. Okay, let's say these are the two bodies. If the bodies move together, if let's say this is the string that you are pulling with, okay, this is m1, this is m2. Can we say that if the bodies are moving together, they are moving with the same acceleration? Yes or no? Definitely yes. So can I say that the force applied equals the total mass, that means m1 plus m2 times the acceleration? Yes. Can we say this? Definitely yes. So if I want to find out the tension over here, do one thing, go and sit on the block number B. Who wants to sit on the block number B? Let's say Rachna is sitting on the block number B. So ask Rachna that Rachna, who is pulling the block number B? Who is pulling the block number 2? What is Rachna going to say? Rachna is not going to observe the force F. She is going to say that the tension is going to pull the block number B. So can we draw the individual FBD of block number B? Can we individually draw the block number B something like this? And can we say, who is this? This is Rachna. Okay, so Rachna is sitting over here. Rachna is sitting over here. Okay, ask Rachna that who is pulling you. She is saying that tension T is pulling me. Okay, that's fine. So what's the expression going to be? T equals to M2 times of A. Okay, so what is the acceleration? What's the value of acceleration? Acceleration is common, na? Acceleration is common. How much is that? That's F divided by M1 plus M2. Substitute this value over here. So the tension is M2 times of F upon M1 plus M2. I hope that this condition is absolutely fine. Please note it down. Simple, direct condition. Okay, let's take the discussion ahead. Here we go. Here we go. If we talk about the connected motion through a string, if we talk about the connected motion through a string, this is the only force that's acting in the situation. That's the force of tension. That's the force of tension. Okay. Force of tension acts on the body in the direction away from the point of contact. Now see, the thing is, Vaibhav Mangalam is saying 183 watching. What a number, sir. See, it doesn't matter to me that whether 183,000 people are watching or 183 are watching. Even if one student is watching, I'm going to deliver the same syllabus with the same intensity. Okay. Even if no one is watching, I'll give it recorded. Later on, someone can watch. Okay. So that makes no difference. Okay. That how much students, it's not like that if more students are watching, then I'm going to give more efforts. Okay. It's not like that. So every person who is sitting over there, every student who is there is important to me, is equally important to me. Now see, come over here. If this is the string, if this is the string and this is a block and this is the block, okay, then in this situation, what happens? There is one force mg acting downward. Definitely there is tension in the string. That's why the string is, straight. If we talk about, I'm not getting a string, or else I would have demonstrated it. See, the only thing the string can do, that it can pull. Imagine that this is the block and this is a string. So it can pull something like this. It can pull something like this. String cannot push. String cannot push. Okay. String can never push. Why? Because the direction of tension is assigned always away from the observer. Let's say this is a person. So what is the direction of tension he is going to say? He is going to say that the direction of tension is upward. If some person is sitting at the top, he is going to say that the direction of tension is downward. That means tension has no fixed direction. It depends that from where are you observing the situation. Okay. Strings are assumed to be inextensible so that the magnitude of acceleration is always same. In order to produce tension in a string, the two equal means if the string is producing some tension, then it is taken equal from both the observation points. It's as simple as this. Okay, so let's take the discussion ahead. And here we go. We have seen this condition. We have seen this condition. We have seen that tension. We have seen that in this situation, acceleration is what? That's the force divided by the total mass m1 plus m2. And then what can you say about the tension T? Quickly, now you can say tension equals to mass into acceleration. You can substitute the value of acceleration over here and get the answer. Okay. The 3-block system also you have seen. 3-block system also you have seen. What do you say in the 3-block system? Acceleration is force divided by the total mass m1 plus m2 plus m3. If you want to find out T1, go and sit over here. Go and sit over here. Okay. Now what you're going to say? You're going to say that the tension T1 is going to be mass. How many masses T1 is pulling? How many masses T1 is pulling? T1 is pulling m1, m2 plus m3. Yes or no? Times the acceleration. Fine. Substitute the value of acceleration. What is T2 going to be? T2 is going to be mass into acceleration. Substitute the value of acceleration. So these are the different cases for the connected motion. Okay. Yeah. So let's take the discussion ahead. Here we go. Now see, this is about the tension in a rod. This is a nice, this is a nice concept. Try to understand. This is a rod. Okay. And if the rod is moving with some acceleration, every single point in the rod is moving with the same acceleration. Definitely yes. Okay. So let's say the F force is pulling the rod. Every particle is moving with the same acceleration. But now what you need to do, you need to find out the tension at some given point in the rod. All of you. Who wants to sit on the rod? Dynamic creator is saying that, sir, I am depressed because less time is left as I am scoring 110 in the previous attempt. Chill. Okay, we are studying now. Just focus on the concepts. These questions are going to come in the examination, in NEET, in JEE mains. Just focus on the concept. Who want to sit on the rod? Let's say we are making this person, dynamic creator, sitting on the rod. Okay, see, you are sitting over here. You need to find the tension at this point. So can you say that this rod is made up of these two segments? Let's just say that this rod is made up of these two segments and it's tied with some string. Let's imagine that the rod is made up of two segments. I have divided the rod into two segments, and who is pulling the back segment? Who is pulling the backward part? The tension is making the part pull, isn't it? The tension is making the backward part move. Okay, is this point cool? Okay, so this is T. So can we say that the force is equals to mass, whatever the mass of this part is, this is some m dash into acceleration a? Can we say this? Definitely yes. So what is m dash? How can we compare m dash? How can we find out m dash? Unitary method. How can we find out m dash? Unitary method. L length corresponds to m mass. Unit length corresponds to m upon L mass. Unit length corresponds to m upon L mass. Okay. So how much length is this? This is L minus x length. How much length is this? This is L minus x length. This is x length. Okay. So the mass of this segment, let's call it as m dash. This is m by L times of L minus x. So you have L minus x. So you have found the mass of the segment. You have found the mass of the backward segment. Okay. So you can say that tension is equals to m dash, that's m by L bracket L minus x times of G, times of A. Okay, and what is A? Acceleration is nothing but force divided by mass. So this is the expression in front of you. This is the expression. This is important. Okay, this is important. This is very important. Multiply L inside, multiply this L inside over here. So you get the expression something like this. Okay, m gets cancelled out. So this is F times of 1 minus x by L. Important. Okay, is this point very clear? Cool. Let's take the discussion ahead. So here we go. Apart from this, the pulley mass system. So tell me that how do we resolve this pulley? How do we find out the individual accelerations? Let's say this is A downward and this is A upward. Okay. So in this situation, the masses are same. So in this situation, is the pulley going to move? Yes or no? Quickly, all of your answers in the chat. Ajay, Hindumurthy, Prodipta Das. Is the pulley going to move? Definitely no. Why? Because T equal to mg. It's going to be balanced. No motion. Okay, that's fine. In the next situation, if let's say m1 is greater than m2, m1 is greater than m2, then this is going to be the direction of acceleration. Yes or no? Definitely yes. So let's apply the second law. This is m1g, this is t. So we are going to write m1g minus t equal to m1a. Can we write this? Definitely yes, we can. Can we write this? Definitely yes, we can. Over here, t minus m2g. Over here, what can we write? We can write t minus m2g equals to m2a. So these are the two equations in front of you. These are the two equations in front of you, isn't it? Solving them, you get t equals to twice of m1 m2g upon m1 plus m2. And what's the value of a? That's m1 minus m2 upon m1 plus m2 times of g. Isn't it? Is this point very clear? So let's take the discussion ahead. After this, if this is the situation in front of you, see, these are the cases. These cases are very, very important. The cases that we are going to discuss now, these are very important cases. Exactly this kind of questions you are going to get in the examinations. Lot of questions from these concepts are being asked. Okay, like I remember this is written r equal to root 2t. This is the net normal reaction on the hinge of the pulley. Same this question was asked in JEE mains 2015 or 16 something. Okay, same this normal reaction question. Okay, n number of times these questions are being asked. If this is the situation, no friction is there, so definitely the body is going to move downward. What are the equations you are going to make? This is m2g. Now listen, just observe the system. No need to write any equation. Just observe. Which is the pulling force? Which is the driving force in the situation? Who is the driving force? Which force is going to make the system move? Only there is one force in the situation, and that's m2g. That's m2g. Okay. The only force that's going to make the system move is m2g. So the driving force is m2g. If I apply Newton's second law, that the net force equals to mass into acceleration, it's going to accelerate whom? m1, m2, or both of them? It's going to make which bodies accelerate? m1, m2, or both of them? Definitely both of them. Yes or no? So can I say that the net force equals to F net equals to total mass, and both are going to move with the same acceleration a. So from here, can I write that a is equals to m2 upon m1 plus m2 times of g? Can I write this? Definitely yes, I can. Okay. Sir, if we try to figure it out with the equations, can we? Definitely yes. What's going to be the equation number 1? It's going to be m2g minus t equal to m2a, and the next equation is going to be t equal to m1a. Just substitute the value of t over there. Just substitute the value of t over there, you get the same expression. Substitute the value of t over there, you get the same expression. I hope that the concept is clear. Concept is fine. Is this point very clear? Concept is fine. Okay, let's take the discussion ahead. Let's take the discussion ahead. Another case, another system in front of you. Another system in front of you. Now let's say that m1 is greater than m2. Okay. Which is the driving force? Orally. Which is the driving force? All of you. Which is the driving force in this situation? There is only one driving force. There is only one driving force. That's equal to how much? That's equal to m1g. Isn't it? How many masses is it going to accelerate? It's going to make 3 masses accelerate. Yes or no? Which are these 3 masses? m1, m2, and m. So can I say that the driving force F net, that means m1g equals to m1 plus m2 plus m times of a? So can I say that the acceleration is going to be m1j divided by, can I write this? All of you? Simple. Do we have to mug up any formula? Definitely no. Is the concept absolutely clear? All of you? If I add friction in this situation, simply I have to subtract the frictional force. Is the point very clear? So let's take the discussion ahead. Now I'm going to make the situation inclined. If this is the inclined situation, just resolve the forces. If you resolve the forces correctly, 80% of the task has been done. To be very clear, if you just resolve the forces properly, 80% of the numerical has been done. If this is M, this is mg. If this angle is theta, this angle is theta. This is mj cos of theta. This is mj sine of theta. Okay. In this situation, let's say m1 is greater than m2. m1 is greater than m2. First of all, you need to check the pulling force and the stopping force. If m1g is lesser than m2g sine theta, body is going to go this side. If this force is greater, it's going to pull. It's going to get up. If m1g is greater than m2g sine theta, the body is going to travel in this direction. That's fine. Okay. Either you can make equations or apply the direct logic. Whatever you like. Whatever you like. Okay. See, I am directly going to write that the driving force F net is going to be m1g. That is equals to mass into acceleration. How many masses? m1 plus m2. Okay, just a second. The net force in this situation is going to be the driving force minus the stopping force. Which is the driving force? Driving force is m1g, and which is the stopping force? That's m2g sine of theta. That's m2g sine of theta. Okay, just a second. Let's come back to the previous case also. See, over here, if you talk about the net force, that's going to be the driving minus the stopping. So just a second, let's write it as m1g, the direction is this side, m2g, this is over here, so this is m1g minus m2g, so the driving force is m1g, the stopping force, which is the stopping force, that's m2g. So how much is the net force in that situation? The net force is m1 minus m2 times of g. Okay. How can we justify it with the equation? You can write the first equation to be m1g minus t equal to m1a. Second equation you can say, let's call it as T1, tension T1 over here. Second equation you can say T1 minus T2 equals to capital M times of A. T1 minus T2 is capital M times of A. Yes or no? In the third situation, this is T2. Who wants to sit on the block number? M1, M and M2. Let's say Vasuki is sitting on the block number 1. Make Vasuki sit on the block number 1. Okay. Make Daya sit on the block number 2. And make Riya Soni sit on the block number 3. Okay. Riya is sitting on the block number 3. Ask Vasuki, first of all, that what are the forces acting on Vasuki? What is he going to say? M1g in the downward direction, T1 in the upward direction. So what is the equation? M1g minus T1 equal to M1a. Yes or no? Definitely yes. Ask Daya that what are the forces? T1 minus T2 equal to M into A. Now ask Riya. This is simply T2 minus M2g. T2 minus M2g. Let's write it this way. Let's write the third equation over here. Just a second. The third equation is going to be T2 minus M2g equal to m2a. Method number one, either you can solve equation number 1, 2 and 3. Either you can solve equation number 1, 2 and 3. Method number 2, you can simply write that F net equal to total mass into acceleration. What is F net? The driving force minus the stopping force. What is the driving force? m1g. What is the stopping force? m2g. Okay, this is the net force. Equals to total mass. How much is the total mass? m1 plus m2 plus capital mass m into a. So this is the equation in front of you. Okay, this is the equation in front of you. Is this point very clear? Is this point absolutely clear? Subha, is this point very clear? All of you. Let's come to the next point. Let's come to the next point. Subha is saying NEET oriented teach कीजिए. बेटा इसमें NEET और मेंस दोनों के क्वेश्चन है. We are discussing NEET as well as JEE mains concepts. Okay, because a lot of questions in NEET are reflected from JEE mains and same in mains also. Okay. Samarth is saying please take my name. Now we'll make Samarth sit in this situation. Okay, so Samarth is going to give the equation. Let's say that Samarth is sitting on this block and another person who wants to sit, Manoj, is sitting over here. Manoj is sitting on this block m1. So tell me one thing, if m1 is greater than m2g sine theta, that means this force is greater than this force. Acceleration is going to be along this direction. That's cool. Yeah. So what's going to be the equation that Mr. Manoj is going to say? Manoj, na? This is Samarth, that's Manoj. Yeah, what's the equation that Mr. Manoj is going to say? Quickly. Fast. This is, what is this equation? This is simply m1g minus t equals to m1a. That's fine. And what is the expression that's going to be over here? Varman, quickly tell me. This is going to be t minus m2g sine of theta equals to m2a, equals to m2 times of a. Yes or no? These are the two equations in front of you. These are the two equations in front of you. Either solve these two equations or apply the direct logic that I gave you, that F net equal to ma. F net equal to ma. Aditi, tell me what's going to be the direct expression for this situation. F net, how much is F net? F net is m1g minus m2g sine of theta. This should be equal to total mass times acceleration. So equate both of them. Okay, and find out the value. It's up to you. Is this point absolutely cool? Let's take the discussion ahead. So here we go. Okay, if we talk about a spring is a very interesting discussion. Spring is one of the most important discussions. See, if this is a spring and you pull a spring, so what force does the spring applies? If you pull this spring, okay, let's say you are taking the spring from point A to point B. So what force does the spring applies? It applies a restoring force, and that restoring force is proportional to the displacement, and it is along the opposite direction. So when the proportionality is removed, the restoring force or the spring force is minus of kx. Spring force is minus of kx. Okay. Problems we are doing, don't worry. Ayush Patkur. Don't worry. Every problem we'll be doing. Okay. First of all, we have to cover some concepts. Quickly tell me that this is going to be minus of kx. What is k? K is known as the spring constant. That's F divided by x. What is F? F is Newton. What is x? X is meter. So this is Newton per meter. Okay. Here we go. Let's try a numerical. After that, we'll be taking the discussion ahead. We have seen the concept of Mm, 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 mm. Yeah. Uh-oh. Yes. Read the question. Read the question, all of you, quickly. The ratio of weight of a man in a stationary lift and when it is moving downward with the uniform acceleration. Now, this is simply the application of second law that we have studied. Let's check how many of you can do this quickly. All of you, the ratio of weight of a man in a stationary lift and when the lift is moving downward with uniform acceleration is 3 by 2. The value of A. That means if the lift is a stationary, okay, this is the man standing on a weighing machine, something like this. Who wants to stand in this stationary lift? This is Aditi standing over here. Okay, Aditi is standing over here. And in the second situation, what's happening? The lift is moving. In the second situation, what's happening? In the second situation, the lift is moving. Where is it moving? Where is it moving? Downward with some acceleration A. So the ratio of weight, weight is the normal reaction, okay, is given as 3:2. Do this quickly. All of you, A, B, C, D. 45 seconds for this question. 3, 2, 1, begin. Time starts now. Let's see how many of you can apply the concept and get the answer. Fast. Quick, all of you. Last 10 seconds. Okay, so time up. Now see what the situation is, what the condition has been given to you. What the question says that in the first situation, if the lift is stationary, then what can you say? You can say that the normal reaction equals the weight of the person mg. In the second situation, the lift is coming down, the elevator is coming down. So what are the different forces acting over here? This is m1g. This is normal reaction n2. This is the acceleration. So you can say that m1g minus n2 equals m1 times of a. Okay. This is the expression in front of you. Okay. So what can you say regarding n2? n2 can be written as m1 times of g minus a. Okay. So divide the two. Divide the two. Simply what do you get? You get, let's write it over here. Let's do it over here. Let's do it over here only. Okay. So what do we get? We get n1 divided by n2. We get n1 divided by n2 is simply whatever the mass of the person is. Let's call it as m only. Neither m1, neither m2. This is m. Okay. M. Okay. M gets cancelled out. M gets cancelled out. This is g divided by g minus a. The ratio has been given to you as 3 by 2. So what is the answer going to be? It's going to be 2g equals to 3g minus 3a. Isn't it? So what is a going to be? 3a is going to be how much? That's going to be 3a is going to be how much? That's going to be g with a negative sign. That means it's going to be g by 3. It's going to be g by 3 downward. Downward, that's why negative. Yes. So the answer is B. How many of you got B? Very good. Very good. So do this plus 4. Those who got a -1, those who got wrong answer, please do that -1. Let's come to the next question. Let's come to the next question. The next question in front of you is this. Read the question again. +4 -1. 45 seconds for this question. Okay. Yogin, Aditi, Manoj, Subha, Gautam, Sakshi, Ishika. Ready? So, what the question says, two blocks of masses 4 kg and 2 kg are connected to the ends of a string which pass over a massless frictionless pulley. The total downward thrust on the pulley. There are two masses connected something like this. Okay, that's fine. M1 and M2. Okay. 4 kg and 2 kg. You need to find out the total downward thrust on the pulley. So I'm giving you 45 seconds for this question. The time starts now. All of you begin quickly. Simple question. Be quick. Fast. Let's see what you do. Quick. Give the answers. Fast. Okay, so finally time up, and the situation is going to be something like this. See, this is the tension T, and the tension over here in this situation is going to be how much? The tension on this string is going to be 2 times of T. So what can you say regarding the tension? You know that the tension T is 2 times of M1 M2 divided by M1 plus M2 times of G. Can we write this? Definitely yes. Simple. So how much it's going to be? It's going to be 2 times of 4 into 2 divided by 4 plus 2, that's 6 times of G. This is 10. Okay. So this is how much? This is 3 and this is 8. 3 is 8 into 10, 80 divided by 3. Okay. So you need to find out 2T. 2T is going to be how much? That's going to be 160 divided by 3. That means nearly how much it is? This is nearly 54. How much is the tension going to be? How much is the value of 2T going to be in the situation? That's going to be simply, oh sorry, this is going to be, just a second, this is going to be 2 times of 4 into 2 divided by 4 plus 2, that's 6. This is 3. 8 times 80 divided by the 3. So 54. How much is going to be? 54. T to T, total downward thrust on the pulley. Downward thrust on the pulley is going to be how much? Total downward thrust. 54 or 27? Quickly, all of you. 54 or... Yes, Lalita, got your comment. First of all, give the answer to this question. Half of you are saying as A, half of you are saying as B. How much it's going to be? 2 times of T. 54 or 27? Total downward thrust. Total downward thrust we need to find out. Quickly. How much is it going to be? Just a second. How much is the total downward thrust going to be? T and T downward. Oh, still people are saying 27. See. How much is the tension? The tension T is 2 times of 4 into 2 divided by 6 into 10. Is this the value of tension? Definitely yes. So into do this, multiply this by 2. Okay, so how much do you get? You get it as how much? This is 8. 8 into 2, 16 into 10, 160 multiplied by 2 divided by 6. Calculate this. This is going to give you the answer. Okay, because the total downward thrust is going to be 2 times of T. So those of you who got it as positive, who got it as the correct, mark it as +4. Rest of you mark it as -1. Okay. Next question is this, on the conservation of momentum. What the question says? The question says that a boat of mass 40 kg is at rest. A dog of mass 4 kg moves in the boat with a velocity of 10 meter per second. Okay. What is the velocity of the boat? What the question says, a boat, this is the boat All of you focus over here. This is the boat. Let's say it is M1, 40 kg. This is at rest. Initial velocity is 0. Okay. After this, what happened? A dog of mass 4 kg moves in the boat. This is the dog. Okay. This dog jumps in the boat. This dog jumps in the boat with 10 meter per second. V2 is 10 meter per second. Okay. So what is the velocity of the boat? What we need to do in this situation, total initial momentum equals to the total final momentum. Total initial momentum equals the total final momentum. Is the initial momentum 0? Is the initial momentum 0 because the velocity of the boat is 0? You need to find out the final momentum. 20 seconds for this question. 3, 2, 1. The time starts now. Begin. Only 20 seconds for this question. Fast. Quick, quick, quick. Last 8 seconds. 0. You don't watch over here. I'm solving it. How much it's going to be? Time up. Total mass into the common velocity. So what it's going to be? 0 equals to M1. M1 is 40. Okay. Plus. Just a second. Let's talk about the isolated system. This over here is the isolated system. Okay. This is the isolated system in front of you. So if I talk about the system, we never apply the momentum conservation on the particle. We always apply on the system. So who is there in the system? There is the boat and there is the dog. Okay. So the boat is initially at rest. The boat is at rest and the dog is moving with certain amount of velocity. Okay. The dog is moving with certain amount of velocity. So the initial momentum of the system must be equal to the final momentum of the system. That means initial momentum of the dog. That's going to be how much? Mass of the dog. How much is mass of the dog? 4 into the velocity of the dog 10 equals to the final system. The final system is dog plus the boat times the common velocity Vc. Times the common velocity Vc. So how much it's going to be? How much is it going to be? How much is the system going to be? Vc. What is it? 40 divided by 44. So this turns out to be nearly 1 meter per second. Nearly 1 meter per second. Okay. So what is the velocity of the boat? This man moves in the boat with a velocity this much. What is the velocity of the boat? So this is going to be the combined now. This is not going to be exactly 1. Isn't it? How you're saying exactly 1? It's going to be nearly 1 because if the boat is at rest, the dog of mass moves with certain velocity into the boat. They are asking about the velocity of the boat. Both are going to move with the same velocity. Both are going to move with the same velocity. That means it's going to be nearly 1. Okay. Okay, so let's take the discussion ahead. Here we go. Lap number 4 is going to be work, power, energy. Lap number 4 is going to be work, power, energy. So we are getting started with the discussion of work, power, energy. What is Pushpa saying? Yes, definitely. We are taking it fast now. So Manoj is asking why 40 plus 4. See, why 44 plus 4? Because in the system, if the dog is jumping inside, if the dog moves in the boat with certain velocity, now both of them are going to move with the same velocity. Both of them are going to move with the common velocity, isn't it? Initially, the dog was coming towards the boat. The dog was coming towards the boat with certain velocity. Finally, both of them are moving together. Both of them are moving together. Okay. Yeah. So we need to discuss work, power, energy, but before that, we'll be shortly doing some more questions. Let's do 2 or 3 more questions, then we'll be beginning with the work, power, energy. Try this question. Block of mass M is pulled along the horizontal frictionless surface by a rope of mass M. There is a block of mass capital M, and this block is pulled along the horizontal frictionless surface with a rope of mass small m. If a force P is applied at the free end of the rope, the force exerted by the rope on the block. We'll be doing friction, don't worry. We'll be doing friction right now. Don't worry, it's included with our work power energy. Okay. So, what is going to be the answer? Is the question very clear? Let's begin in 3, 2, 1. 45 seconds. 45 seconds. The time starts now. All of you begin. Quick. Fast. Quickly, 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 all of you. Do this. Fast. All of you be quick. Here we go, here we go, here we go. Last 5 seconds. 4, 3, 2, 1. And here we go. Now see, this is the direct question. What it says that if you apply a force P, how much force you have applied? P on the free end of the rope, at the free end of the rope. Okay. So this is the whole system in front of you. This is the system in front of you. First of all, what you write? You write that the net force is equal to total mass into acceleration. So the acceleration is going to be P divided by M plus M. You need to find out the force exerted by the rope on the block. That means you need to find out the force at this point. Okay. Let's call it as F or F dash. So you can simply say that F or F dash is going to be mass M times the acceleration. Substitute the value of acceleration over here. So what do you get? You get the value as MP upon M plus M. That means the answer is going to be A. Okay. MP upon, capital M. Sorry. It's going to be D. Okay. PM upon M plus M. So all of you who got it as correct, mark it as +4. Who got it as wrong, mark it as -1 and tell your scores. Give me your scores. Give me your scores. What are your scores? Quickly. What are the scores in the present situation? All of you. What about your scores? Now see, we are discussing about a force. We are discussing about a force that tries to stop the impending motion, relative motion between the two bodies. Okay. And this force is what we call as the friction. Let's say this is the system, a block kept on a surface. If you apply a force on the body, what's going to happen? Let's say this is you standing over here, applying a force on the body. Okay. So if you apply a force, if you try to push the body resists the motion. Why it resists the motion? Because there is some force acting between the block and the body, which does not wants the body to move. This is the force of friction. Okay. So let's say you increased the external force. The force acting over here also increased. You again increase the force again increased. Up till when? Up till a particular limit. After that, what will happen? After that, the body will move. The body is going to resist till the point it can resist. After that, the body is going to move. Okay. So we are discussing about a contact force. It does what? It opposes the relative motion between the two bodies. What it does? It opposes the relative motion between the two bodies in contact. Okay. So this is the concept of friction. So basically, what is the cause of friction? There are two views regarding the friction. The first thought is that the bodies have molecular level irregularities. The two bodies which are in contact with each other, they are having molecular level irregularities and they form peaks and valleys. What do? They interlock the surfaces. The interlocking between the surfaces take place. That means this is body number A, this is body number B. So no matter how polished the surfaces are, they are actually uneven at the surfaces. Molecular level irregularities are there. And what happens when the two bodies are in contact? They get interlocked. And if you try to move these bodies relative to each other, they are going to oppose each other. Okay. Now this was the old view. This was discarded. You know why? Because the reason of friction is not interlocking. The reason of friction is not interlocking. It is the intermolecular force of attraction between the two bodies. Friction is electromagnetic force. Okay. It's the intermolecular force of attraction that's happening between the two bodies due to which there is attraction. Okay. So here we go. Here we go. If you talk about the dry friction, simply when the bodies are in contact, the solids, unlubricated solids, this is dry friction. If you talk about the fluid friction, that's the viscosity. Okay, the friction that acts between the layers of a fluid, the friction that acts between the layers of a fluid is what we call as viscosity. If let's say this is the surface, if let's say this is the surface and this is the block, okay, you are applying a force, F. So there exists a maximum value until which the body is going to oppose. Okay, that maximum value is what we call as the force of maximum static friction or the limiting friction. What do we call it? We call it as the force of maximum static friction or the limiting friction. Okay, so this force of maximum static friction or the limiting friction is dependent upon the normal reaction, and you write the expression to be mu times of n. What do you write it as? Mu times of n. That means it depends upon the normal reaction. Okay, what is mu? Mu is the coefficient of friction. Okay, what is the direction? What is the direction of friction? It's always opposite to the direction in which the body is on a verge of moving. Body is on a verge of moving. That means not the body is moving. It is having the tendency to move. Let's say you have kept the body something like this. You are applying a force in the right direction. The friction wants to act in the left direction no matter the body is moving or not. Okay. You apply the force in the left direction. The friction will apply in the opposite direction somewhat over here. Okay. That's fine. Let's take the discussion ahead. This is always slightly less than the limiting friction. What? The kinetic friction. Now see. Let's say if you talk about a condition, let's say mu is given as 1 by 2. Try to understand a conceptual question I'm giving. Okay, the body is weighing 10 kg. How much the body is weighing? The body is weighing 10 kg. Okay, yeah, that's fine. So what is the value? What is the value of maximum force that can act in the situation? You can say that the F max can be mu times of normal reaction. That means it can be 50. Okay, it can be 50. Let's say you apply a force of 10 Newton. Find out the acceleration. Find out the acceleration of the block. Find out the acceleration of the block. Okay. Find out the acceleration of the block. 4 meter per second square. 2 meter per second square. Minus 4 meter per second square. Okay. And D 0. Quick. Fast. All of you. Tell me the answer. Based upon this, we are going to have a very important discussion. Let's see how many of you give the correct answer. What you mark? Quick. What's the answer? Kashnikant is saying 0. Ishika is saying C. Lalita is saying 0. Arpan is saying 0. Indumurti is saying D. Riya is saying D. Some are saying -4. See, what is the maximum value of friction that can act in the situation? What is the maximum value of friction that can be possible in the situation? That's 50 mu times of n. You are applying a force of 10 Newton. You are applying a force of 10 Newton. Is the body going to move? Is the body going to move? Definitely no. Is the body going to move? Definitely no, it's not going to move. So the acceleration is going to be simply 0. So if you apply a force, if you try to plot the graph between friction and the applied force, the graph is going to be something like this. The graph is going to be something like this. That you increase the value of the force, the friction increases. You increase the value of the force, the friction increases up till a certain value. Up till a certain value. Okay, after that what happens? After that, the friction remains same. This value of friction is what we call as the maximum static friction. And after that, which friction is acting? After that, the body started moving. That means now the kinetic friction acts in the situation. After this, the kinetic friction acts in this situation. Okay, and you can see that the kinetic friction is slightly lesser than the static friction. Okay, I hope that this point is absolutely clear. So let's take the discussion ahead. Okay, some important points regarding the friction that you should remember as it is. Frictional force always opposes the tendency of relative motion. First point. The force of static friction exactly balances the applied force during the stationary state. If the body is stationary, the two forces are balanced. Static friction is self-adjusting. That means if you change the direction of applied force, the direction of friction changes. Frictional force is a contact force parallel to the surface in contact. Okay. The component of contact force along the direction of the surface. That means parallel to the surface in contact and directed as so oppose the relative motion or attempted relative motion. That means it's going to either oppose the relative motion or the tendency to have relative motion is going to be opposed by friction. Okay. In exceptional cases, mu s and mu k can exceed unity. This is the condition of cold welding. That means if two highly polished surfaces are pressed with extreme pressure, this is what we call as cold welding. Okay, remember this. Okay, let's take the discussion ahead. Okay, so angle of friction. What is basically the angle of friction? Angle of friction is simply the resultant. See, listen, this is the surface, this is the normal, this is the surface, this is the normal. Okay, so if you are applying a force F, something like this, where is the friction going to act? This is the friction going to act, and this is the normal reaction. Okay, so what is the resultant? What is the resultant of friction and normal reaction? This is the resultant of friction and normal reaction. This is the resultant of frictional force and the normal reaction. So angle of friction is simply defined as the angle which the resultant of the limiting friction and the normal reaction makes with the normal reaction. Let's call it as lambda. This is the angle of friction. Simple. What is the angle of repose? This is the body. It's not sliding. Still it's not sliding. Still it's not sliding. At particular angle it will start sliding. That angle is what we call as the angle of repose. That means the angle till which the body opposes its motion. Mg sine theta equals the force of friction. So what can we say? We can say that mg sine of theta equals to mu times of n. What's going to be the normal reaction? N is going to be mg cos of theta. So from here you can say that the angle of repose tan theta is going to be equal to mu. Is this point absolutely clear? So we have finished friction as well as NLM. Now we are going to begin with work power energy, circular motion, rotational and center of mass in the upcoming session. That means after the break. Okay. So we are having a break. After the break, work power energy, center of mass, rotation, okay, and circular. Definitely circular. This would be done from 10, what's the time? 10 it is, na? It's 10. So we'll be doing from 10:20 to 12:20 onwards. 10:20 onwards. Okay. So. This is 10. We are going to meet over here. 10:20. We are going to meet over here at this point. Okay. Have food. After this, we'll be observing the next topics. Cool. Yeah. We'll be discussing box over blocks in work power energy. Combined numericals we are taking, in which the topic that you're asking, the block with the block friction included, we will be doing these questions in WPE. PDF would be at the app. Okay, PW app. It's free of cost. You can simply download from the app. Banking we are going to do in the NLM session. Sorry, in the circular session. After this circular, we are going to do banking and all. Yes, we are going to do banking, death of well, and everything in circular. Okay. Banking. So let's meet at 10. Okay. All of you, let's meet at 10. So see you all. Quickly have dinner. Fast, all of you. Hello, 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 hello. Hello, 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 hello. Am I audible? All of you? Can you hear me? All of you? Can you hear me? Welcome back, all of you. Am I perfectly audible? Okay, okay, okay. Okay, okay, okay. So, let's get started. Let's get started with our discussion. Just a second. We are getting started in a minute. Just wait for a moment. Here we go, here we go, here we go, here we go. Okay, okay, okay. Yeah, just a second. Okay, yeah. So let's continue the discussion. We are back. What were we discussing? We were discussing regarding the friction. Okay. One small application of friction, the comparison of pushing versus pulling. Let's have a look at the comparison of pushing and pulling. If I give you two situations, then what after 12:20? Let's see. We'll be completing the whole syllabus. Don't worry. The complete syllabus will be completing. Okay. So if this is a block, this is a block, this is another block. And what you're doing in these two situations, in first situation, you're pushing at some angle. In another situation, you're pulling at some angle. So let's try to figure out the amount of effort that's required in the two situation. Let's say we are measuring the angle from the vertical. Let's say we are measuring the angle from the vertical theta. If this force is F, if this force is F, this is F sine of theta. This is F cos of theta, isn't it? Definitely yes. If this force over here is F sine of theta, this force over here is F cos of theta. So tell me that how the normal reaction is going to change. How the normal reaction is going to change. The normal reaction is going to change something like this. In this situation, you can say that the forces acting on the body, this is F cos of theta, this is mg, and this is the normal reaction. So you can say that the normal reaction in the first case is going to be how much? That's going to be mg plus F cos of theta, isn't it? Definitely yes. In the second situation, what are you going to say? In the second situation, what are you going to say? In the second situation, what are you going to say? All of you focus over here. All of you focus over here. What can we say in the second situation? This is going to be mg. This is going to be F cos theta. And this is going to be the normal reaction. Okay. So the normal reaction in the second situation is going to be mg minus F cos of theta. That's fine. That's cool. Okay. So if you compare the normal reactions in the two cases, you can clearly see that the normal reaction in the second situation is lesser in the first. Normal reaction in the second situation is lesser than the first. So definitely the frictional force acting in the second situation is going to be lesser as compared to the first. So this is easier. That's why we say that pulling is easier, okay, as compared to the pushing. Okay, so here we go. Let's say you have a two block system. All of you try to understand. Let's say if this is a two block system and we are applying a force on the lower block. I am giving you the conditions. Try to understand, all of you. Let's figure out a condition in which we have two blocks. Block number one, and block number 2, block number 1 and block number 2, that's fine. This is A, this is B. You are applying a force F. You are applying a force on the lower block. You are applying the force on the lower block. Okay. So if you apply a force on the lower block, both the blocks are moving together. If both move together, if both the blocks move together, can you say that the acceleration in this situation is going to be force divided by the total mass? Force divided by the total mass. What is the total mass? The total mass is MA plus MB. The total mass is going to be MA plus MB, isn't it? Now the question is, who makes the body B move? You are applying a force on body A, but still the body B is also moving with A. Which force is responsible for the movement of B? Which force is responsible for the movement of B? Let's draw the individual FBDs of the two blocks. This is the force F. Okay. So the frictional force is going to oppose the motion of A, and the frictional force is going to make the body B move. Okay. So we are going to say that the body B is moving due to the friction. Okay. So you're going to say that the only force acting on the body B is frictional force. So it's going to be mass into acceleration. That's fine. That's fine. Is this point clear? The only force acting on the block B is the frictional force. So what are we going to write? We are going to write that the frictional force maximum can be mu times of N. Isn't it? Equate it with the given equation. So from there you find out the limiting value of acceleration. Okay. Try to understand what I am saying. Let's understand this concept with a numerical. What I'm saying, if this is the frictional force, this is the maximum value of frictional force, and this is the required value of friction. Okay. So if the maximum value is greater than or equal to the required value of friction, that means there is 100 Newton of force required and the maximum value of friction is 110. So definitely they are going to move together. If not, they are going to get separated. If not, they are going to get separated. If the maximum friction greater than equal to the frictional force which is required, then bodies move together. Okay, then the bodies move together. Okay, let's understand the situation with a question. You just tell me whether the bodies do the bodies move together. Okay, just tell me that are the bodies going to move together? See, block number B, block number A. Okay, the ground is frictionless. Coefficient of friction between the block B and A is 0.2. How much it is? It's 0.2. Okay. This is 15 kg. This is 10 kg. Okay. 10 kg, 15 kg. You apply a force of 100 Newton. Okay. You apply a force of 15 Newton. 15 Newton you are applying a force. Whether these bodies are going to move together, or they are going to get separated. Quick, all of you. Conceptual question in front of you, quickly. Whether the bodies are going to move together or they are going to get separated. This is what you are going to answer. Fast, I am reading your chats. Be quick. Don't take this much time. First of all, steps. Step number 1. Let's say that the bodies move together. Step number 1. Let's say that the bodies move together. If they move together, okay, you can say that acceleration is the applied force divided by the total mass. So what is going to be the acceleration? Acceleration is going to be applied force, that's 15, divided by the total mass. Total mass is how much? 25. So this is 3 by 5 meter per second square, the value of acceleration. 3 by 5 meter per second square is the value of acceleration, common acceleration. Step number 2, you need to check whether this much friction can be provided. Is this much amount of friction possible? If you talk about the block number B, block number B, so the frictional force makes the block B move. How much friction is required? Mu times of n. 0.2 times of n is the maximum value. Normal reaction is 100. How much is it? How much is it? The maximum friction in this situation is 20 Newton. The maximum friction is 20 Newton. Okay. And what is the requirement to get this much acceleration? What is the requirement to get this much acceleration? It's mass times the acceleration. Mass is 10 times the acceleration. That's 3 by 5. So this is 2. So 3 2 is 6 Newton. How much is required? Why they would separate? See, how much is required? Only 6 Newton is required. Only 10 into 3 by 5. Mass into acceleration. 6 Newton is required. Only 6 Newton of friction is required. And what's the maximum amount of friction that can be possible between the situation? That's mu times of n. Mu is 0.2 times of 100. How much is it? It's 20 Newton. It's 20 Newton. That means what? Quickly, all of you. That means what? That means they are going to move together. Yes, they are going to move together. Simple. The required amount of friction is lesser than the available. The required amount of friction is lesser than the available. Is this point clear? All of you, is this point absolutely clear? So let's take the discussion ahead. Let's take the discussion ahead. Now, we have done the questions. We are going to get started with the lap number 4. That's the work, power, energy. Lap number 4. Yes, Naveen, we are going to complete it. Don't worry. First of all, the concept of work. What is the concept of work? If I ask you a very simple question, that this is you. Who wants to stand over here? Who wants to stand over here? This is the person. Let's take Naveen. Okay. Let's take Naveen. Naveen is standing on a platform. Okay. He's taking some weight on his head. Okay. And he's moving from point A to point B. He's moving from point A to point B. So Naveen has moved from A to B. But when Naveen has reached B, what I said that listen, you have read in class at 8th that work done is force times the displacement, isn't it? Work done is force times displacement, and it's the force along the direction of displacement, and it's the F and S cos of theta. Yes or no? He said, yes, sir, I know this, I remember this. So he said that work done is nothing but force into displacement into cos of theta. This is what Mr. Naveen said. Okay. So then I said that, okay, what's the force acting? What's the force acting on the block? Naveen said that mg is acting on the block. Okay, that's cool. What is the direction of displacement? This is the direction of displacement while going from A to B. So I said that what is the angle between force and displacement? He said that, sir, it's 90 degree. So if the angle is 90 degree, definitely work done should be 0. Definitely work done should be 0. He said yes. Then I asked that you are actually taking a weight on your head, something like this, and you're moving. So is the work done 0? And if it is 0, then in that situation, which force is doing in that situation? Why are you getting tired? Adrika is going to give the answer. Quickly. Tell me. That was a different question. That was regarding push and pull. This is a different question, Adrika. I am asking that if the work done is 0, then why this person gets tired? If the work done is 0, then why this person gets tired? The reason is that on a body at the same time, n number of forces can act. N number of forces can act. Now the force that you're talking about, is mg. In this situation, this is the direction of displacement and this is the direction of mg. So the work done by mg is 0. This is 1 point. Work done by the force of gravity is 0. Work done by the gravitational force is 0. So then the question arises that which force is doing work? Who is doing work? If the block is moving from A to B, let's say this person is taking the block from A to B, the person gets tired actually. Then who is doing the work? The work has been done by the internal force of that person. Okay. The muscular energy is spent in the situation. Okay. Very nice. So what are we saying? We said that first of all, what is work done by a constant force? If the direction and magnitude of a force applied on the body is constant, then simply work done is said to be force into the component of displacement along the force. Force into component of displacement along the force. Okay. After this, if the work done is due to a variable force, let's say that the force that you applied is a variable force. Force is changing according to this expression, x square plus 2x. Find out the work done. Find out the work done. How do you find it out? You find it out something like this. While going from initial position to final position. Okay. That means if I draw the graph between f and x, so the area under the curve of the fx graph is going to give us what? It's going to give us what? It's going to give us the work done. Simple. Okay. So let's find out the work done in this situation. This is going to be integral of x square plus 2x the dx. Just integrate it. And let's take the limit from, let's say x initial is 2, x final is 3. So substitute upper limit minus lower limit. This is going to be x cube by 3 plus 2x square by 2. Okay. So this gets cancelled out. Substitute the limit from 2 to 3, 2 to 3. Okay. Do this and calculate this. Okay. Let's take the discussion ahead. Let's take the discussion ahead. What is positive work? If the force and the displacement are along the same direction. If the force and the displacement are along the same direction, then the work done is said to be positive. If the force and the displacement are along the opposite direction, that means the angle between the force and displacement is 180 degree, then the work done is said to be negative work. Simple. Remember this. Okay. Zero work can be in these following situations. Zero work can be in these following situations. If the body is moving with uniform velocity, if the net force acting on the particle is 0, if you push an object and that object doesn't displaces, okay, if you push an object and that object does not displace, something like this, okay, something like this, that means you're pushing a wall, the work done is 0. Pendulum is oscillating, that means the net displacement is 0. Electron moving in around a nucleus, that means again and again it's coming to the same point, so the net displacement is 0. Satellite moving around the earth, the net displacement 0. Simple. Okay. Dependency on the frame of reference. This is very important. Dependency on the frame of reference. Okay. This is very important. First of all, if you talk about the unit and dimension of work done, that's force into displacement. What is the force? Force is Newton and the displacement is meter. So it's going to be Newton meter, that means joule. Newton is kg meter per second square into meter. So kg meter square per second square. These are the different units of work done. 1 joule equal to 10 to the power 7 erg. Electron volt is also a unit of work done. E, that means Q, charge, into potential difference. Work done equal to Q delta V. Remember electrostatics? Yes. Million electron volt, 10 to the power 6 volt. Okay. So basic discussion. Just read this after the lecture. Just go through this. Now we are talking about the frame dependence of the work done. We are talking about the frame dependence of the work done. Point is that the work is defined for an interval or displacement. There is no term like instantaneous work. You have seen instantaneous velocity, instantaneous acceleration, instantaneous power you will be seeing. But there is nothing like instantaneous work. Okay, there is nothing like instantaneous work. Okay. For a particular displacement, work is independent of time. for a particular displacement, work done is independent of time. When several forces act, work done by a force for a particular displacement is independent of the other forces. That means, let's say on a body, three forces are acting. Okay, force number 1, force number 2, force number 3. F1, F2, and some other force F3 is acting. Let's say it's acting over here, and the body is having some random displacement along this direction. So you can individually find out, find out the work done due to individual forces, and that's independent of the presence of other forces. This is what the net point says. Okay, yeah. Displacement depends upon the frame of reference. We know this. So the work done by a force is reference dependent. Okay, so here we go. Let's take the discussion ahead. Next concept is the concept of kinetic energy. Let's say this is a block. Let's say this is a block. You know that if you displace this block from point A to some point B, if you displace this block from some point A to some point B, then the amount of work that you do gets stored in the form of kinetic energy. Okay, or let's say that the work that you have done goes into changing the kinetic energy. Okay, so can we say that this displacement x, work done, force times the displacement? Now what you can say v square equals u square plus 2as. Okay, or 2as. So v square minus u square divided by 2 can be written as a times of x. Can we write this? Can we write this? Definitely yes. Can we write this? Definitely yes. Now what I'm saying? I am saying work done is force into displacement. Force is mass into acceleration into displacement. So what is a times of x? Substitute this value. Substitute the value of a into x over here. Okay. So when you substitute this value over there, what do you get? You get 1 by 2 m into, you get 1 by 2 m times of v square minus u square. Yes or no? Definitely yes. Okay, so what is this? This is the change in kinetic energy. Okay, yes, you will be getting the practice sheet on the app itself. Okay, this particular notes and the practice sheet will be available on the app. Don't worry. So this is basically the work energy theorem. What it says that work done by all the conservative, non-conservative, internal, external, all the forces goes where? It goes into the change in kinetic energy of the body. Okay, yes, that's what I said now, that in this situation you have max. This is ax. If you multiply m both the sides, you get the expression of max. Substitute it over here. Okay, and what this expression is, this is nothing but the work energy theorem. Okay, so let's take the discussion ahead. Here we go. Let's do a question first, then we'll be taking the discussion further. Okay, let's try a numerical. Let's try some numericals on this. Just a second. Here we go. Yeah. Read the question. Quick. A car is moving on a straight road with constant speed. Then these are the four options. 30 seconds. Okay. 3, 2, 1, and the time starts now. Quick, all of you. 30 seconds, quickly. Simple question. No need to take a lot of time. Quickly. 10 seconds are remaining. Fast. Quick. Okay, time up. What the question says? The question says that if a car is moving on a straight road Okay, if the car is moving on a straight road with a constant speed which is constant, okay, work done against the friction, net work is done on the car, that's zero. Net work done on the car is zero. Net work done may be zero. B and A both are correct. Let's try to understand. First option, work is done against the friction. Definitely yes, work is done against the friction because the body is moving with constant speed. If you want to maintain the constant speed, definitely there is a retarding force acting in the situation, that's the frictional force. So you need to apply some force, and work is done against that force. Yes, body is moving with constant speed, so you are applying a force F. Definitely if the body is moving with constant speed, the applied force, if the body is moving with constant speed, the applied force and the frictional force should be equal. Yes. Okay, first point, work is done against friction, true. Net work done on the car is zero. Net work done on the car is zero because work done by the F plus work done by the frictional force are equal and opposite, because the net force acting on the body is zero. F is acting forward, friction is acting backward. Net force acting on the body is zero. So the correct answer is D. The students who have marked as D, please add +4 to your score. The students who are marked as D, add +4 to your score. Okay, let's try another question. Read this question, all of you. Read this question. Another nice question. One more nice question. What it says: a bullet of mass m moving horizontally with a velocity v strikes a block of mass capital M and gets embedded in the block. The block is suspended from the ceiling by a massless string. Okay, the block is suspended from the ceiling by a massless string. That's fine. Okay, this is the bullet that's going. It gets embedded. The bullet gets embedded. Okay. Change in kinetic will be V2. What are you saying? Just a second, we'll be checking it. Okay. So do this question. Again, you need to find out what? The block is suspended from the ceiling by a massless string. The height to which the block rises, you need to find out the height. +4 -1 for this question. The time starts now. 45 seconds for this question. Begin. All of you. Quick. Fast. Fast, all of you. Apply the conservation of momentum. First step. Apply the energy conservation. Second step. Question would be over. This is what you need to do. Quick. Fast. Okay, time up. So what I said that apply the momentum conservation. That means initial momentum must be equal to the final momentum. So what is the initial momentum? Initial momentum is the mass of the bullet. Mass of the bullet into velocity of the bullet. What is the velocity of the bullet? V. So that's m times of V equals to the final momentum. Final momentum is m plus m times of V dash. Okay, m plus m times of V dash. So from here you get the velocity of the system. Now what is the system? System is small m plus capital M moving with some velocity V dash. Now what it's going to do? It's going to attain some height. It's going to attain some height h. This system is going to attain certain amount of height h. So this whole kinetic energy at the position A is going to get converted into the potential energy at the point B. Isn't it? So what are you going to write? You're going to write that half m plus m times of V dash square equals m plus m times of g h. Okay. If you do this, what do you get? How much do you get? Substitute the value. What do you get? Quickly. This is going to give the option. Calculate this, what it's going to give you. From here, you can find out the value of v dash. Substitute the value of v dash. This gets cancelled out. Calculate. It's going to give you the option A. How many of you got the answer as A? Rahul. Only one. And Darshini. Rahul, Darshini. Nice, nice, nice. Rachna. Rachna, very nice. So those of you, Rahul also, yeah, Rahul, I've taken the name. So those of you who have got the answer as A, that's correct. Let's take the discussion further. Please mark it as +4. Yeah, so the next question coming in front of you is this. Read the question. Again, this is corresponding to +4 minus 1. Again, this is corresponding to +4 minus 1. When a bullet of mass 10 gram and speed 100 meter per second penetrates up to a distance of 1 meter in the human body, in rest, the resistance offered by the human body. The resistance offered by the human body. Okay. Find out the resistance offered by the... Adrika also got the same answer. Very nice. So now this question, 30 seconds only. Get started. Give the answer. 30 seconds. Give the answer. Quick. Quick. Simply what you need to find out, you need to find out the resistance offered in the situation. Easy question. I don't think that this is going to take a lot of time. One of the easiest question that you're getting. Okay. Quick. Bullet mass has been given. Speed has been given. It penetrates up to what distance? It penetrates up to what distance? Up to 1 centimeter. 1 centimeter, no? Yeah, 1 centimeter. In the human body. The resistance offered by the human body. What is going to be the resistance offered by the human body? Easy question. Okay, so here we go. Here we go. 5 more seconds. 4, 3, 2, 1. Time up. Let's see the answers. What you have given. What answers you have given. Most of the students are saying as... Give your answers, all of you. I can't see your answers. See, what is given in the situation? Mass of the bullet has been given as 10 gram. That means 1 by 100 kg. 10 by 1000 kg. That means 1 by 100 kg. What is the initial speed? Initial speed is 100 meter per second. That's fine. Okay. Penetrates up to a distance of 1 centimeter. That means 0.01 meter. 0.01 meter. Isn't it? The resistance offered by the human body, definitely the final velocity is going to be 0. Final velocity is going to be 0. Okay. So, v square equals u square plus 2as. Can we write this? Definitely yes, we can. V square is 0. How much is u square? 10 to the power 400 square. Okay. Plus 2 into a into s is 1 by 100. Simple. Okay. So, what is going to be a? A is going to be minus of 10 to the power 4 into 100. 1, 2, 3, 4, 5, 6. What is going to be the force? Resistive force is going to be 10 to the power 6 into mass is divided by 100. That means it's going to be how much? It's going to be simply 10 to the power 4 Newton. That means D is going to be the just a second. We have not calculated this 2. This is going to be 500. Sorry. This is going to be, this 2 we have not calculated. So half of this. That means 5,000. 5,000. How many of you got the answer as C? Add +4 to your scores. Those who have got as C. Darshini is saying 2. That's wrong. Tanishar is saying D. That's wrong. I didn't calculate this 2 divided by 2. That means the answer is going to be 5,000. Okay, 10,000 by 2. That means 5,000 is going to be the answer. Let's take the discussion ahead. The next question coming in front of you is this. The next question coming in front of you is this. Again, +4 minus 1. Okay. Read the question. Which of the diagrams as shown in the figure most closely shows the variation of kinetic energy of the earth as it moves around the sun in elliptical orbit? Kinetic energy of earth when it moves around the sun. Only 30 seconds for this question. Simple logical based question. If you click the logic, you get the answer. If not, no sense. Quick, quick. Fast. Fast. Quickly. All of you. Last 8, 7, 6, 5, 4, 3, 2, 1. See, basically, this is the concept of gravitation. Okay, you will be understanding this concept. But I think that you might be knowing that the sun is located at one of the two foci, and these are the positions at which the velocities are maximum and minimum. Okay, so when the earth is at this location, let's say location number A, the positions of perihelion and aphelion, the velocities are maximum and minimum. Okay. No, Rahul, the total energy is constant. Try to understand the total energy, which is the sum of kinetic energy plus potential energy, that remains constant. But the velocity, the speed is continuously changing. Kinetic energy is continuously changing. Okay. Speed is continuously changing. The kinetic energy is continuously changing at every single point. It reaches a maximum value. It reaches a minimum value. Okay. But it can never be zero. It can never be zero. Okay. That's why this graph is drawn above the axis. It can never be zero. It can be maximum. This is the maximum value. This is the maximum value. This is the minimum value. Why this point is wrong? Why this option is wrong? Because in this option, there are different points at which the kinetic energy is zero. This cannot be possible. Okay. I hope that the point is clear. So the answer is D. Okay. All of you, those who got the correct answer, mark it as +4. Okay. Mark it as +4. Next question coming in front of you is this. Read the question. A uniform chain of length L and mass M is lying on a smooth table. Important concept. Very important concept. Okay. Again, +4 -1. And 1/3 of its length is hanging vertically down over the edge of the table. 1/3 of its length is hanging vertically down over the edge of the table. Okay, that's fine. See, this is the chain, and some part of the chain is lying. Okay. SBS Nike 0 not possible because it is having certain amount of velocity at every point. Earth is not stopping. When the kinetic energy 0 means it's going to stop. Earth doesn't stop in its motion at any time. This is L/3 lying over here. L/3 lying over here. Again, 45 seconds for this question. 3, 2, 1, start. Time starts now. Begin quickly. Very good, very good, very good. All of you do this. Do this, do this, do this. Fast. Quick. Be quick, all of you. Okay. Time up, time up, time up. See, if this is the hanging part, how much mass the hanging part is having? Let's find it from unitary method. L length corresponds to M mass. Unit length corresponds to M upon L mass. Okay. 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 So L/3 length corresponds to M/L into L/3 mass. Simple. That means M/3 mass is lying. So what is the center of mass? What is the point at which you can concentrate whole of the mass? This is the point. That means it's at what distance? It's at L/6 distance. That means this system is equivalent to a system in which you want to place M dash mass. You want to place M dash mass to a height of L by 6. Okay, so how much work needs to be done? M, G, H. How much is H? L by 6. That means M by 3 into G into L by 6. You can also find this expression using integration. You can take a small element and you can integrate it from L by 3 to 0. You're going to get the same answer. That's mgl by 18. So all of you who got the correct answer, congratulations, and add +4 to your score. Okay, let's come to the next question. The next question coming in front of you is this. Read the question. What the question says: momentum of a body is increased by 20%. The percentage increase in its kinetic energy is going to be. So first of all, I'm telling you the concept. What is the concept? What is the concept? The concept for relation between momentum and kinetic energy. Kinetic energy is half mv square. That means under root of, see, this is p square by 2m. So you can say p is root over 2 ke m. Okay. So kinetic energy can be written as p square divided by 2m. That's fine. That's fine. Okay. You need to find out the percentage increase in kinetic energy, percentage increase in momentum has been given to you. Only 30 seconds for this question. Only 30 seconds for this question. All of you be quick. All of you be quick, fast. Very simple question. Very simple question. Okay. You are increasing the momentum by 20%. Last 5, 4, 3, 2, 1. Time up. Let's say you have increased the momentum by 20%. What's going to be the final momentum? Final momentum is going to be 1.2 times of initial momentum, that is P. The final momentum is going to be 1.2 times the initial momentum, that is P. So what is going to be the final kinetic energy? Final kinetic energy is going to be final momentum square pf square divided by 2m. That's fine. That means it's going to be how much? It's going to be 1.2 into 1.2. That means 1.44. Okay, times of p square by 2m. So from here what you can say? You can say that the final kinetic energy is 1.44 times the initial energy. Okay, so can you say that it has increased by 0.44? That means 44%. Okay, so the answer is B. The answer is B. All of you tell your scores. All of you tell me the scores that you're having presently. We are reaching the lap number 5. Lap number 5. Okay, circular center of mass and rotational motion. Circular center of mass and rotational motion. Give me your scores. How many scores are you having? What are your scores presently? All of you, quick, fast. Let me check your scores. What is happening? Ria Soni 44. Very good. Is it the answer or is it the score? I'm asking about your score. How much are you scoring in the session? Okay. Yeah. Anyways, let's get back to the point. We're talking about the circular motion. Okay. So if I give you a comparison between circular, or let's say general discussion between rotational and linear motion. So I'm going to compare the parameters. I'm going to compare the linear and the rotational parameters. Okay, this is a general discussion that you're going to follow in every unit of rotation. Okay, just listen carefully. So what am I saying? I am saying that if you move from point A to a point B, if you move from a point A up till a point B, this is what we call as displacement. This is what we call as displacement. In this situation, what do you say? In this situation, what do you say? If you move from point A to some point B, you say, yeah, just a second, Pushpa Kumari, chill, we'll be doing this, don't worry. If you go from A to B, something like this, this is theta. So this is what we call as the angular displacement. What is this? This is the angular displacement. It is represented with theta. This is x, okay? You represent the speed as distance upon time, or the velocity as displacement upon time. Yes, Chetan will be doing it over here. Okay. After this, if you talk about the angular speed or angular velocity, that's going to be rate of change of angular displacement. Acceleration is dv by dt. Yes. Angular acceleration is this. Okay. Over here, we talk about the momentum, that's m times of v. Over here, we are going to talk about the angular momentum, that's going to be I times of omega. Here we talk about force, here we talk about torque. Here we talk about mass, here we talk about moment of inertia. Okay, just a general discussion I'm giving. Okay, yeah, listen. Someone is saying power, so we are going to add the questions of power in this discussion, but still for the moment while, if someone is not aware about power, what is power? Power is simply rate of doing work. Power is simply the rate at which the work is done. You can say work done is force into displacement divided by the time. So this is displacement upon time, that's force into velocity, the dot product of F into velocity. Okay. So what is going to be the unit of power? The unit of power is going to be joule per second. This is going to be watt. Okay. Remember this, we'll be doing questions on it. Don't panic. Okay. Let's focus on the discussion that I'm telling. Yeah. So I was giving you a comparison between the parameters. I was giving you a comparison between the different parameters. Now what we are saying, if you talk about the displacement in terms of angular parameter, that means the angular displacement, what it's going to be, it's going to be the angle traced by the position vector. It's going to be the angle traced by a position vector of a particle with respect to some fixed point. With respect to some fixed point, you're going from A to B with respect to a fixed point. So how much angle is traced? This is called angular displacement. Okay. After this, if you talk about the frequency is simply the number of revolutions covered by a body, per second. Okay, RPM. Okay, see, one rotation, what we are talking about, let's say 10 revolutions are done in 1 minute. 1 minute equal to 10 revolution, that means 60 seconds equal to 10 revolution. Okay, 10 revolution per minute. So in 1 second, 10 by 60, 1 by 6 revolution per second. Getting the point? The number of revolutions described by a particle per second is the frequency. The unit of frequency is going to be per second. Okay. 1 RPS, 1 rotation per second equal to 60 per minute. You're talking about revolutions per minute. 1 minute can be written as 60 second. NLM का last question समझ में नहीं आया बेटा, करते हैं. We'll be doing that. Don't worry. Focus on what we are discussing. Time period is simply the time taken by a particle to cover one complete revolution. Angular velocity is going to be the change in angular displacement upon time. That means the angle traced divided by the time. Okay, that's fine. After this, the relation between angular and linear velocity. You know that if this is a body, try to understand the body traveling from A up till a point B, the angle traced is theta. Let's say this is x. So you can say theta equals arc upon radius. You can say theta equals arc upon radius. Can you? Definitely yes. So can you say x equals to r times of theta? Definitely yes. Differentiate the expression with respect to time. dx by dt is r times of d theta by dt. Yes or no? What is dx by dt? That's v. What is d theta by dt? That's omega. So what expression are you getting? You are getting this expression v equal to r omega. Yes or no? Simple. In vector form, I clearly said that omega, theta, alpha are what kind of vectors? They are axial vectors. Okay. So remember that v is the cross product of omega and r. V is the cross product of omega and r. Okay, remember this discussion. Similar like the average linear velocity, we define the average angular velocity. That's the total change in angular displacement upon the time. Okay. Yes, Chetan will be doing this. Don't panic. I said now that we'll be doing this. Instantaneous angular velocity, d theta by dt. Okay. Let's take the discussion ahead. If you talk about the uniform and non-uniform circular motion, try to understand. Try to understand. Which is the necessary force required for circular motion? All of you, quickly in the chat. Which is the force required? Which is the necessary force for circular motion? If a body is describing circular motion, which is the mandatory force? Tell me. The centripetal force. Which is the mandatory force? Tell me. The centripetal force. That means if a body is describing a circular motion, it should have centripetal force. Yes. What is that force? That centripetal force is m v square divided by r. Now, if the body moves with constant speed, if the body moves with a constant speed, okay, if v is a constant, there is only one force acting in the situation. There is only one type of acceleration in this situation. That's the centripetal acceleration. That's the centripetal acceleration. Okay. In this situation, in uniform circular motion, the only acceleration present is the centripetal acceleration. Okay. If you talk about the non-uniform circular motion, then in this situation, apart from the centripetal acceleration, there is going to be presence of another type of acceleration, which is the tangential acceleration. Okay. The centripetal acceleration is always directed towards the center. Okay. The centripetal acceleration is always directed towards the center. And there is another acceleration in this situation, that's the tangential acceleration. And so the net acceleration is going to be the resultant of tangential acceleration and the centripetal acceleration. What is tangential acceleration? Let's say a person is moving with a constant speed. Okay. In 1 second, he is covering one revolution. In 1 second, the person is covering one revolution continuously. This is uniform circular motion. Equal revolutions, equal time. Okay. If the person covered one revolution in 1 second, then in half second he covered another revolution. Then in 0.1 second, that means he is speeding up. The person is speeding up. The example of a fan, when you turn on a fan, this speed keeps on increasing initially, isn't it? So this is uniform circular motion. This is non-uniform circular motion. The resultant acceleration in this situation is going to be somewhat over here. The resultant acceleration is going to be somewhat over here. Okay. What is AT? What is the tangential acceleration? That's dv by dt. Rate of change of the speed along the path. Okay. So this is the difference between the uniform and non-uniform circular motion. Okay. Uniform circular motion, non-uniform circular motion. If you talk about the equations of circular motion, the equations of circular motion, you can compare the equations with the equations of rectilinear motion, something like this. V equals u plus t, omega equals omega naught plus alpha t. V square equals u square plus 2as, omega square equals omega naught square plus 2 alpha theta. Okay. S equals to ut plus half at square, theta equals to omega naught t plus half alpha t square. Okay. These are the equations. Okay. Let's take the discussion ahead. Now see, let's try a question first. Let's try a question first. Then we'll be taking the discussion further. Just a second. Yeah. Lot of you were asking regarding the banking of a road. A lot of you were asking regarding the banking of a road. So that concept came. What is the situation and what is the requirement of banking? Try to understand. If you want to take a turn on the road, if you want to take a turn along the road, which force is going to provide you the centripetal force? If you're driving a car and you're taking a turn, which force is providing you the required centripetal force? Let's say this is the road, and let's say this is you driving the vehicle. This is you driving the vehicle. So which force is providing the required centripetal force in this situation? Yes, which force is providing centripetal force? That's what I'm asking. Which force is providing the required centripetal? Yes, very good, Samarth Patil. Frictional force is providing. Very good, Sujita. Very nice. Okay, Rahul. No, not normal force. Not normal force. Frictional force is providing. Frictional force is providing the required centripetal force. Why? Why? Because if you talk about the circular motion, let's say you have a thread, you have a string, and you are rotating a mass m, something like this, along a circle. If at any instant we cut the string, then what happens? Then the mass gets off tangentially. Then the object gets away tangentially, isn't it? Who is providing the centripetal force in this situation? Tension. If you take the example of Earth moving around the sun, which force is providing the required centripetal force? The gravitational force is providing the required centripetal force. If you take the example of electron moving around a nucleus, who is providing the required centripetal force? The electrostatic force of attraction is providing the required centripetal force. If you take the example of a bowl, okay, bowl in which you eat na, bowl, and you take a marble inside it, and you just rotate this bowl, so that marble is also rotating along with it. Who is providing the required centripetal force? Some component of normal reaction is providing the required centripetal force. Now what I'm asking, that if you cut the string, the object gets away tangentially. Yes, the object gets away tangentially. If this is the road, and let's say a car is traveling something like this, so in this situation, if you spill some oil on the road, if you spill some track on the road, where the car is going to get? It's going to get away from the track. Okay, we know this thing. Yes. The only force over here is the frictional force. So normally on the plain roads, friction is the only force which provides the required centripetal force. But what if friction is not sufficient? So what do we do? In that situation? We tilt the roads. We design the roads in such a way that they are banked, they are tilted. This is what we call as the banking of roads. Okay. So in the first situation, if we are dependent only on the friction, for the turning of the vehicle, okay, in the first situation, we are dependent only on the friction. That means friction is going to provide the required centripetal force, and you're going to say that friction is going to provide mv square by r. That's fine. What is the maximum value? Of friction possible? The maximum friction possible is what? That's mu times of n. That's mu times of mg. So the friction should be, see, the friction has this much maximum value. Okay. So the required force should be either should be at most equal to this, isn't it? So you can write this is equal to m v square by r. This gets cancelled out, m gets cancelled out. From here, you get the expression for velocity as under root of mu rg. Okay. This is the expression for velocity in front of you. This is the limiting value. Of friction. This is the limiting value of velocity that you can have on the curve. Okay. What happened to Anjana? Why she got offended? Why is she saying not that great and this? Is something wrong with you, Anjana? Hello, hello, hello. If you're not comfortable, you can please leave and you can just go and sleep. Let others study. Okay. Rest of you, is this point very clear? This is the maximum value of velocity that you can possess. This is the maximum value of velocity that you can possess. Okay. On this turn. On this turn. If let's say you want to increase the velocity, let's say there is a racing track. If you want to go with higher velocity, then what you're going to do? You're going to do banking. Then what you're going to do? You're going to use the concept of banking. So what is basically the concept of banking? The concept of banking is that at high speeds, you are only dependent upon the friction. At higher speed, you are only dependent upon the friction. That's not a safe case. If you want to take a turn at a very high speed and the dependence for centripetal force is only on the friction, then it's not safe. You need additional help. Okay, you need additional help. Getting? And what's that additional help? That's the banking. That's the banking. So if the body is turning along this curve, try to understand. Let's take the example. Let's say this is a car. Okay, let's say this is a car. This is the car. Okay, and this is the surface. This is the surface. The body was turning initially like this. Now this is the curve. If the body turns like this, if the body moves like this, this is the curve. Okay, this is the curve. Along this the body is moving. If the body is moving like this, in this situation, what is the agent which is providing the centripetal force? Try to understand. Let's resolve it. Okay, let's resolve it. Let's say this is the body. Okay, that's fine. Normal reaction, yes. Mg, yes. So what is the component of normal reaction along this direction? What is the component of normal reaction along the center? What is the component of normal reaction along the center? Tell me. If this angle is theta, this angle is also theta. Yes, definitely yes. And this angle is also theta. So this is n cos of theta and this is n sine of theta. So n sine theta is along the center. You can simply say that n sine theta is providing the required centripetal force. That's fine, isn't it? But the point is that what if friction is also present in the situation? This is the case in which we are dependent only on the banking of the road. So we can say that n sine theta equals mv square by r and n cos theta equals mg. Dividing them, you get the expression. As tan theta equals v square by rg. Okay. Now what if both the forces are present? Friction and the banking both are present in the situation. Then what to do? If friction as well as banking are present, then see, let's understand the situation first, then we'll be seeing the formula. See, if this is the track and this is the vehicle, let's say this is the vehicle. Okay, this is the object. How the object is traveling? The object is traveling something like this. If the velocity is increased above a particular limit, just imagine that you have a bowl and there's a marble and you're rotating. Hello, 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 hello. Can you hear me now, all of you? Am I audible? Am I audible? Am I audible? All of you? Can you hear me now? All of you, tell me quickly. No voice after marble. Okay. Yeah. What I was saying that if you have a marble inside a bowl, imagine that you are rotating the bowl along with the marble. So above a particular limit, the marble is going to come out, something like this, isn't it? If you want to see the experiment, see, rotate it, keep on rotating. The water comes up, the surface of the water level rises, isn't it? If you keep on rotating it, the level of water rises. Similarly, if you take the example of a bowl inside which there is a marble, you rotate it, the marble slowly comes up, isn't it? So if you is there voice? No voice after imagine. Can you hear me, all of you? Let me check. This is showing fine. There is voice now. Sakshi is saying no voice. Audio is clear. Please give me a thumbs up first of all for the audio. Give me a thumbs up for the audio. Is the audio clear? Cool. Fine. Okay. Yeah. Now see what I was saying. Similarly, if you imagine the situation that you might have played the video game. If you raise the speed on a tilted track, the car slowly comes up, isn't it, above a particular value of speed. So now what we are saying, we are discussing the two cases. Of Vmax and Vmin. That means when the speed of the car along the banked surface is at the maximum value, the car wants to tilt up, the car wants to go up, and if the motion of the car is towards the upward direction, the friction is going to act in the downward direction. Yes or no? Definitely yes. If the speed is at the minimum value, then the car has a tendency to come down. If the car has a tendency to come down, the direction of friction is going to be over here. Is this point very clear? Are you getting this basic thought? Now you can come to the concept. What is the concept? The concept is that if you talk about the condition of minimum velocity, then in the minimum velocity, the body has the tendency to come down and the friction acts in the upward direction. Yes. What are the different forces acting? This is normal reaction. This is mg. This is the component of normal reaction. You have to simply remember the final result. What is the final result? V minimum. That means the minimum velocity, okay, which is permissible is this much. Root over rg tan theta minus mu upon 1 plus mu tan theta. The maximum velocity, that means the maximum value till which it remains in the circle, and above this limit the body is going to go up. Below this limit the body is going to come down. So this can be a range. Let's say the minimum is 20 meter per second, maximum is 30 meter per second. So if you are traveling with 20 to 30 meter per second in this range, you're going to be in that circle, or else you're going to either come up or go down of the circle. Okay. So write down these formulas, very important. This is important. Okay. Write it down quickly. Note it down quickly, all of you. Done? So here we go. After this, if you talk about a conical pendulum, basically what is a conical pendulum? Take a ball, attach it with a string and simply rotate it like this. Okay. Let's say this is a string. Just imagine that this is a string. I'm rotating it like this. This is the conical pendulum. Okay. Take a bob, attach it with the string and rotate it like this, something like this. Okay. Okay. So what is the radius of the circle in which the object is rotating? That's r. That's fine. Okay. So which force is responsible for the circular motion? If this is the tension T, if this angle is theta, what can you say? You can simply say that if this is T, this angle is theta, that means T sine of theta is providing the required centripetal force. Okay. T sine theta is m v square divided by r. And what is the relation between L and R? This is the length of the string and this is the radius of the circle R. So you can say, you can say that if this angle is theta, this is R, this is L, then sine theta is equals to R by L. Sine theta is equals to R by L, isn't it? R by L. That means R can be written as L sine of theta. So the expression in front of you looks something like this. Okay. Okay. Opposite upon hypotenuse. Okay. So R upon L. R is L sine theta. Simple. Remember like this. Okay. Yeah. So let's take the discussion ahead. If you talk about the death well or the rotor, okay, so let's say this is the system and this is a block kept over here, something like this. If this block is rotating, let's say, imagine that this is attached to a wall. Okay. And this whole system is rotating something like this. So this object is under continuous circular motion. It is experiencing a radial outward force, isn't it? The pseudo force, centrifugal force, yes or no? So the question arises that if this object is balanced, okay, how is it balanced? What are the forces acting? This is the normal reaction. This is the centrifugal force, the pseudo of centripetal, isn't it? So first point that you're going to say over here, see, this system is rotating like this. I hope that the system is very clear. Okay. If you want some other example, imagine that this system is rotating. Imagine that this system is rotating, and inside this system there is a block. So if this system is rotating, that block is also rotating, yes or no? So can we say that there is a continuous force that's acting on the block? One force, the normal reaction towards the center, and the other, you can say, the centrifugal. That means normal is the only force which can provide the required force for the motion, N equal to m v square divided by r. Expression number one. Okay. Expression number two. Which force is balancing the body along the vertical direction? Mg is acting downward. So who is stopping the body from coming down? Which is that force? The friction. Simple. So you can say that Mg is equal to the force of friction. Yes. And what is the maximum value of friction? F max. Mu mg. How many of you are saying mu mg? How many of you are saying mu mg is the maximum value of friction? How many of you are saying that the maximum friction is mu times of mg? How many of you are saying this? I want to know. How many of you are saying friction maximum is mu times of mg? Quick. I'm asking something. How many of you are saying that friction maximum is mu times of mg? How many of you agree with this expression that I've written over here? I'm not getting your responses. How many of you agree? Just tell me yes or no. If you agree, then tell me yes. If you don't agree, then tell me no. How many of you are agreeing? This is wrong. This is wrong. This is wrong. This is wrong. Friction is not mu mg. Friction is not mu mg. Very, very clever students. I said that it's wrong. Students are saying, no, we didn't say this answer. Okay. Oh my God. Friction is not mu mg. Friction is mu n. Friction is mu n. Dear students, friction is mu n. So you can say that mg is equals to F max, which is mu times of normal reaction, and normal reaction is mv square by r. Okay, so you can equate the two. You can, m gets cancelled out. This is r g by mu. V equals to root over r g by mu. Okay, equating this to, m gets cancelled. You can compare the velocity from here. Okay, friction is not dependent upon mass. Very clearly I am saying friction is not dependent on mass. Karthik is saying, oh ho ho, Angrezi. But this is the English channel. This is the English channel, so we have to speak in Angrezi only. Okay. Okay. Anyways, let's come back to the point. Don't distract me from the discussion. After this, the vertical circular motion, another very important discussion. Quickly, I'm telling you that what we have to study in vertical circular motion. See, let me find some example. Let me find some string or something. Okay, I'm not getting a string, or else I would have shown you the vertical circular motion. Let's say this is the string, this is the object. Okay, displace it, it goes something like this, comes back. Okay, displace it with even greater velocity, it goes to a greater displacement, comes back. Displace it further, it goes and completes a circle. So we need to describe the conditions. Okay, we need to discuss the conditions. What are the different conditions that are going to take place? What are the different conditions that are going to take place? Okay, see, if this is an object of mass m, this is the radius r, you provide certain amount of velocity to the object u. Okay, if the object reaches this point, let's say this point is a and this point is b. If the object reaches this point, apply the energy conservation. Can you say, apply the energy conservation? Can you say that the initial energy at a, which is the kinetic energy, initial energy, which is the kinetic energy, gets converted into the potential energy? So simply half m u square equals to mgr, isn't it? That means if you give a velocity lesser than or equal to root 2gr, so what the object is going to do? The object is going to reach till the point B or lesser than the point B. That means the object is going to oscillate. So this is the condition of oscillation of the object. This is the condition of oscillation of the object. The object is going to be in this range if the velocity is lesser than or equal to root 2gr. If the velocity is lesser than or equal to root 2gr. Okay, that's fine. That's fine. I hope that this condition is fine. Also, how do we write tension at different points? See, if this is the velocity u, what is the tension at this bottommost point? Quickly, what is the tension at the bottommost point? We can say that the tension is over here T, the downward force is mg, isn't it? So you're going to write that net force, which is T minus mg, equals to mu square by r, or let's say L. Okay, so this is the expression for tension at point A. This is the expression for tension at the point number A. Okay. So the first condition you have seen, that if you substitute, if you displace the object, with a velocity from 0, oh, what is happening? From 0 to root 2gr, what is the object going to do? It is going to oscillate. It is going to simply oscillate. That's fine. After this, the next condition coming in front of you, what if the velocity is greater than root 2gr? What if the velocity is greater than root 2 gr, and how much the velocity should be such that it reaches the topmost point, Now see, I am providing a velocity u at the bottommost point. Okay, let's say this is the velocity v at the topmost point. Okay, fine, that's fine. T, this is t. Okay, that's fine. So what is the expression for tension at the topmost point and bottommost point? Can you say, first of all, by energy conservation, that half m u square gets converted into, at the highest point, half m v square plus m into g into 2r. Yes or no? Definitely yes. Definitely yes. What is the expression for tension at the highest point? That's going to be T plus mg equals mv square by r. T plus mg equals to mv square by r. Yes or no? Definitely yes. So the minimum velocity that you can provide such that the object completes the loop, the minimum velocity that you can provide at the bottom such that the object completes the loop is going to be how much? The condition for minimum velocity, when u is minimum, then at the highest point the tension is going to be 0. So substitute t equal to 0. So for minimum velocity, the tension at the point number B, should be equal to 0. The tension at the point number B should be equal to 0. That's fine. So you can simply say that mg is equal to mv square by r, isn't it? That's fine. That's cool. So substitute this value in the above equation. Substitute this value over here. So from here you get what? From here you get that the velocity, minimum velocity, should be root over 5 gr. If this much velocity you have at the bottom, then it's going to complete the loop. What if the velocity is greater than root 5 gr? It's going to complete, and anyways, it's not going to say no, I don't want to complete the loop. It's not going to say like that. If the velocity is lesser than root 5 gr, then there is a problem. The body is going to fall at any point if the velocity is lesser than this much. Okay. So if you provide a velocity greater than root 2 gr and lesser than root 5 gr, then it's going to be in this region and it's going to fall. If the velocity is root 5 gr or greater, it's going to complete the loop. Okay. I hope that this point is absolutely clear. Okay. Condition of tension and velocities, I am writing it over here. T, the expression for tension over here. T A, call it as A, B, C, D. Okay, TA minus mg equal to mv square by r. Let's call it TC. TC plus mg equal to mv square by r. This is TB, and this is only equal to mv square by r because mg is down. TB equal to mv square by r, same with TD. Okay, important discussion in front of you. Let's take the discussion ahead. Okay, yeah, the most important part, that in case of a string, velocity can never be 0 at the highest point, or else the circular motion would cease. But if you talk about a rod, at the highest point, velocity will be 0, tension can never be 0, it's a rod. Okay, so in that situation, just remember that the velocity for completing the loop is root 4 gr. For which condition? For a light rod. Okay, for a light rod, tension is not 0, velocity can be 0. Simple. Okay, let's take the discussion ahead. Beginning with the discussion of center of mass. Okay, we are beginning with the discussion of center of mass. It's a hypothetical concept. We consider whole of the mass to be concentrated at one point. Let's say this is a rod. This is definitely consisting of infinite masses, n number of masses within it, isn't it? These are the n number of masses which are present inside the rod. Yes. So if you have to assign one single point to this rod, that where is the actual mass, then what are you going to say? You're going to say that it is located at some point. If it's a geometrical point, it's going to be the exact center of gravity. Okay, or else it can be somewhere else. Like let's say that this is the situation, this is the random mass, this is the random figure, so it can be anywhere. You have to calculate it. That means center of mass is a point at which you are going to assume whole of the mass to be concentrated. It can either be inside the situation, inside the figure, or outside it. It can be geometrical center for symmetric masses. Okay, so here we go. What if we talk about the center of mass of two bodies? What if we talk about the center of mass of two bodies? Let's say this is body number 1. Let's say this is body number 1 and this is body number 2. Okay, tell me one thing, that if this is M and this is M, where is the center going to be? Or let's say this is a rod and there are two masses. I want to balance this rod. Where is going to get balanced? If both the masses are equal, definitely at the center. If both the masses are equal, definitely at the center. Definitely, yes or no? So what's the concept behind it? The concept is that this mass wants to turn the situation like this in the anti-clockwise, and this mass wants to turn the object in the clockwise direction. If the body is balanced, you can say that the moment of masses, that means m times of r, equals the moment of the other mass, that's m times of r. But if let's say if the masses are unequal, let's say this is m1 and let's say this is m2. If m1 is greater than m2, where should I balance it? Near m1 or away from m1? If m1 is greater than m2, where should we balance? Where should we keep that balancing point? Near the bigger mass or near the smaller mass? Definitely near the bigger mass. Because m1 times of r1 is going to be equal to m2 times of r2. Simple. Can we say this? Definitely yes. That means one general rule we can say that m into r is a constant. Okay, so all of you who are attached with Physics Wallah, you might be knowing mr sir. So just remember the direct expression that mr sir is constant. Okay, mr sir always constant. Remember it like this, that the mass moment is always constant. Okay, for this situation, that means if you increase m, the r is going to decrease. Okay, so here we go. Let's take the discussion ahead. Now we can generalize the discussion to any shape, any size. Okay, if you have masses placed randomly, let's say this is m1, this is r1, this is the x1, y1, z1, this is the x2, y2, z2. So what are we saying? We are saying that the center of mass, the position vector for center of mass is going to be what? The position vector for center of mass is m1 r1 plus m2 r2, m1 r1 plus m2 r2 divided by m1 plus m2. That's fine. So you can generalize this for x, y and z direction also. You can generalize this for x, y and z directions also. What can you say? You can say that the x coordinate of center of mass is m1 x1 plus m2 x2 plus dot mn xn divided by the total mass m. Similarly, the y coordinate of center of mass is m1 y1 plus m2 y2 plus dot whole divided by the total mass. Similarly, the expression for z. Okay, similarly the expression for z you can write. So let's take the discussion ahead, and here we go. What if the system is not a point mass? What if it's not a point mass system? What if it's a continuous system? Okay, what if the system is continuous? For example, if you what happened? Yeah, what if the system is a continuous system? For example, you have a rod, something like this. Okay, you need to find out the expression for this rod. or you have a sphere, or you have a disk, or you have a cylinder, any situation that you have, what can you do? You can simply say that the center of mass is going to be integral of x dm divided by integral of dm. Now, what is integral of dm? What is integral of dm? This is the sum of all the masses present in the situation. This is the sum of all the elemental masses present over here. This is the sum of all the individual dm masses present in the situation. That means it's going to be what? It's going to be what? It's going to be what? It's going to be total mass m. It's going to be total mass m. So you can say integral of x dm divided by m. Okay, is this point clear? Applying this expression for the rod, let's apply this expression for the rod, okay, and find out the value. Definitely it should come at the center. Definitely it should come out to be at the center. Okay, I am assuming an element of mass dm, thickness dx at some length x. So x com is going to be integral of x dm divided by the total mass m. That's fine. So what are you going to write? You're going to write integral of x. What is dm? Elemental mass. What is dm? That's elemental mass. M by L dx divided by total mass m. That's fine. This gets cancelled out. What is the limit for the length 0 to L? So it's going to be what? It's going to be 1 by L. X, integral of x is x square by 2. Substitute the limits from 0 to L. So the answer is going to be 1 by 2 L. That means simply L by 2. So we already knew that for a uniform rod, the center of mass lies at the center. Okay, we already know that the center of mass lies at the center. So this is the answer in front of you. I hope that the point is absolutely clear. If you have two masses located one around the other in this fashion, something like this, okay, something like this. The coordinate of center of mass, the coordinate of center of mass of the first body is, let's say, x1 comma y1. Coordinate of center of mass of the second body is x2 comma y2. Okay, you need to find out the center of mass of the whole system. This whole system, this is let's say sphere, or let's say this is the disk. This is the disk and this is the square. Okay, so consider whole mass of the disk to be concentrated at its center of mass. Consider the whole mass of the square to be concentrated at the center of mass of the square. Okay, that means this m1 mass is concentrated at this point. M2 mass is placed at the center of mass of the square, and the expression is going to look something like this. Okay, same expression. Now you can say that mass is nothing but, see, mass is nothing but volume into density. Volume is area A1. I'm writing in terms of A1, A2. Volume is area into thickness, okay, into x1 plus area into thickness into x2 into the density, which is constant, divided by the total mass m1 plus m2. That means A1 into rho t plus A2 into rho into t. So this density and thickness gets cancelled out, and the net expression in front of you looks something like this in terms of area. Okay, this is the expression in terms of area. Same expression you can write A1x1 plus A2x2 upon A1 plus A2. I hope that this point is absolutely clear. A1x1 plus A2x2 upon A1 plus A2 is the formula for center of mass. Okay, let's take the discussion ahead. Okay, so here we go. Yeah. Now what if you take out some mass from one body? Let's say you have a square and you have just a second. Let's say you have a square and you have taken out some mass from that body. All of you focus on the lecture. Stop the text for some time. Let's say this is the disk. This is the disk, and you have removed this much part. So this is the remaining portion. This is the remaining portion. Okay. Bipendra Narwal is saying you're writing wrong formula. Where I have written wrong formula? Which formula is wrong? Tell me quickly. This one, this one, this is fine. Because what we are doing in this situation, we are discussing in terms of area. You have seen this formula in terms of mass till now. Now what I'm saying that mass is equal to volume into density. Volume is area into thickness into density. Not material is same. That means the density is same. Thickness is same. So no need to worry. Chill. Okay, this is correct formula. Absolutely correct. These both formulas. Now let's take the discussion ahead. Can we proceed? Is this point very clear? It's very important. That's why I'm taking so much time on this point. Is this point absolutely fine? Now see, if you remove certain amount of mass from the situation, if you remove certain amount of mass from the figure, what happens? What happens? Tell me one thing. Tell me one thing. That if this is a disk, listen, I am placing a disk above the first disk. Okay. That means in this situation, you have kept one object above the another. You have kept one object above the another. That's fine. In this situation, what's going to happen? Initially, the center of mass was at this yellow dot, was at this orange dot. You have added some mass to this figure. Isn't it? You have kept some more mass on the existing system. So the center of mass is going to shift which side? Right side or the left side? If you place some mass on this disk, the center of mass is going to shift which side? Towards the left or towards the right? Quickly. Definitely it's going to shift towards the left, towards my left, towards this side, towards the heavier mass. Yes. But what if you take away some mass? What if you take away some mass? Okay. What if you take out some mass from the figure? So this is the remaining portion. This is the remaining portion. In this situation, simply coordinate of center of mass is going to be A1 x1 minus the removed area or the removed mass. Okay, this is A1 and this is A2. This is A2. Okay, minus A2 x2 whole divided by A1 minus A2. Just remember this point. This is very important point. Okay, if you remove some mass, the center of mass is going to shift the opposite side. The center of mass is going to shift the opposite side because now it's not a uniform figure. Now it's no more a uniform figure. Is it? Definitely no. Same formula you can also see in the terms of mass. Like this. Okay. Is this point cool? Okay, so here we go. Some general results for center of mass that you need to remember. Some general results for center of mass. Semicircular ring, directly remember 2r by pi from the base. Okay, 2r by pi from the base. Semicircular disk, 4r by 3 pi from the base. If you talk about the hemispherical shell, this is going to be r by 2. If you talk about this solid hemisphere, 3r by 8. Note these formulas in your formula book. Okay, these are very important. And if you remember these formulas, see, anyways, if you don't remember these formulas, you cannot derive them at the time of examination, because in NEET you get hardly 1 or 1.5 minutes for one question. If you remember, then only you can do the question in NEET or JEE. Okay, some more formulas I have written over here. Just go through them and note them down in your formula book. Okay, now we are going to begin the rotational motion, and I'm going to give you the break after rotational motion. Okay, after rotational motion we'll be seeing the thermodynamics, oscillations and waves. Cool. Gravitation we'll be seeing along with the electrostatics in the 12th class lecture, which is on 13th, I guess. Okay, yeah, so I think 20-25 more minutes. After that I'll be giving a break, and after that one more session. So let's get back to the point, what I'm saying. We are beginning with the concept of rotational motion. What is a rigid body? What do you understand by a rigid body? What do you understand by a rigid body? What is actually a rigid body? Rigid body is simply a system that does not changes on application of a force. Rigid body is simply a system. It's a body that doesn't changes its shape and size when you apply a force. Let's say if these are the 2 points on the object, you are applying a force F, you are applying a force F, okay, something like this. So what is happening in the situation? What is happening in the situation? The separation between the 2 points A and B is not changing. The separation between the 2 points A and B is not changing no matter how much large force you are applying. No matter how much large force you are applying. Okay. No sound. Who is saying no sound? Who is this new doctor? 12 बजे भी लोगों को चैन नहीं है, देखो फालतूगिरी कर रहे हैं आके. नो साउंड. पढ़ लो चुपचाप, नहीं पढ़ना तो जाओ सो. बहुत टाइम है क्या तुम लोगों के पास? Oh sorry, I have to speak in English. What are you doing this faltugiri? Don't do this. Just go and sleep if you don't want to study. Okay, Roman Shah is saying wrong. What wrong? No sound. Is there? Just give me a thumbs up if there is sound. Just give me a thumbs up if the sound is clear. Clear ना? So don't do spamming. बच्चों वाली हरकतें क्यों करते हो? हैं? 5वीं 6ठी क्लास के बच्चे हो क्या? Don't do this. Don't do this. Focus over here. Okay. Yeah, so basically what is the difference? What is the difference between translational and rotational motion? What's the difference between translational and rotational motion? This is the translational motion. This is the body showing translational motion. Okay. If you talk about the axis that remains parallel, axis of the body that remains parallel. If you talk about rotational motion, this axis is going to tilt. This axis is going to tilt. Now my question to you is, what is the difference between circular and rotational motion? What's the difference between circular and rotational motion? What is the difference between circular and rotational motion? See, circular motion is a point phenomena. Circular motion is a point phenomena. Rotational motion is a system phenomena. Similarly, the thing that we discussed for linear and translatory motion, linear motion, point phenomena, translatory motion, mass phenomena, system phenomena. So we are discussing about a system. We are discussing about a system. This is the system. Okay. So if the system is moving something like this, this is the axis is not changing. This is translational motion, pure translational motion. And what kind of motion is this? This is the combination of translational and the rotational motion. Okay. What are the different types of rotational motions? The different types of rotational motions that you have seen about a fixed axis. For example, let's say this is a disk. Let's say this is a disk. Okay. Let's say this is a disk and this is the axis. You're making this axis rotate. So what's going to happen? This is the rotation about a fixed axis. Okay. Let's say this is the object that you have thrown. If I throw this object, if I throw this pen, it's going to rotate something like this, something like this, something like this. Adrika will be doing man plank system, don't worry. Okay, this is the system moving something like this. So in this situation, let's say you throw an X, throw X. Okay, I'm not talking about X, I am talking about X. Okay, so don't get confused with X. I'm talking about something else. So let's say you throw this X, so it goes rotating. What is the axis of rotation of this object? It's not about the center of that object. Okay, or let's say you are making an object rotate. Let's say this is a disk. Let's say this is the disk. Okay, and this disk is moving along the path something like this. It is having V as well as omega. That means it is under combined motion. It is under combined motion. Okay, that means it's having linear as well as rotational motion. So what is going to be the instantaneous axis of rotation? Let's try to understand. First of all, if we talk, see, if we talk about the rotational motion, we have seen that in linear motion you talk about displacement, rotational motion it's going to be about angular displacement. In linear motion you talk about velocity, here you're going to talk about angular velocity. In linear motion you talk about acceleration, here you talk about angular acceleration. In linear motion you talk about mass, here you're going to talk about moment of inertia. In linear motion you're going to talk about momentum, here you talk about angular momentum. What is the linear momentum? That's m times of v. What is the angular momentum? That's I times of omega. In linear motion, what do you talk about? In linear motion, you talk about the force. Here you talk about torque. What is force? Force is mass times of acceleration. What is torque? Torque is I times of alpha. Isn't it? Isn't it? What do you say? What do you say for the expression of conservation of momentum in linear motion? You say that the total linear momentum, you say that the net external force is equal to the rate of change of the linear momentum. Yes or no? Definitely yes. So if the momentum is conserved, if the total linear momentum is constant, that means the net external force acting on the object is zero and vice versa. Similarly, if I talk about the conservation of angular momentum, if the net torque acting on a body, is equal to 0, then the total angular momentum of the body should remain conserved. Yes or no? Or vice versa. Can I say that if the total angular momentum of a body is constant, the net torque acting on the body should be equal to 0? Yes or no? Definitely yes. So, sir, continuously you are saying about I. You are saying that in linear motion we talk about mass, in rotational motion we talk about moment of inertia. So basically what moment of inertia is? Moment of inertia is exactly the analogous of mass, the same role that mass used to play in the linear motion. Let's say you have an object. Okay. If you want to displace the object from A to B, okay, if you want to displace the object from A to B, this is a small object, this is a bigger object. Definitely if the object is greater, if the mass of the object is greater, the effort required is greater. Yes or no? Now think about the rotational motion. If you're rotating a disc, if this is the disc that needs to be rotated, if you're spinning a wheel, in fun fair you might have done this now. In fun fair you might have done this, that spinning wheel. You might have gone to your school fun fair and that prize you got the prize, get the prize if you rotate the wheel, isn't it? So if this is a lighter disc, and in the next case you have a very heavy disc, okay, in the next case you have a very thick, very big, very heavy disc, so definitely greater effort is required to rotate the heavier disc. That makes sense. So which parameter is required? Which parameter plays the role of mass over here? Who's analogous to mass? Definitely it's moment of inertia. What it is? It's the moment of inertia. And how do we define the moment of inertia? We define the moment of inertia about an axis as the second moment of the mass. We define the moment of inertia of an object about the axis as the second moment or the double moment of the mass. Okay, that means r square times of m. So this is the expression in front of you for one object. Let's say this is m1. If you have n objects, then what it's going to be? It's going to be m1 r1 square plus m2 r2 square plus m3 rt square, r3 square, and so on. If you have a continuous body, then integral of r square dm. Just note it down. Let's take the discussion ahead. Okay. If we talk about the moment of inertia for a disk, if we talk about the moment of inertia, first let's talk for a rod. Okay. So what's the moment of inertia going to be? That's going to be integral of r square dm. Yes or no? Definitely yes. What is dm going to be? Dm is going to be m by L times of dx. Substitute and find the answer. Substitute and find the answer. Quick, all of you. I'll be giving the break in 15 minutes. I'll be giving the break in 15 minutes. All of you. Fast. Do this and find out the answer. Do this and find out the answer. What are you getting? You will be getting integral of r into dm. dm is m by l into dx. What is basically r? Sorry, this is r square, second moment. Okay, r square. What is r? R is equal to x. What is r? R is equal to x. Take m by l as common outside. Take m by l as common outside. You get integral of x square dx, isn't it? X square dx. So how much are you getting? How much are you getting for this situation? Is this point clear? Is this point clear? What are we doing? What are we doing? We are trying to figure out the moment of inertia. So what is the moment of inertia for a continuous body? Right now you have written that the moment of inertia is nothing but r square dm. What is dm? dm is m by l dx. What is dm? dm is the m by l dx. Okay. So this is m by l into x cube by 3 from 0 to L. Okay. So how much are you getting? How much are you getting? You are getting m L square by 3. How you are getting? Oh yeah, m L square by 3. That's correct. Correct. M L square by 3. Okay. Now we are going to study. The different theorems based on the moment of inertia. But before that, another important term, that's the radius of gyration. Okay. We know that I is equals to mr square, the second moment of mass. Now what I'm saying that what is the separation at which if you place the mass, you're going to get the same moment of inertia. Once again, what is the separation from the axis of rotation at which if you place the mass, you're going to get exactly the same moment of inertia. That's going to be, let's say, k. And this is what we call as the radius of gyration. So the radius of gyration is going to be root over I divided by m. Okay, I divided by m. What is total I? If there are n number of masses, m1 r1 square plus m2 r2 square dot divided by the total mass divided by the total mass. So this is the expression in front of you. Okay, for radius of gyration. Now quickly, the two theorems based on the moment of inertia. First, the perpendicular axis theorem. What the perpendicular axis theorem says, let's say this is a 2D figure, this is a planar figure. Okay, and these are the three mutually perpendicular axes. These are the three mutually perpendicular axes. Okay, that's fine. Z, X and Y. So the moment of inertia about the perpendicular axis, that is the Z axis, equals the sum of the moment of inertia about the rest of the two which are lying in the same plane. Okay. This is the perpendicular axis theorem. If we talk about the parallel axis theorem, let's say this is a body. Try to understand. This is any general body. Okay. You know the moment of inertia about the center of mass. This is the center of mass, and the moment of inertia about the center of mass is ICM. You want to find out the moment of inertia about some other axis which is at some separation D. So what is going to be the moment of inertia? The moment of inertia is going to be the moment of inertia about center of mass plus md square. Okay, the total moment of inertia about the axis is going to be moment of inertia about the center of mass plus m times of separation square. This is called the parallel axis theorem. Okay, point clear? So quickly, let's figure out some more moment of inertias. If this is a ring, basically it's the formation It's the collection of small infinite dm masses placed at equal distance. Placed at equal distance. Okay. Placed at equal distances. So what the total moment of inertia for the system is going to be? That's going to be integral of r square dm. So take r square common outside, it's going to be integral of dm. What is integral of dm? Integral of dm is going to be m. So the moment of inertia is r square times of m, that means mr square, that means it's the same as that of a point mass, isn't it? Is this point very clear? Isn't it amazing? If you take 1 m mass at r distance, or if you take 2 m by 2 masses at r distance, or if you take n number of masses placed in a circle, all of them are going to give the same moment of inertia. Isn't it amazing? Yes. Let's take the discussion ahead. So this is the expression for a disk. How do we find out the moment of inertia for a disk? We take a small ring and we generalize the integration from 0 to r. We integrate it from 0 to r. Okay. So the expression that you're going to get, is 1 by 2 times of m r square. Okay. Clear? Let's take the discussion ahead. The next shape that's coming in front of you is a solid sphere. So if you talk about a solid sphere, the moment of inertia for a solid sphere, remember, it's going to be 2 by 5 times of mr square. It's going to be 2 by 5 times of mr square. No need to get into the derivation. Okay, directly you have to remember this. After this, the moment of inertia for a hollow shell is going to be 2/3 of mr square. 2 by 3 times the mr square. Cool? Let's take the discussion ahead. Now this is a thin rod. Okay. And you are talking about a thin rod, about its center. Can we find out the moment of inertia about the center? Are we aware about the moment of inertia about the axis, about the end point? Yes. That's ml square by 3. Is it ICM? Definitely yes. So can we write that moment of inertia at any other point is equal to moment of inertia about the center of mass plus md square. So can you write the expression? I is ml square by 3. I is ml square by 3 equals to I center of mass. That's m. That's what you need to find out. Let's call it as I. Plus m times of L square by 4. Calculate this quickly. Calculate this fast. What are you going to get? You're going to get I is equals to ml square divided by 12. Okay. I is equals to ml square divided by 12. Clear? Fine. Can we take the discussion ahead? Raj Maheshwari is asking, is it recorded? If it's recorded, then what am I doing here? Anyways, let's take the discussion ahead. Okay. So if you talk about a thin cylinder, so a thin cylinder is equivalent to a ring. A thin cylinder is equivalent to a ring. Okay. If you take a ring and if you stretch the ring, it's going to look like a cylinder. Okay. And the mass distribution is going to remain exactly the same. What is going to remain the same? The mass distribution is going to remain the same. And if the mass distribution is same, then the moment of inertia does not change. So if you talk about a thin hollow cylinder, the moment of inertia is going to be mr square only. I hope that this point is clear. Okay. So now let's take the discussion ahead. If you talk about a solid cylinder is going to be equivalent to what? If a hollow cylinder is equivalent to a ring, a solid cylinder is going to be equivalent to what? A solid cylinder is going to be equivalent to a disc. Take a disc, stretch it. Stretch it. Okay, the mass distribution is same. The mass distribution is still same in this situation also. MD, what is MD? MD is same. Okay, is this point very clear? This is mr square by 2. Disk, if you talk about a disk or a solid cylinder, it's going to be absolutely same. Now if you talk about a rectangle, just imagine, okay, that this is a rod. Just imagine that this is a rod. Okay, can I say that a rectangle is a thick rod? Can I give this a statement that a rectangle is nothing but a thick rod? If you had a rod, the rod is eating a lot of calories, the rod got thick, so it turned out to be a rectangle. Okay, still the expression of rod is going to be applicable for this rectangle. If this length is b, this length is b, okay, you're going to say that the moment of inertia is going to be m b square by 12 for this situation, provided that this thickness is small. But what if this thickness is not small, it is considerable? What if this thickness is considerable? So we are going to write that the moment of inertia is going to be m times of a square plus b square divided by 6. M times of a square plus b square divided by 6. Tushar is having some doubt. Quickly tell me what's your doubt, Mr. Tushar. What doubt are you having? Oh, sorry, not 6. This is going to be 12. Just a second. This should be 12. My bad. This is 12. Okay, about the center. Yes, Tushar, what doubt are you having? Please ask quickly. Let's take the discussion ahead. Okay, so here we go. We have seen the axis theorem. Now we are beginning with the conservation of angular momentum. After this, we'll be doing questions. Okay, conservation of angular momentum. After this, what we'll be seeing? After the conservation of angular momentum, we will be seeing the rolling motion, and then we'll be doing the combined numericals. Okay, and then we'll be doing the combined numericals. But before that, what you can do? Okay, let's first of all complete the concept of whatever I said. Okay, let's complete the concept, then we'll be starting with the numericals. Okay, no need to worry. Yeah, so what is the analogous of force? What is the analogous of force in rotational motion? It's the torque, isn't it? It's the torque. Yeah. So what are we talking about? We are talking about the turning effect of force. Let's say this is an object. And this object is hinged at one point. That means this object is fixed at one point. Okay, that's fine. So if you apply a force F, definitely there are going to be two components of this force. One is going to be along the rod, and the second is going to be perpendicular to the rod. If this angle is theta, this is F cos of theta, and this is F sine of theta. This is R. So we define torque as the force which is turning the object, the turning component of force. That means the F sine theta. That means F sine of theta multiplied with R. Okay, multiplied with R. So force into perpendicular distance, or the perpendicular component of force into distance. So this is going to be R cross F. This torque is going to be R cross F. Okay, Tushar, we have discussed this concept that you are saying in the, I guess, in what? In circular motion we discussed this, okay? Isn't it? Yes. So this is R cross F. This is the expression for torque. That's fine. Now what are we saying? We are saying that what's the unit of torque? First of all, what's the unit of torque? The unit of torque is going to be same as that of work. That's Newton meter. Okay. But we do not denote it by joule, because joule is present. Joule is specifically the unit of energy. That's why we cannot denote torque with joule. Remember this point. Okay. Basic, simple point. What is rotational equilibrium? First of all, what is equilibrium? Sir, equilibrium is the state of being equal. Okay. That means if this is an object and these are the different forces acting on the body, F1, F2, F3, F4, F5 and so on. So if the sum of all the forces, acting on the body is 0, if the sum of all the forces acting on the body is 0, we say that it's in which equilibrium? Translational equilibrium. If the sum of all the torque acting on the body is 0, if the sum of all the torque acting on the body is 0, we say that the body is in rotational equilibrium. We say that the body is in rotational equilibrium, isn't it? Isn't it? Definitely yes. So what is going to be the rotational equilibrium? What is going to be the rotational equilibrium? Let's say I'm going to give you directly a question from torque. Who wants to sit over here? Who wants to sit over here? Let's say Shreya is sitting over here. Shreya is sitting at one point. And who is this? This is Sontu. Sontu is sitting at the other. Okay. So this is Shreya is 60 kg. Sontu should be of what mass? Sontu should be of what mass so that they are balanced at these separations. They are balanced at these separations. Quickly. Quickly. What should be the mass of the other person? What we are going to do? We are simply going to discuss the rotational equilibrium. That means the two torques produced by the objects should be equal. If this is tau 1, this is tau 2, then definitely tau 1 must be equal to tau 2. What is tau 1? Tau 1 is the what is tau 1? Tau 1 is the force. Tau 1 is the force into separation. What is the other? What is the other? That's mg into 4. So from here calculate the value. Calculate the value. This, let's say g is 10, so this gets cancelled out. This gets cancelled out. This is 2. This is 30. Simple. Okay, direct. Now what we were saying, let's come to the point. Let's come to the point again. We were saying that if the body is under various actions of forces, if the body is under various forces, then in order to be at rotational equilibrium, okay, the body cannot be at rotational equilibrium under the action of a single force. Let's say this is the body. I leave this body. Okay, I leave this body. This is only under the action of mg. It cannot be at rotational equilibrium. If Earth is pulling the object from one side, let's say I fix this point. If Earth is pulling the object and trying to rotate it in this sense, I should apply a torque in the opposite direction. If one object wants to rotate the body in clockwise direction, there should be another object that should rotate it in the anti-clockwise direction. So under the action of one force, a body cannot be at equilibrium, rotational equilibrium. If a body is in rotational equilibrium, under the action of three forces, the line of action of the three forces must be concurrent or parallel. Okay, remember this point. Yeah. Now see, you have said that the linear momentum of a body, that's simply m times of v, and if the net force acting on the body is 0, then the total linear momentum remains constant, isn't it? That means the total initial momentum equals the total final momentum. Similarly, if I talk about the net torque acting on the situation, what if the net torque is 0? The angular momentum remains conserved. So can you say that the total initial angular momentum equals the total final angular momentum? Now, what are the different type of angular momentums that we know? There are two type of angular momentums. Okay. See, if a body is actually rotating, about an axis, try to understand. This is very important. if a body is actually rotating about an axis. Okay, a body is actually rotating about an axis. Then what happens? Then what happens in that situation? It has certain amount of angular momentum. This is called angular momentum. If a body is moving linearly, if a body is moving linearly, it has got certain amount of velocity, definitely yes. It has got some mass, definitely yes. So it possesses some momentum, definitely yes. Definitely yes, isn't it? And what you are doing, you are observing this body. What you're doing, you are observing this body from some distance. Let's say I'm standing over here and I'm observing an object, and I'm observing an object. So this body is moving. If you observe the object from some distance d, then what's going to happen in this situation? Can you say that the distance traveled by the object, can you say that the angular separation of the object is going to change? Is going to change? Is it going to change? How can we say this? Imagine that you're standing over there. Who wants to sit over there? Let's say Ayush is standing over here. This is Ayush. Okay. And this is a traffic signal. This is a traffic signal. And someone was going over here. Okay. Someone was walking over here. So Ayush started Ayush started looking at that person. So if that person is moving, Ayush is also rotating his neck, something like this, isn't it? Ayush is also rotating his neck. That person keeps on moving. He keeps on rotating the neck. But don't you think that the amount of neck that needs to be rotated, is going to change if that person is exactly in front of you and if the person is moving away? Imagine that the person has moved far apart. Still you are observing. The question is, why are you observing? Why are you watching over there? Let that person go. That makes no difference. So if you keep on observing, if you keep on looking, so now very little amount of neck you need to rotate. That means the angular displacement that you need to do is very small, isn't it? The angular displacement that you need to do in this situation is very small. Theta 3 is lesser than theta 2, that is lesser than theta 1. That means the angular parameters are changing even when the body is moving in a linear motion. Yes or no? Yes or no? Yes. That means there is some, the concept is, what I want to say, that there is some angular momentum attached with a body which is exactly in linear motion. And this is what we term as the linear angular momentum. Linear angular momentum, and we define it as r cross p. We define it as r cross p. That means r cross mv. That means mv cross r. See, these terms you are not going to get in the book. There is nothing like linear angular momentum and angular momentum. But why I am saying this? So that you can remember the term, you can remember the case exactly the way I have told you. It is very important. Okay, so these are the two kind of angular momentum that exist in a situation. Okay, so let's take the discussion ahead. If we talk about the impulse momentum theorem for rotational motion, what we have seen, the impulse momentum theorem in case of translational motion, impulse equal to change in momentum, isn't it? Impulse equal to change in momentum. Here you're going to talk about the angular impulse. What is the angular impulse going to be? That's going to be equal to change in the angular momentum. What is impulse? Impulse is force acting for a very short time. What is angular impulse? A torque acting for a very short time. Okay. So I hope that the point is absolutely clear. So here we go. Let's try some numericals. let's try some numericals. Okay, after that we'll be seeing the combined motion. Read the question. Plus 4 minus 1, same marking scheme. Okay, plus 4 minus 1. Read the question. 30 seconds. Abhishek is saying that's why the Parishram batch was cancelled. Yes, that's why it was cancelled. It was not cancelled. I'll have that batch on, might be tomorrow or day after tomorrow. Don't worry. Read this question and let's take 1 minute for this question. Okay, plus 4 minus 1. When slightly different weights are placed on two pans of a beam balance, then the beam comes to rest at an angle with the horizontal. The beam is supported at single point P by a pivot. Then what it wants to say, try to understand, try to figure out the situation, what actually it looks like. Quick. The time starts now. Fast. Quickly, all of you. Try to draw the figure before attempting the question. Do not attempt the question without the figure. If you visualize it, you can very easily do this. Ten more seconds. Okay, time up. See what the question says. Question says that when slightly different weight are placed on two pans of a beam balance, the beam comes to rest. Okay, that's fine. At an angle with the horizontal, the beam is supported at a single point by a pivot. Then what? Then what? The net torque about the point P due to the two weights is non-zero at the equilibrium. It cannot happen. If the net torque is not zero, how is it at equilibrium? It cannot be true. Okay, so this is wrong. After this, the whole system does not continue to rotate about P because it has a large moment of inertia. That this makes no sense. The center of mass of the system lies at P. See, if the system is at equilibrium, if the body is at equilibrium, that means what is it saying? When different weights are placed at the two pans, the beam comes to rest at an angle with the horizontal. Let's say these are the different weights. Just for the moment, let's say that these are the different weights. If this is the balancing point, can I say that this P point is nothing but the center of mass? Can we say that the P point is nothing but the center of mass? Isn't it? So simple, direct. This is going to be the answer. C is the answer. So all of you who gave the answer as C, mark it as +4. Those who marked some other answer, do it as -1. Quickly. Next question coming in front of you is this: a pulley fixed to a ceiling, +4 -1. Okay, carries a string with block of mass M and 3M attached with it. The masses of the string and pulley, are negligible when the system is released. The acceleration of center of mass. You need to find out the acceleration of the center of mass. Okay, so again, 45 seconds for this question. Let's begin in 3, 2, 1, and the time starts now. Begin, all of you. Fast. Quick. Quickly. All of you. Draw the figure. There are two masses, m and 3m. What is going to be the acceleration of the center of mass? Quickly, quickly, quickly. Draw the pulley now. Draw the pulley fast. What the situation looks like. See, I am pausing the timer. I am drawing the situation. I am giving you the hint. Okay, I think some of you are facing difficulty. This is the situation. This is the situation. And this is the pulley. These are the two masses. These are the two masses. What are the masses? M and 3m. Okay, so the acceleration of 3m is going to be down. Acceleration of m is going to be up. Okay, let's call it as a only. It's going to be same. A upward, a downward. So what's going to be the acceleration? Acceleration for the individual masses is going to be delta m, that means 2m divided by sum of masses, that means 4m times of g. This is g by 2. This is g by 2. Okay, so the acceleration of individual masses is g by 2. You need to find out the acceleration of center of mass. You have written the expression for the center of mass something like this. You have said that the position vector is m1 r1 plus m2 r2 divided by m1 plus m2. If we differentiate this, we get the velocity of center of mass m1 v1 plus m2 v2 divided by m1 plus m2. And similarly, if you differentiate it, you get the acceleration as m1 a1 plus m2 a2 divided by the total mass, that's m. So just use this formula, substitute the value of the individual accelerations that you have just found and find the answer. Do this fast. Quick, 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 quick. Do this. See, a big hint I have given you. Now simply what you need to do, you need to find out this. Apply the expression over here and get the answer. This is what you need to do. So once again, I'm starting the timer, but now this time only 30 seconds because 90% of the question I have solved. Begin now, all of you. Quick. Fast. Quick. What happened? Yeah, over here. Quickly, 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 quickly. See what it's going to be. It's done. It's already done. Okay, I don't know what you're calculating. G by 2, if you substitute the data over here, m1 a1 m2 a2 divided by m1 plus m2, just substitute and calculate it. The center of mass is also going to move with the same velocity. That's going to be with the same acceleration. That's going to be how much? That's going to be how much? That's going to be g by 2. So let's take the discussion ahead. And here we go. The next question coming in front of you is this. The next question coming in front of you is this. Again, plus 4, minus 1. Keep on marking the scores. Let me know your scores. Now the students are giving the answer. I already gave the answer. Quickly. Another question, what it says. The center of mass of a system, of two particles of masses m1 and m2 at a distance d1 from m1 and at a distance d2 from m2. Very direct question. M into r is constant, yes or no? Yes or no? So what's going to be the answer? 30 seconds. 3, 2, 1. And here we go. Quick. Fast. Quickly. What's going to be the answer? 3 more seconds. Time up. Time up. Now let us check that how many of you are sleeping and how many of you are actually awake. Lot of you have gave correct answer. Good. Good, good, good. Students are not giving the answer. They are appreciating me for my hard work. I want your answers. You are not getting this. Students are saying, sir, you are doing good job. Keep it up. I know that, but I want your answers. You are not giving the answer. That's what the problem is. Give the answer. All of you. Be participative. Okay. This is not for my revision. M1 R1. See, again, we know that M into R is constant. MR sir is constant. Okay. MR sir is constant. Just remember the rule. MRs are constant. That means M1 R1 equals to M2 R2. M1 D1 equals to M2 D2. We remember this? Definitely yes. So let's take the discussion ahead. Mark plus 4 minus 1. Mark it as plus 4 minus. Now the next question coming in front of you is this. Read the question what it says. Read the question what it says. Two discs of moment of inertia I1 and I2 about their respective axis of rotation with angular frequencies omega 1 and omega 2. Okay, respectively, are brought in contact face to face with their axis of rotation coincident. That means this is disk number 1 rotating with omega 1. This is disk number 1 rotating with omega 1. Disk number 2 rotating with omega 2. That's cool. Okay, you bring them in contact. So what's going to be the angular frequency of the composite disk? Simple. Conservation of angular momentum. Total initial angular momentum of the system equals the total final angular momentum of the system. Do this and get the answer. Again, 45 seconds. 3, 2, 1. The time starts now. All of you get started. The time starts now. Fast. Quick. All of you. Give the answer. Fast, all of you. Velocity increase and acceleration 0. Is it possible? What are you saying? I didn't got your question. Please repeat. Yeah, anyways, I gave 45 seconds for this question. So the initial angular momentum I1 omega 1 plus I2 omega 2 equals the final angular momentum. Total moment of inertia I1 plus I2 times of the common angular velocity, that's omega. So omega is going to be I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Is this point absolutely clear? That means the answer is going to be what? The answer is going to be no. This is going to be the answer. A is going to be the answer. Okay. How many of you got the correct answer? Mark it as plus 4. Those who got the wrong answer, mark it as minus 1. So let's take the discussion ahead. The next question coming in front of you is this. This belongs to gravitation, not right now. This question, not right now. Let's come to the next question. Read the question. A ladder is leaned against a smooth wall, and it is allowed to slip on a frictionless floor. Okay, this rod slips on a frictionless floor. That's cool. Which figure represents the trace of its center of mass? Got the question? What this question says. There's a rod which is kept something like this. Okay, this is the floor and this is the wall. The rod is kept like this. It falls like this. What happens with the center of mass? What is the trace of center of mass? Rakesh, Samantha got mad. 191 are watching. So what to do? Should I dance? Mad people. Sorry. Focus over here. Give the answer. 30 seconds. 3, 2, 1. And here we go. Give the answer. Plus 4 minus 1 for you. Quickly. Fast. They are asking what represents the trace of the center of mass. What represents the trace of the center of mass? Vignesh, we'll check. We'll check. Don't worry. We'll just check that one. First, give the answer to this question. A, B, C, D. Most of you are giving the correct answer. That's cool. That's nice. That's very nice. Now see, the point is that it's a frictionless floor. There is no friction. Wall is frictionless. The wall is frictionless as well as the wall is frictionless as well as the floor is frictionless. So we know that torque is what? Torque is nothing but R cross F. Yes, torque is nothing but R cross F. Okay. And the force that's acting downward, that's mg. Exactly. So the trace of the center of mass is going to be exactly downwards. Okay. Rakesh Samantha is saying you are mad. Might be. I might be mad, but you are for sure mad because you are wasting your time. I'm not wasting my time. Okay. I don't know what you're doing over here. Anyways, rest of you, what I was saying that this is the force acting downward. That's cool. So in short, the center of mass is going to follow the same path C, because we know that torque is nothing but R cross F, and in this situation the force is mg. There is no force of friction along the wall as well as along the floor. Okay. Next question, again +4 -1, the condition of toppling. This is important. +4 -1. Try this question. Fast, all of you. What this question says that a cubical block of side L rests on a rough horizontal surface with coefficient of friction mu. The horizontal face F is applied on the block. For this should be force. The horizontal force F is applied on one face of the block. Okay. Coefficient of friction is sufficiently high so that the block does not slides before toppling. Minimum force required to topple. Okay. Try this question. I'm giving you 1 minute for this question. Try this question. All of you. 3, 2, 1, and the time starts now. Begin. 1 minute for this question, all of you. Just figure out what are the different forces acting in the situation, what are the different torques acting in the situation. This is F, this is going to be mg, isn't it? So the force F wants to rotate it in the clockwise direction, so the torque of mg should balance the tau 1. Just balance the torques, all of you. Quickly. Fast. All of you do this. Be quick. Quick. Okay, time up. So what are we saying? We are saying that the system is balanced. If the system is balanced, the two torques should be equal. Tau 1 equals to tau 2. What are you going to say about tau 1? Tau 1 is force into perpendicular separation. What is torque? Due to mg. That's force into, okay, into perpendicular separation. Now what is going to be the perpendicular separation in this situation? Tau 1 is the force due to F. So that's going to be F times of L. Yes or no? Tau 1 is going to be F times of L. How much is the torque due to the mg? That's L by 2. That means mg times of L by 2. So this gives you what? This gives you. What you need to find out? You need to find F now. F is going to be mg by 2 simply. That means the answer is C. Simple. mg by 2. How many of you got it correct? Give your scores as +4 and -1. So what are your scores? Tell me quickly. What are your scores? Next question. 1/4 section is cut from a uniform circular disc of radius r. This section has a mass m. Okay. This system has a mass m. It is made to rotate about the line perpendicular to the figure. That means you have a pastry. You have a pastry. Okay. Just rotate that pastry or rotate that piece of pizza. Okay, something like this. What are you going to observe? What shape do you see? You're going to observe a complete pizza, isn't it? Is the mass distribution same? Is this same? M mass disk and M mass pie shape. Is the mass distribution same in both of them? If it is same, then definitely what you can say? If it is same, then definitely what you can say? You can say that the moment of inertia is going to remain same if it is same. So 30 seconds for the question. Time starts now. Begin. 30 seconds for the question. Only 30 seconds. Quick. Fast, all of you. Sir, whether on previous question the normal forces act on center of mass. No. See, I'll tell you after this question. If this is the block, if this block is displaced, if it wants to tilt, the normal acts at the point of rotation. It does not produce any torque. Normal is not going to produce any torque. Harsh bro. What is this ID? Harsh bro. Write your full name. What is Harsh bro? Yeah, so anyways, this is the same shape. So disk is half mr square. So the answer is half mr square, because the reason we are going to write that the mass distribution is same. The mass distribution is going to remain same. Okay, let's take the discussion ahead. Here we go. Another question coming in front of you. Read the question, what the question says. Again +4, -1. Again +4, -1. Read the question. Vignesh is asking question for a very long time. Let's check. We didn't calculate the previous one. Okay, so let's substitute it with the proper sign. How much is it going to be? M1 is m times of g by 2. Okay, plus 3m times of g by 2 divided by m1 plus m2. That's going to be 4 times of m. So it's going to be how much? It's going to be g by 4 in the downward direction. That means g by 4 in the downward direction. That means minus g by 4. Yeah, that's correct. Correct, Vignesh. No worries. Okay. Vignesh was asking the correct doubt. Okay. We didn't substitute the negative sign in that direction in that particular question. That's why it's that's why we were getting as g by 2. Oscillation and wave at the end. Okay. Read the question, what it says. A child sits stationary at one end of a long trolley moving uniformly with a speed v on a smooth horizontal floor. If the child gets up and runs about one the trolley in any manner, okay, then speed of the center of mass of the trolley plus the child's system is going to be, speed of the center of mass of the trolley plus mass system is going to be, trolley plus child system is going to be. Should we begin? Shall we begin this? All of you. 3, 2, Vignesh is giving the answer. A lot of you have done this. That's nice. So let's begin this. Let's begin this. 3, 2, 1. Only 20 seconds. Only 20 seconds for this question. Only 20 seconds for this question. All of you. Only 20 seconds. Time up. Time up. Now see what the question says. A child sits at one end of a long trolley. That's fine. This trolley is moving uniformly with some velocity v on a smooth horizontal floor. Okay. This is a smooth horizontal floor and this is a trolley, and this trolley is moving with some velocity v. This is a child. Who wants to sit on the trolley? Who wants to sit on the trolley? Avneet. Let's say Avneet is sitting on the trolley. So Avneet was sitting on the trolley. Now Avneet is standing and walking on the trolley. Okay. Is there any external force acting in the situation? Definitely no. This is an isolated system. This is an isolated system. Is there any external force acting on the isolated system? Definitely no. Is there any external torque? Definitely no. So can the linear momentum change? No. Can the angular momentum change? Definitely no. So we are going to say that it's going to remain same. It's not going to change. That means the answer is A. It was a nice conceptual question. Okay, it was a nice conceptual question. So let's see what scores are you having. What scores are you getting? How many questions you have done correct? The radius of Earth contracts one by n times of its present radius. Okay. Radius of Earth is contracting to 1 by n of its present value. Then the new value of the length of the day. The new value of the length of the day. The radius has contracted to r by n. Then t dash is going to be how much? The new value of length of the day. What do you say? Let's begin. Let's begin in 3, 2, 1, and here we go. 30 seconds. 30 seconds for the question. Quick. Fast. Fast, all of you. Okay. Here we go. So what can we say? We can say that for this situation, for Earth is an isolated system. If it is rotating with some angular velocity omega is 2 pi by t. Earth is having certain radius. Definitely yes. It is having its moment of inertia. Yeah. So what? So what? So can we say that for this system, that for this isolated system, can we say that for this isolated system, the product of I into omega remains constant? Why? Because the angular momentum remains the same. There is no external torque in the situation. Tau external is 0. Net external torque is 0. What is I? I is equals to mr square. What is omega? Omega is 2 pi by t. This remains constant. This remains constant, yes or no? Definitely yes. So can we say that this 2 pi and m, they are already constant. So r square divided by t remains a constant. Yes, this term remains constant. R square divided by t remains constant. Yes. And what you're doing with radius? What you're doing with radius? The radius is divided by n times. Okay, the radius is divided by n times. So what can you say? You can say, what can you say? You can say that r1 square divided by t1 is r2 square divided by t2. Can you say this? Definitely yes, you can. So you can say that, t2 is going to be, r2 divided by r1 the whole square times of t1. And how much is r2? R2 is 1 by n times of r1. So this is 1 by n square times of t. This is 1 by n square times of t. Okay, this is 1 by n square times of t. Okay, okay. So 1 by n square times of t. That means the answer is going to be, B. Is this point clear? I'm repeating the question what I said. See, we said that Earth is an isolated system. Definitely yes, it is. So if it is rotating, there is no net external torque acting in the system, even if the radius shrinks or it contracts or it expands. That makes no difference to the angular momentum, because that's going to remain constant. Okay, what is angular momentum? That's I times of omega. That's going to remain constant. I is what? For the solid sphere, I have written it mr square. This is 2 by 5 times of mr square. This is constant. This is constant. In short, r square by t is going to remain constant. R square by t is going to remain constant. Okay. Yeah. So if this quantity is constant, from here you said that r square by t is constant. We compared time period, and this is the answer coming in front of you. Okay, that's fine. So I'm giving a 10-minute break. After that, we'll be continuing the discussion. Okay, quickly have some water and come back. Okay, we are having a 10-minute break. Okay, we'll be meeting over here. After break, a lot of things we have to do. We have to do rotation. We have to complete the rotational motion some up with some questions. After that, we'll be doing the mechanical properties of solids, liquid, fluids, thermodynamics, oscillations, waves. A lot we have to do. Okay. So see you all. Hello, 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 hello. Welcome back, all of you. Am I audible? Can you hear me, all of you? Yeah, all of you. Welcome back. Where's the pen? Okay, so here we are once again. Welcome back. Audible? Let's get started. Let's get back to the discussion. Here we are. We were doing numericals, so let's do some more numericals and then let's get back to the next concept. So here we go. The angular momentum of particle with a central force is constant due to. Try to understand the question, what the question says. Try to understand the question, what it says. The angular momentum of the particle. Listen, this is the listen, all of you. This is the last slot. Let's say we are going to continue this slot, and after that we'll finish off the session. Okay. The remaining part we'll be doing in the upcoming session, might be tomorrow or day after tomorrow. But till then, all of you be alert and be participative. This is the last slot. I am saying that this is the last slot. Aman Yadav is saying that neend aa rahi hai. So this is the last slot. Might be from 1:30 up till something 1.5 hour more, up till 3 or up till 3:30, whatever the time might be. But we'll be stopping after this slot. So till then, be alert, be energetic, try to give maximum answers. Okay, let's get started. The angular momentum of the particle with a central force is constant due to force constant, linear momentum, zero torque, constant torque. So here we go. 3, 2, 1. The time starts now. Quickly, only 20 seconds. A, B, C, D. A, B, C, D. Be quick. Be quick. Be quick. Angular momentum of the particle with a central force is constant due to. Angular momentum is constant due to. Time up. What is the meaning of a central force? What is the meaning of a central force? Let's say this is an object, okay, and this is the axis. So if you apply a force along the axis, okay, if you apply a force along the axis, then definitely the torque of that force is going to be zero. The torque of that force is going to be zero. So if the force is central, the torque is going to be zero, and if the torque is going to be zero, then the angular momentum is constant. So the correct answer is C. Simple question. Let's take the discussion ahead. Okay. Next question coming in front of you. Read the question. A ball rolls without slipping. There is a ball which is rolling. A ball is rolling without slipping. Radius of gyration of the ball passing about an axis through its center of mass is K. If radius of the ball is R, then the fraction of total energy associated with the ball. Fraction of total energy associated with its rotation. Fraction of total energy associated with its rotation. That means the total energy divided by the rotational kinetic energy. Divided by the rotational kinetic energy. Kinetic energy rotational. Okay, so what it's going to be? It's going to be half mv square plus half I omega square divided by kinetic energy rotational, half I omega square. How much time do you require for this question? Let's say 40 seconds. So 3, 2, 1, and here we go. The time starts now. All of you get started. Quick. All of you quick. Quick. Fast, all of you. What can you say about this particular term? What can you say about the rotational kinetic energy? That can be written as half mk square, half mk square. So what is the expression going to look like? Quick. First give the answer, all of you. Give the answer. Why you're taking so long to give a simple answer? What it's going to be? You can simply write the expression like this: half mv square plus half mk square divided by half m k square. Isn't it? Half mv square plus half mk square divided by half mk square. So what it's going to be? Fraction of the total energy associated with the rotational energy. What is the fraction of total energy associated with the rotational energy? That means, see, kinetic energy is half mv square. Kinetic energy rotational is half I omega square, isn't it? So what you're going to write? I as mk square. What is I? What is I? All of you? Yes, Darshini is saying reverse the ratio. Exactly, that's what I wanted to say. What is going to be the reverse of the ratio? What is going to be the reverse of the ratio? They are asking the fraction of the, they are asking about the fraction of the total energy associated with the rotational energy. So we have written the rotational is to the total. This is going to be something like this. We need to find out the kinetic energy rotational, divided by the total. Okay, so when you find out the total kinetic energy, that's going to be how much? That's going to be half mv square plus half mk square. Sorry, half mv square plus half I omega square. So if you add these terms up, the total kinetic energy, half m total kinetic energy, half mv square plus half I omega square, isn't it? Just take the ratio with the, just take what this person is saying, physics wala. Band karo. Why band karo? Some more time is remaining. See, be mentally prepared that we are going to do some more concepts. We are going to do some more numericals, and then we are going to sleep. Then we are going to say goodbye. If someone of you is willing to go, that's not an issue. You can simply go, sleep, whatever you want to do that. But if you're sitting in the class, be alert and give the answers. Okay. So anyways, tell me what's going to be the expression for the, we want to find out the reverse expression. So that's going to be rotational upon the total energy. That's simply k square divided by k square plus r square. Okay. So let's take the discussion ahead. Here we go. The next question coming in front of you. For which of the following does the center of mass is outside the body? For which of the following? Pencil, shot put, dice, bangle. Pencil, you know what's a pencil? Only 5 seconds. 5, 4, 3, 2, 1. Time up. What's going to be the answer? The answer is going to be a bangle. Bangle. What is a bangle? Bangle looks something like this. So bangle is basically a ring. So the center of mass is over here. It doesn't lie in the system. Okay, it's not lying in the system. Okay, next question in front of you is this, another conceptual question. Read the question, what it says. Read the question. Which of the following points is likely the position of center of mass of the whole system shown? This is a hollow sphere. Okay, and there is sand over here. There is some sand over here, something like this. So what is the position of center of mass? A, B, C, D. This is A, this is B, this is C, and this is D. Again 10 seconds for this question. Only 10 seconds for this question. So time starts now. Quick, all of you. Quick. 5, 4, 3, 2, 1. and the time is up. So definitely the mass is shifted towards the heavier system. So the answer is going to be C. The center of mass is going to be shifted towards the heavier system, that's going to be downward. Okay. So let's take the discussion ahead. Gravitation we are going to do with the electrostatics. We are coming to the next unit. We are coming to the next unit, and that is gravitation. We are going to do along with the electrostatics because all the concepts are same. We are going to discuss what? We are going to discuss the mechanical properties of solid. We are going to discuss the mechanical properties of solid. Okay. So this is the lap number 7. All of you, be alert. First of all, what is a deforming force? Any force that's acting on the body, any force that's acting on the body which tries to change the separation between its 2 points is what we call as the deforming force. Okay. Any force that acts on a body which tries to change the separation between its 2 segments, this is what we call a deforming force. Okay. And if there is a deforming force, there is going to be a restoring force. If there is a deforming force, there is going to be a restoring force. Okay. Now the property by which, due to which, listen, the property due to which a body gets expanded and again it comes to the original position. If you apply a force, the separation between 2 points is going to change. Remove the force, the separation is again the same. This property is what we call as the property of elasticity. So basically, what is elasticity? What is elasticity? The property by virtue of which the body regains its original shape, shape. Okay. Once the deforming force is removed, once the deforming force is removed. Okay, so you apply a deforming force, it gets expanded. If you remove the deforming force, it comes to the original position. If you remove the deforming force, that comes to the original position. Okay, so this is what we call as the property of elasticity. So what is the restoring force? It is the internal resistance due to which a body opposes the deforming force. Simple. Okay, so this is the concept of deforming and restoring force. Okay. Apart from this, the concept of stress. So what is the concept of stress? Stress is defined simply as the internal restoring force acting on a unit area. If this is a body, okay, and let's say this is any cross-sectional area, this is any given cross-sectional area, apply a force on the body, apply a force F on the body. Okay, this is the area A. So the internal restoring force, not the deforming force, clearly I am saying, internal restoring force acting per unit area is what we call as the stress. This is what you call as the stress. Okay, is this point clear? After this, what are the different types of stresses? See, this is what we call as the tensile stress. Okay, the stress that tends to expand the body. Okay, the stress that's acting along its axis and it wants to expand the body. This is what we call as the tensile stress. Okay, so this is simply the tangential force or the longitudinal force acting per unit area. We denote it by sigma. What is the unit of stress? That's force acting per unit area. That means Newton per meter square. Okay, Newton per meter square. Okay, after this compressive stress, simply if the force acting wants to compress the body, that means the force is acting along the inward tangential direction, along the inward axial direction. This is what we call as the compressive stress. volumetric stress. Volumetric stress. Basically, what is volumetric stress? Now see, what we are saying, this is force acting per unit area. Now, in order to define volumetric stress, we'll be defining volumetric stress after we define the volumetric strain. Okay, so just wait for a moment. Okay, we'll be defining it. Just wait for a moment. Okay, so here we go. Here we go. Here we go. If we talk about the strain, try to understand. This is an object. The length of this rod is L. If you apply a force on this rod, it's going to expand. It expands. Okay, let's say if you applied a force, it got expanded. The length has increased from L to some L dash. Okay, that's cool. That's cool. Okay, let's fix it from one side. Let's say we have fixed it from one side and you have applied a force F. So the length has increased from L to L dash and the change in length is delta L. Okay, so strain is defined as the change in quantity divided by the original quantity. That means change in length upon the original length. This is what we call as the longitudinal strain. What do we call it? L dash minus L divided by L. Is it going to have some unit? No unit. Unitless. Is it going to have some dimension? No dimension. Dimensionless. That's fine. What is volumetric strain? What is volumetric strain? Volumetric strain is simply defined as the change in volume divided by the original volume. Okay, that means final volume minus initial volume divided by the initial volume. Okay, that's fine. Apart from this, there's another type of strain acting in the situation. This is the shear strain. Okay, if you apply a force on the object, in the tangential direction, this is the tangential direction. Let's imagine a heavy book. Okay, a big book that's in front of you. Okay, let me check. Do I have a big book over here? Okay, let's imagine that there's a big book. Keep that book at a table and apply a force at the top. So the book is going to tilt this way. The base is going to remain at its position, isn't it? The upward portion is going to change. Upward portion is going to tilt. The shape is going to look something like this. Okay, so this is what we call as the shear strain. What is shear strain? This is the change in dimension. This is original dimension. So tan theta can be written as x divided by L. Tan theta can be written as x divided by L. Okay, so this is what we call as the shear strain. Okay, I hope that the point is clear. Let's take the discussion ahead. Here we go. Now, if you have an object, let's say this is a wire. You have fixed a wire. Listen, all of you. This is a wire. Very important discussion, all of you. Okay, this is a wire of some length L. What you're doing, you're hanging a mass. You are hanging a mass on this wire. The mass expands to some extent. Okay, you increase the mass. Sorry, the wire extends to some extent. You increase the mass, the wire extends even more. You again increase the mass, the wire extends further. You keep on increasing the mass. What's going to happen? The force that you are applying is increasing. That means the stress is increasing, strain is increasing. That means the strain is increasing. Yes or no? But it's not the case that wire would keep on increasing. At some point, it's going to fail. It's going to get break, isn't it? So what we are saying that there are different regions. This is point number O. This is point number A. In the point OA, the stress is proportional to the strain. In the point OA, the stress is proportional to the strain. This is called the proportionality limit. That means you are increasing the force, you are increasing the mass, strain is increasing. After this point, after this point, after this point, elasticity is maintained. After this point, elasticity is maintained, but the proportionality is not maintained. That means, that means, that means, that means, listen, listen. That means if you are increasing the stress, strain is increasing, but not in the same proportion. For lesser stress, greater strain you're getting. Getting the point? So after the point A, the body is still elastic, but the proportionality is not maintained. Okay. After the point B, the yielding starts. The body gets the tendency to break, and finally it gets, ruptured at the point D. Okay. So the region O to A is linear. This is the region in which the Hooke's law is obeyed. The body is completely elastic. This is called the elastic limit. From A to B, even if you remove the force, the body regains its position. Very carefully listen every single point. After the point A, even at the point B, body regains the position when the force is removed, but it is not proportional. But the stress is not proportional to the strain. Okay, but the stress is not proportional to the strain. The point B is known as the elastic limit or the yield point. Is this point very clear? If the load is increased further, the stress developed, then the strain increases rapidly. After this point, the stress and the strain are not proportional to each other. Okay, let's take the discussion further. In the region B to D, where load is removed, the body does not regain the original dimension. Even when the stress is zero, the strain is not zero. Okay, that means the body has permanently deformed. The body has permanently deformed after that point. The point D corresponds to the tensile strength. What is this called? This is called tensile strength. That means if this much amount of force you apply, the body is sure to deform. The body is definitely going to get deformed. Okay, this is the tensile strength. Okay. If the plastic region is large, the material will be ductile. These are the important points. Okay, these are the important points from NEET point of view, because these questions are being asked. Okay, 2-3 times in the past 5 years. If the plastic region is small, the material will be brittle. Okay, so let's take the discussion further. And here we go. What is basically Hooke's law? The Hooke's law says that within the elastic limit, within the elastic limit for a material, the stress is proportional to the strain. So if the proportionality is removed, you can say stress is Young's modulus times the strain. Okay, this is a stress, this is the strain. Okay, so stress is going to be force acting per unit area. Young's modulus times the strain is delta L by L. Strain is delta L by L. So you can say Young's modulus is nothing but F by A delta L by L. Okay, this is the expression in front of you. Is this point very clear? So what is going to be the unit of Young's modulus? That's going to be Newton per meter square, because the strain is unitless. Strain is unitless. Is this point very clear? Okay. So here we go. What are the different types of modulus that we know? First of all, the modulus of elasticity, simply the ratio of stresses to strain. The longitudinal stress acting, okay, on a body divided by the longitudinal strain developed. Simple. Okay, simple. Young's modulus. After this, modulus of rigidity. This is simply the shearing stress. What is shearing stress? Shearing stress is the tangential force acting per unit area divided by the divided by the shearing strain theta. We have seen the shearing strain, yes or no? Quickly, yes or no? Okay, so this is the modulus of rigidity. After this, the Poisson's ratio. After this, the Poisson's ratio. Poisson's ratio is simply the ratio of lateral strain is to longitudinal strain. See, what is lateral strain? This is D. So delta D by D is the lateral strain. What is longitudinal strain? What is longitudinal strain? That's simply delta L by L. So delta D by D is to delta L by L. This is the expression for the Poisson's ratio. Simple. Remember these three relations corresponding to the moduli. Okay. Young's modulus. Okay. Poisson's ratio. And this is K. That means the bulk modulus. This is shear modulus. I'm writing it over here. Bulk modulus. Bulk modulus. Shear modulus. This is Poisson's ratio. And this is Young's. Let me tell you what the bulk modulus is. Okay, let me tell you quickly what the bulk modulus is. Just a second. So what the bulk modulus is? Here we go. Okay. Bulk modulus beta or K is simply the ratio of volumetric stress is to the volumetric strain. Okay, it comes with a negative sign. It comes with a negative. These are very important. These are very important. Okay, these relations are very, very important. All of you listen. Now, if you consider a balloon inside a bucket or inside a tank, let's say this is a balloon inside a tank that's filled with water. So this balloon is going to experience force from every dimension. Definitely yes. This balloon is going to experience a force from every dimension. Definitely yes. So there is going to be some compression in the balloon. Let's say that the stress acting is delta P. How much is the change in volume? Delta V divided by the original volume V. This ratio is what we call as the bulk modulus. Okay, remember this. So the inverse of bulk modulus is compressibility. Inverse of the bulk modulus is compressibility. Okay, cool. Okay, let's take the discussion ahead. Here we go. Okay, now see, if this is an object, you are applying a force and this expands. So how much work needs to be done in completely expanding the object per unit volume? Work done per unit volume. That's simply half into stress into strain. Okay, so what can you say about the total work done? The total work done is going to be half into stress into strain into volume. Remember this expression as it is. Okay. Now, if you talk about the factors affecting elasticity, what happens if we raise the temperature? Definitely, if we raise the temperature, the molecular motion increases. That means the intermolecular force decreases. That means if you increase the temperature, Young's modulus decreases due to the weakness of intermolecular force. Okay, remember this. Remember this. Okay, so here we go. Okay, yeah. So if we talk about the density, okay, what is basically the density? Density is the amount of matter contained in a given volume, amount of mass contained in a given volume. Yes or no? Definitely yes. So we can say that density rho is nothing but delta M by delta V, or simply M by V. Unit kg per meter cube or gram per cc, one and the same thing, isn't it? But what is basically the relative density, or let's say the specific weight? What is basically the relative density or the specific weight? See, listen all of you. It is defined as the ratio of the weight of a substance to its volume. This is what? This is the normal density. Relative density is defined as the ratio of the density of a given fluid to the density of pure water. That means if you talk about the relative density, you are going to compare the density of a liquid to the density of water. Okay, this is what we call as the relative density. Okay, let's take the discussion further. So basically the relative density is the comparison of the density of any given liquid to the density of water. It's as simple as that. Okay, so what is pressure? What actually pressure is? If this is any given cross sectional area, so how much force is acting perpendicular to that area per unit area? That means the normal force acting per unit area. This is what we define as the pressure. Okay, so it's defined as the magnitude of the normal force acting per unit surface area. Okay, what are the units of the pressure? The units of pressure, ATM, 1 ATM is 1.013 into 10 to the power 5 bar, 10 to the power 5 Pascal. 1 bar is equal to 10 to the power 5 Pascal. 1 torr is the pressure exerted by 1 mm of mercury. That's 133 Pascal. Okay, mm of Hg is also the unit of pressure. Okay, pressure is what kind of quantity? It's a scalar quantity. This is because hydrostatic pressure is transmitted in all directions equally. This is what we call as the Pascal's law. So let's try to understand the Pascal's law. Basically what the Pascal's law says that if you have a system, Pascal's law says that, let's say if this is a container, okay, if this is a container and I have made several valves, okay, several outlets about this container. Okay, this valve is closed, this valve is closed, this valve is closed, this valve is closed, this valve is closed. Okay, that's fine. Okay, you are applying a force at one segment, you are applying a pressure at one segment. So the pressure that you have applied at any segment, is going to be transmitted. You are applying a pressure at segment A, the same pressure is transmitted at B, C, D and E undiminished. The same pressure is transmitted at every section of the fluid undiminished. This is what we call as the Pascal's law. And on the basis of Pascal's law, we have a very important device. That's what we call as the hydraulic lift. See, if this is the liquid, okay, if this is the liquid inside the container, okay, you are applying a pressure. Listen all of you. The notes are available on the PW app. What is Coco saying? Example of bus. Listen. This is basically what? This is a hydrostat. This is hydraulic press. If you apply a pressure at segment A, the same amount of pressure you're going to observe at the segment B. Same amount of pressure you're going to observe at the segment number B. So what are you going to write? You're going to write that the force acting per unit area at segment 1 equals the force acting per unit area at the segment number 2. Yeah, that's cool. That's cool. So what can you do? If you have different areas, if you are applying a force at segment number 1, you can get the value of the force that you're going to get at the segment 2 by changing the area. Okay, Maha Hussain is saying session kab rukega? Session I guess let's see कब रुकता है. जब इच्छा होगी, जब सेशन खत्म हो जाएगा तब रुक जाएगा. इशिता मुखर्जी इज आस्किंग और कितनी देर होगा? थोड़ी देर और होगा। ओके, थोड़ी देर और होगा, कुछ देर के लिए और होगा, ठीक है। एनर्जी बरकरार रखो, एनर्जी बनाए रखो। तो आ जाओ, कार उठा ही लेते हैं इस बात पे, कार उठा ही देते हैं इस बात पे। यू आर अप्लाइंग अ फोर्स F1 at the segment A1. You get a force F2 at the segment A2. Okay. So you can say that the force acting per unit area, that means the pressure does not change. Same pressure is transmitted throughout the fluid, throughout the liquid, isn't it? So F1 by A1 equals to F2 by A2. So this much amount of upward force you are going to get at the other segment. It's as simple as that. Okay. Let's take the discussion ahead. Let's take the let's take the discussion ahead. There's a question coming in front of you. Read the question. Some questions regarding the elasticity. Breaking stress. What happened? Breaking stress of a wire depends upon only 20 seconds. 3, 2, 1, time starts. Begin, all of you. Breaking stress of a wire depends upon. Breaking stress of a wire. Quickly, all of you, do this fast. Fast, 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 fast. All of you. We are talking about the breaking stress of a wire. Okay. So the breaking stress is the property of the material of the wire. Okay, it doesn't depends upon the length or the radius or the shape of the cross section. No, 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 no. It doesn't depends upon the length, radius, and the cross section. It depends upon the Young's modulus. Breaking stress. Okay, that's what. That's the deforming force acting per unit area. So on what value of force this wire is going to break, it depends upon the material of the wire. Okay. Next question coming in front of you is this. When a metal wire elongates by hanging a load mg on it. Okay. This is the metal wire. You have elongated it by hanging a load m. The gravitational potential energy of the mass m decreases by mgl. This energy appears in which form? This energy appears in which form? This is what they are asking. Quickly. 3, 2, 1. Again 20 seconds. Conceptual question. Conceptual question. Quickly, all of you. A simple conceptual question in front of you. Quick. Time up. Okay. See, the point is, listen. The point is that if you apply a load, the material is going to expand. And if the material expands, then what happens? Its elastic potential energy is going to increase. That you are doing the work, that's going to get stored in the form of elastic potential energy, but also there are going to be heating effect. It's going to get heated. So what we are going to say? We are going to say that definitely some portion goes into elastic potential energy and some portion goes into the thermal energy. Okay. So C is going to be the practical answer. Okay. Let's take the discussion further. Another question. A material of Poisson's ratio 0.5. If a uniform rod of it suffers a longitudinal strain of this much, the percentage change in its volume. Longitudinal strain has been given to you. Percentage change in volume has been asked. So what is basically the Poisson's ratio? Poisson's ratio, let's denote it by Poisson's ratio sigma or E, whatever you want to write. Poisson's ratio, that's the ratio of lateral is to longitudinal, isn't it? Lateral strain is to longitudinal strain. Yes or no? And this Poisson's ratio has been given to you as 1/2. And longitudinal strain has been given to you as how much? Longitudinal strain has been given to you as this much. Okay, this much. Okay. Now see, this is a uniform rod. This is a uniform rod. That's cool. Okay, this is a uniform rod. So this is delta L. This is delta L, the lateral. Okay, longitudinal, and delta D by D. So, just a second. Shh. Quiet. This is the question. Read the question and give the answer. Read the question and give the answer. Quickly, all of you. This is a simple, direct question. This is not half. This is not half. This is 0. These are the options in front of you. These are the options in front of you. Okay, this is not half, this is 0. So let's see what you do. 10 seconds for this question. Time starts now. Time starts now. All of you quick. Quickly. ABCD. Okay, time up. Time up. See, you can solve this question. You can get the question. You can say volume is equal to area into length. That means pi d square by 4 into length. Okay. So you can say that delta V by V equals to 2 times of delta D by D plus delta L by L. You can say this. You can write this. Okay. This is the concept. This is the concept. But the reality is that the volume does not change. But the reality is that the volume does not change. And if the volume does not change, the delta V is going to be 0. Delta V is going to be 0. So simply the answer is going to be 0. Okay. Simply the answer is going to be 0. Let's take the discussion ahead. Volume does not change. It's going to be 0. The next question coming in front of you is this. The next question coming in front of you is this. A metallic rod of length L and cross-sectional area A is made up of a material of Young's modulus Y. If the rod is elongated by an amount Y, okay, then the work done is proportional to what? This is what you need to figure out. Again 30 seconds. 3, 2, 1, start. Again 30 seconds. 3, 2, 1, start. Quickly. Work done is proportional to. Quickly. Fast. Okay, time up. So can we say that work done is going to be nothing but average force into the extension, whatever the extension is, isn't it? Into the extension. Can we say this? A lot of you are giving the correct answer. Definitely. Very good. Doraemon Yadav, whatever your real name is. Work done can also be written as the change in energy. Okay. Change in energy. And you know that simply the energy is half into stress into strain, isn't it? Half into stress into strain. This is the energy per unit volume. This is the energy per unit volume or work done per unit volume. So if you compare, this is half into stress. Stress is force acting per unit area into strain is delta L by L. Strain is delta L by L, isn't it? The total work done or the total energy is going to be half into stress into strain into volume. Into volume, where should I multiply? Let's multiply it over here, volume. Volume is area into length. Volume is area into length, isn't it? So this area into length gets cancelled out. Area into length gets cancelled out. So you can see that the work done is proportional to, either way you get the same result. Work done is proportional to force into delta L. What is average force? Average force is F by 2. Okay, it's F by 2. So F, what is F? What is F? Which force are we talking about? If you talk about an object, okay, so the force that we are talking about, the restoring force, that's proportional to the displacement. That's proportional to x. We know this, isn't it? So this force itself is proportional to the displacement. And what is displacement? That's y. Delta L is y. What is the elongation? What is the elongation? Elongation delta L is nothing but y. So work done is proportional to y into y. That means y square. Work done is proportional to y square. Simple. What happened to Raghav? Why are you spamming? You want to get blocked? Okay, definitely I'll convey your message. But now, please either study or let others study. Okay. Raghav, you're spamming. This is not called commenting. Okay. This is called spamming. Try to understand the difference and maintain the decorum. Okay. Here we go. Next question coming in front of you is this. Next question coming in front of you is this. Read the question. Read the question. The length of a wire is increased by L due to a factor F applied on it. Work done in stretching the wire will be. Again, plus 4 minus 1. Keep on writing your marks. 30 seconds. Be quick. All of you. 30 seconds. Be quick. All of you. Direct formula. ABCD. Quickly. Be quick. Be quick. Be quick. All of you. Be quick. Fast. Okay, time up. Time up. Time up. So what are we saying? We are talking about the work done in stretching the wire. That's going to be half into stress into strain into volume. Half into stress into strain into volume. Okay. So what is going to be stress? Stress is simply going to be force acting per unit area. What is going to be strain? Strain is going to be change in length divided by the original length into volume is area into length, isn't it? So what it's going to be? Area into length gets cancelled out. Area into length gets cancelled out. So the wire increases by L. Delta L itself is given as L. So this is FL by 2. A simple question in front of you. The answer is FL by 2. Okay. So let's take the discussion ahead. C is the answer. Okay. C is the answer. C is the answer. Let's take the discussion to hydrodynamics. Okay. Lap number 8. Quickly. After this thermodynamics. After this oscillation and then waves. Then finish. Okay. Simple. So here we go. Here we go. Here we go. Basically what we need to understand first of all the types of flow. Steady flow is the flow in which the fluid velocity at any point does not change with time. Try to understand. Who wants to stand up over there? Let's say we are taking Bhumi and we are taking Havish, okay, and Doraemon Yadav. Let's say this is person number 1 standing over here, Bhumi, person number 2 standing over here, Havish, person number 3 standing over here, Doraemon, okay. So water is flowing something like this. The point is, the thing is that whenever any particle, whenever any given particle reaches this point, let's say it has velocity 10 meter per second. This particle reached another point, its velocity turned out to be 15 meter per second. It reached another point, its velocity turned out to be 20 meter per second. Okay. If next particle is coming, listen all of you, if next particle is coming, all of you, at this point, this is the particle, it is coming at this point. When this previous particle comes the same point, its velocity is same, its speed is same. Getting the point, all of you? What I'm saying? Tell me, what am I saying? I am saying that when any particle comes at that particular point, its speed at that location is same. That doesn't mean the speed of every point is same. When the previous particle, this is my hand number 1, it reaches this point, its velocity is 10 meter per second. When left hand is coming at this point, its velocity is also 10 meter per second. When it reaches the point number B or C, its velocity is 15 meter per second. Another point reaches over here, the velocity of that particle is also 15 meter per second. Getting the point? All of you getting the concept? Ankit, Pratiksha, Doraemon. Yes, predecessors will have the same speed. Very good. Okay. This is what we call as the steady flow. Okay. The fluid particle may have different velocity at some other point. Okay, that's fine. That's fine. If you talk about the laminar flow, so the flow of a fluid, of a liquid in terms of layers, somewhat like this, one above the another. If you observe the banks of a big river, okay, one above the another, that's what we call as the laminar flow. Okay. Equation of continuity. What the equation of continuity says? It says that the amount of liquid that's entering a given segment should be equal to the amount of liquid that's leaving the segment. Yes or no? Let's say per second 2 kg of water is entering. So per second 2 kg of water should leave the system. Yes or no? What I am saying that mass entering the segment per second should be equal to the mass leaving the segment per second. Mass is equal to volume into density. Volume is area into length into density divided by the time. Area into length into density divided by the time. Okay, that's fine. Length upon time is velocity. Okay, so this rho gets cancelled out. So A1 V1 equals to A2 V2. A1 V1 equals to A2 V2. Clear? Is this point very clear? So this is the expression for continuity equation. The total mass inlet equals to the total mass outlet. The total mass entering equals to the total mass leaving. Okay. Density remains same. That's why we say that A into V remains constant. That's why we say what? We say that the A into V remains constant. Now, if you talk about the Bernoulli's theorem, so what basically the Bernoulli's theorem says, what basically the Bernoulli's principle says, consider a tube somewhat like this. This is the fluid entering from one segment. This is the fluid entering from one segment. This is the fluid leaving from the other segment. Okay. So what are the different kind of energies that are involved in the situation? Kinetic energy, pressure energy, and potential energy. The sum of all the energies, the total energy of the system, that means the sum of kinetic energy plus the pressure energy plus the potential energy remains constant at the segment number 1 and at the segment number 2. How do we represent it in the equations? How do we represent it in the form of equation? First of all, what is the kinetic energy? We are discussing the kinetic energy for a given volume. That means half mv square divided by the volume. V is the velocity over here and this is the volume. So the expression is half rho v square. Okay. if you talk about the potential energy per unit volume, that's simply going to be mgh divided by the volume. So this is nothing but the rho gh. This is what? This is rho gh. What is the potential energy per unit volume? This is simply rho gh. Okay. Pressure energy per unit volume. Pressure per unit volume. What is basically pressure? What is basically pressure energy? Energy is work done. Try to understand. Pressure, energy. Energy and work done are the same thing. Work done is force into displacement. Force is equals to pressure into area into displacement. Let's call it as delta x. So this is nothing but the volume. This is volume. So work done can be written as the product of pressure into volume. Work done can be written as the product of pressure into volume. So if you talk about the pressure energy per unit volume, this is going to be pressure into volume divided by the volume. This is nothing but the term of pressure. This is nothing but the term of pressure. Okay. Is this point very clear? Is this point very clear? Clear? All of you? Yeah. So we are discussing Bernoulli. We have not still discussed the Bernoulli theorem. I've just discussed the different forms of energy. So what am I saying? I am saying that at any given segment, the sum of pressure energy per unit volume, potential energy per unit volume, and kinetic energy per unit volume. What am I saying? I am saying that at any given segment, the sum of these three energies per unit volume, kinetic energy per unit volume divided by pressure energy per unit volume divided by the potential energy per unit volume, it remains what? It remains constant. It remains what? Yes, Bhumi, that's what I'm saying. I'm saying that for a segment, for two segments, the sum of these three energies, yes, Aditya, that's what I'm saying. Bernoulli's theorem, that for two segments, the sum of pressure, kinetic and potential energy per unit volume remains same. What is the pressure energy per unit volume? Right now we have seen pressure energy per unit volume. That's nothing but the term of P. What is the kinetic energy per unit volume? What is the kinetic energy per unit volume? That's nothing but rho gh. What is the potential energy? Sorry, what is the kinetic energy per unit volume? Half rho v square. What is the potential energy per unit volume? Rho gh. So the sum of these three energies per unit volume remains what? That remains constant. That remains constant. Okay. So remember this discussion. Let's take the discussion ahead. Okay. Let's take the discussion ahead. So this is the expression in front of you. Okay. Pressure, kinetic, potential energy per unit volume remains constant. Okay. Now I'm defining some terms. Pressure head. That's nothing but P divided by rho g. Kinetic head. Listen. Kinetic head. What is the rho g h? Sir, what's the rho g h is equals? What do you mean, Mitanshi Tomar? Rho g h is equal? Bhumi is asking why? Because the total energy is conserved. Oh. In the Bernoulli theorem, try to understand. This is you applying a pressure from one side. This is the pressure by the fluid in the opposite side. So you are doing work in order to take the body up. That means the work done goes into changing the potential energy and the kinetic energy. And the work done is what? That's P delta V. Isn't it? So this is simply the energy conservation. The expression that we have written. Apart from this, remember the pressure head. Okay. The velocity head, V square by 2G. V square divided by 2G. And this is the pressure head. And the potential head. Potential head is nothing but H. Please note it down. Please note it down. Yes, these terms are very important. You have to remember these terms. These terms are very important. You have to remember these terms. Please note it down. I'm giving you some time for this. That's just a terminology, Bhumi. That's just a terminology. Okay. So let's try some numericals. Sorry. Let's try some numericals on this. Read this question. In which of the following cases will the fluid flow in a pipe be most streamlined? They are talking about the most streamlined flow. They are talking about the most streamlined flow. See, I am giving you a term. This is called Reynolds number. This is called Reynolds number. Reynolds number defines the flow, whether the flow is going to be streamlined or turbulent. No, Sujal, I am not ignoring you. Definitely, I am not ignoring you. Are you having some doubt? Please ask. This is rho V d by mu. Okay. Rho is the density, V is the velocity, D is the diameter, and mu is the coefficient of viscosity. Okay. Write it down. Density, velocity, diameter of the pipe, okay, and the coefficient of viscosity. Okay. Okay. Yes, listen. Listen. So what are we saying? We are saying that, now read the question. Which of the following cases will be most streamlined? Now try to do this question. Shubham, basically this is the comparison of the energies along with height. If I give you the practical application, this is the comparison of pressure head, means that along with what height, how much pressure is going to change. You are going to comparing the energies along with the height. That's why we have divided it by the term of rho g, such that we get the dimensions of h. If you see over here in the complete discussion, every term is having the dimension of height. Okay, Shubham, and all of them who were having the discussion regarding the heads. Okay. Yeah, so anyways, 30 seconds for this question, and the time starts now. 3, 2, 1. All of you be quick. So here we go. What happened? Anyways, you get started. Give the answer, all of you. A, B, C, D. The timer is not starting, but you get started quickly. A, B, C, D, A, B, C, D, A, B, C, D. What's going to be the answer? What's going to be the answer? What's going to be the answer? The answer is going to be, let's check. Liquid of high viscosity and high density. High density and through a pipe of small radius. Radius is small, high density. Wrong. No, that's false. That's wrong. Liquid of high viscosity, low density, flowing through a pipe of smaller radius. Now see, Reynolds number should be a particular value. This is viscosity, density, diameter. Okay, the Reynolds number, R or RD, the Reynolds number should be lesser than 1500. Okay, 1500 or 15,000 it is. I exactly don't remember. Okay, in short, it should be below a certain value to keep the flow streamline. Okay. Getting the point, all of you? So what I'm saying, that in order to keep the flow streamline, you need to keep the density low, you need to keep the diameter low, you need to keep the viscosity high. So the only option that's matching this situation is something like this. Okay, high viscosity, low density, and smaller radius. I hope that this point is absolutely clear. Okay. So the next question coming in front of you is this. Read the question, all of you. What the question says, all of you read the question. What the question says, quickly. A body floats in a liquid contained in a beaker. The whole system shown in the figure falls freely under gravity. This whole system is falling freely under gravity. The upthrust on the body is going to be. This is a body. Okay, this is the body. The system is falling down. Quickly. So 20 seconds for this question. 3, 2, 1. And the time starts now. Quick, 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 quick. All of you. Do this fast. All of you. This is the condition of weightlessness. Hello, Mitanshi. Hello, everyone. Let's see, the class would be for some time more. Okay. Okay, anyways, time up. So what the answer is going to be in this situation? See, when the system is kept something like this, this is the liquid. Okay. And this is the object. So what happens in this situation? This is mg, and this is the buoyant force. Okay, mg and the buoyant force. Okay. Sir, please clear my confusion. Can we say that more the Reynolds number, more the streamline? Definitely no, Harsh. You are saying the opposite. Higher the Reynolds number, the flow is going to be non-streamlined. It's going to be turbulent. Yeah. So this is the condition. Now the point is that if the body is falling freely, then in that situation, is there going to be any upthrust? If the body is falling freely, is there going to be any upthrust? Definitely no. The upthrust is going to be 0. Under free fall. This is weightlessness. This is the condition of weightlessness. Okay. Because this is A, you're going to say mg minus fb equal to ma, and ma equal to mg. This gets cancelled out. So fb equal to 0. Simple. Okay, remember this. Just true to you. I am weak in physics and I want to score as much I can. So can you help me? What should I do? Definitely try to just follow the sequence that we are doing. Okay. Let's take the discussion further. Here we go. Next question. Which of the following phenomena does not involve the viscosity of air at all? What happened to Aditi? Why is she angry? Aditi, I don't think that anyone invited you. You can just go and sleep. Why are you doing these comments? I don't understand. If someone is studying and someone is teaching, I don't think that this is the appropriate manner to just come and speak anything that you want. Okay. Everyone else, give the answer. Which of the following phenomena does not involve the viscosity of air? Read the options. 3, 2, 1. And the time starts now. Quickly, all of you. 10 seconds only. Quick. Time up. Now see, all of you. What is the point? We are saying that a meteorite burns up on entering the Earth's atmosphere. So this is completely due to air friction. This is completely due to drag. This is completely due to the frictional force between the object and the surface. That's cool. Raindrop falling from a greater height. This is the raindrop. So it experiences a drag force. Definitely yes. Ball spinning. This is the Magnus effect. This is the Magnus effect. It's the Magnus effect. And yes, it happens. It happens because of the friction between the object and the surface. Okay. So this is Magnus effect. So all these three examples are involving the viscosity. Okay. All these three examples are involving the viscosity. But if you talk about the air flowing through a tube of variable cross section, okay, something like this. So the velocity is different. This is not due to viscosity. This is not due to viscosity. Okay, this is due to the conservation of mass, conservation of volume. A1 V1 equals to A2 V2. Okay, so I hope that this point is absolutely clear. Let's take the discussion ahead. Next question quickly. All of you read the question. What this question says: a tube shown is of uniform cross section, liquid flowing through a constant speed. This is the water entering, this is the water entering, and this is the water leaving. Okay, so what is it going to do? The liquid exerts on the tube. What is it going to do? It exerts a force, it exerts a torque. Think about the situation. Net force towards the right, net force towards the left, clockwise torque, anti-clockwise torque. What is going to act in this situation? Fast, all of you. 20 seconds. 20 seconds. 3, 2, 1, and the time starts now. Quickly. Fast. Yeah. Okay. Sufficient time has been given. Let's see what you have thought regarding the situation. So, is it going to have a net force towards the right? Is it going to have a net force towards the right? Definitely no. No. Let's try to understand what is happening. Net force towards the left, clockwise torque, anti-clockwise torque. If you observe the situation, water is entering, water is going to hit this surface and it's going to change its direction. Water is going to hit the surface and change the direction. Okay. Water is going initially along this direction, finally along this direction. Okay. So what is the direction of change in velocity? Velocity final minus velocity initial. That's velocity final plus minus of velocity initial. Is this the direction of change in velocity? Is this the change in velocity? So if this is Vi, this is minus of Vi. This is minus of Vi. Yes or no? Definitely yes. So the change in velocity is along this direction. This is the direction of change in velocity. So we know that the force, okay, the reaction force is going to be along which direction? If this is the direction of change in velocity, This is the direction of the force applied by the water. The direction of change in momentum. Force is equal to rate of change of momentum. So this is the direction of applied force. So the reaction force on the object is going to act on the opposite direction. This is the reaction force acting on the pipe in the opposite direction. Similarly, the reaction force acting over here is something like this. If you observe the situation, okay, if you observe the situation, let's say one force is acting over here, one force is acting over here. So in what direction is it going to make the system rotate? Something like this. Yes or no? Quickly. What is going to be the direction? What is going to be the direction of the torque? It's simply going to be along the clockwise direction. Yes, very good. Perfect. So the answer is going to be clockwise. It's going to produce a clockwise torque. It's going to produce a clockwise torque. Okay. Is this point clear? All of you. Cool. Let's take the discussion ahead. Here we go. 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 Okay. Next topic that we are beginning is the thermal properties of matter. Basically, it's the thermal science. We are going to cover all the concepts of the thermal science in this lab. Let's see how much time do we have. Okay, the remaining portions we would be covering in the upcoming session in a separate marathon. Okay, that I'll be informing on the community post. Is that point clear? Yeah, so here we go. Here we go. Here we go. Here we go. Just a second. Let me check with the team that how much time do we have. Yeah, sorry for the delay. Sorry for the disturbance. Let's get back to the point. So what I was saying, all of you, what I was saying, we are beginning with the thermal properties of matter. Okay. Listen, listen, listen. Listen. We are beginning with the thermal properties of matter. So basically all what we have to see in this session, the concept of thermometry, the concept of expansion, the concept of heat transfer, the concept of thermodynamics. Okay, and calorimetry. So let's begin with the content. Here we go. First of all, basically what is heat? if I take the discussion from heat, listen, if I talk about heat, what is basically heat? Heat is a form of energy. Yes, that's true. If I ask you what is heat, definitely heat is a form of energy. Okay, that's cool. But how is it different from the different forms of energy? It is a form of energy in transit. It is a form of energy in transit. That means it comes into picture when you bring two bodies in contact which are having a difference in a parameter that gives you the sensation of heating or cooling. What is basically the sensation of heating or cooling? What is basically that parameter which gives you the sensation of heating or cooling? That's the temperature. So let's say this is TA, this is TB. So if TA is greater than TB, you are going to observe the flow of heat from one body to another. If the temperature of one body is greater than the other, you're going to observe the flow of heat from one body to the another. Okay. Yeah. After this, if I talk about temperature, so basically what is temperature? Temperature is simply the degree of hotness or coolness of a body. Temperature is simply the degree of hotness or coolness of a body. That means it gives you the information about how hot or how cool a body actually is. Okay. If you bring two bodies in contact which are having different temperatures, this is A, this is B, TA is greater than TB. So heat is going to flow from A to B. Till what extent? Till the moment their temperatures become same. Okay, till the moment their temperatures become same. That means at thermal equilibrium, at the final stage, at the final temperature, that's what we call as the thermal equilibrium. At the thermal equilibrium, the temperature of the two bodies in contact is going to be same and the flow of heat is going to be zero. Simple. Let's take the discussion ahead. The next concept is the zeroth law of thermodynamics. What it simply says that this is TA, this is TB, this is TC. If you bring these three in contact, now the heat flow between A and C is possible. Heat flow between B and C is possible. Okay. So finally, temperature of A is going to be the temperature of equal to the temperature of C. Temperature of B is going to be equal to temperature of C, because A and C are going to be in thermal equilibrium. B and C are going to be in thermal equilibrium. That means, in short, finally all the three bodies are going to be in thermal equilibrium. Okay. TA equal to TB equal to TC. Simple. Is this point very clear? Let's take the discussion ahead. This is the zeroth law of thermodynamics. Okay. Simply what it means, if A and B are brothers, if A and C are brothers, if C and B are brothers, then A, B and C, all three are brothers. Okay. Remember it like this. Okay. Let's take the discussion ahead. Here we go. If you want to compare and measure the temperature, then you have a device that's what you call as the thermometer. What it does, it takes a thermometric fluid that shows the property of expansion on heating. For example, mercury. This is the lower point, this is the higher point. If I talk about the normal thermometer, the lower point is the 0 degree centigrade freezing point, higher point is boiling point of water. That means the 100 degree centigrade, isn't it? So if you compare any two thermometers, so remember the general formula that I am giving you. Higher point minus the reading. Just a second. I am giving you the general formula. Reading minus the lower point divided by the higher point minus the lower point. This remains constant. Okay. This remains constant. Simple. This remains constant. Okay. Now I'm making a thermometer out of your name. Let's say we are making a thermometer, Chitrali thermometer. Okay, we are making a thermometer called Chitrali thermometer. So you are comparing the normal thermometer, okay, the degree thermometer that we have, which is having the lower point as 0 degree centigrade, higher point as 100 degree Celsius or 100 degree centigrade, isn't it? And these are the 100 calibrations. This is Chitrali thermometer. Chitrali thermometer. She is denoting it by CT. Okay, she is denoting it by CT. 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 So the lower point of Chitrali thermometer is 100 CT. Try to understand. Higher point is 300 CT. 300 Chitrali. Okay, directly take the name because that's Celsius. That's also the name of the scientist. So Chitrali became a very big scientist and she made a thermometer and this is the situation. Okay, this is the thermometer after name of Miss Chitrali. So if the left thermometer, if the degree thermometer shows you a reading of 20 degrees centigrade, so how much is going to be the reading on the Chitrali thermometer? All of you quick. All of you quick. Option number A, 40. Option number B, 140. Option number C, 100. Option number D, 240. Sorry, 200, 240. A, B, C, D. Quick, quick, quick. Quick, 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 quick. Fast. Give me the answer. Quick, 10 seconds. 10 seconds for you. Begin. Uh-oh. Not moving. No worries. Give me the answer. Fast. All of you. Okay. See, basically, if you go through the formula or if you go through the direct logic, if you go, listen. If you go through the formula or if you go through the direct logic, what you can say, if it is having how many calibrations? It is having 100 calibrations. How many calibrations are there? 100 calibrations are there. And how many calibrations are here? 200 calibrations are here. How many calibrations are here? 200 calibrations. Okay. 100 calibrations, 200 calibrations. So if you move 20 calibrations, here you are going to move 40 calibrations. Yes or no? Yes or no? If you move 20 calibrations on the left scale, you are going to move 40 calibrations on the right scale. Yes or no? So the answer is going to be 40 above 100 because your starting point is 100. So the final answer is going to be 140 Chitrali. Okay, this is the final answer on the scale. 140 CT. 140 CT. Okay. Direct question. Let's take the discussion ahead. So here we go. The next concept that's coming in front of you is the concept of expansion. Now we know that if you talk about any given object, no matter the object is looking stationary, the particles are under continuous vibrational motion. The particles are under continuous vibrational motions. Yes, the particles are vibrating. The particles are continuously vibrating. Okay, the particles are doing what? The particles are vibrating. The particles are vibrating. If you raise the temperature, then what happens? If you raise the temperature, the vibrational amplitude increases. If the vibrational amplitude increases, that finally results in the increase in length of the object. Okay. So we say that the object expands. We say that the object is going to expand. So delta L is proportional to delta L by L is proportional to delta theta. That means the fractional change in length is proportional to the temperature difference. The fractional change in length is proportional to the fractional change in length is proportional to the temperature difference. Okay, so delta L is proportional to L delta theta. If you remove the proportionality, this is going to be delta L equals to L alpha delta theta. Delta L is going to be equal to L alpha delta theta. Okay, so what is delta L? Delta L is the final length minus the initial length equals to initial length alpha delta theta. So what you can write? You can write final length is initial bracket 1 plus alpha delta theta. Simple. Okay, is this point clear? Is this point clear? All of you? Is this point fine? Okay. Next point, if you talk about the aerial or the superficial expansion, this is the area. This is the area. Okay, this is the area. Okay, that's fine. So the area delta A by A is proportional to delta theta. If the proportionality is removed, delta A equals to A beta delta theta is going to be the expression. This is going to be the expression. Okay, this is going to be the expression. Delta A equals to A beta delta theta. So the final expression can be written something like this. And from the concept of error analysis, we can say that beta is going to be twice that of alpha. Similarly, if you talk about the volumetric expansion, the change in volume upon original volume is proportional to gamma delta theta. Okay, so the relation between alpha, beta and gamma is going to be 1:2:3. It's going to be 1:2:3. Okay, so let's take the discussion ahead. Okay, basically what is heat? We have seen what is heat. Heat is the energy in transit. It is the energy in transit which comes into picture when two bodies are brought in contact at different temperatures. From higher temperature to lower temperature, it flows. Okay, heat is felt by the effect, and some of the effects are change in the degree of hotness, change in the length, surface area, volume, change in the state, change in the resistance of a conductor, and thermo EMF effect. So let's discuss the effects. Okay, first of all, what's the unit of heat? If I ask you what is the unit of heat, the basic unit of heat, that's going to be calorie. Okay, what is 1 calorie? How do we define 1 calorie? This is water. How much water is it? This is 1 gram of water. This is 1 gram of water. Okay, heat 1 gram of water. Heat 1 gram of water. Okay, if you heat 1 gram of water, then what happens? If you heat 1 gram of water, then what happens? Its temperature changes. Now you need to provide that much amount of heat. You need to provide that much amount of heat such that the temperature of 1 gram of water changes by unity. What am I saying? Amount of heat required to raise the temperature of 1 gram of water by unity, by 1 degree or 1 Kelvin. Okay, this is what we call as 1 calorie. Getting the point? All of you getting what I'm saying? Getting what I am saying? I am saying the amount of heat that should be given to 1 gram of water to raise the temperature by 1 degree centigrade or Kelvin. Thermal heat capacity is different. Specific heat is for any given material. I am talking only for water. Okay, international calorie is the specific calorie. Okay, international calorie is basically specific calorie. What it says, That means you are going to raise the temperature from 14.5 degrees centigrade to 15.5 degrees centigrade. Okay. Anyways, basic discussion. Let's take the discussion further. Here we go. Specific heat. What is basically specific heat? Let's say this is any given material. This is any given material. Okay. If you heat the material, if you are heating the material, what is going to happen? The temperature of the material is going to rise. Okay. So the mass of the body is unity. The mass of the body is unity. You need to raise the temperature by unity. The mass of the body is unity. You need to raise the temperature by unity. How much amount of heat should be given? How much amount of heat should be given? So the amount of heat that should be given to raise the temperature of a body having a unit mass by unity, that much amount of heat is what we call as the specific heat. No need to mug up the definition. This is simply heat that should be provided to a unit mass to raise the temperature by unity. Simple. Okay. Getting the point? All of you. So what are going to be the units? What's going to be the unit? Joule per kg Kelvin. Calorie per kg Kelvin, or calorie per gram per Kelvin. Actually, that's the point, you know. I have spoken so much of English today. I didn't spoke this much English in the past whole year. That much I have spoken today. Okay. Yeah. Anyways, it's a nice experience. It's a different experience. So after this, the thermal capacity. What is the thermal capacity? Thermal capacity is simply the mass into specific heat. That means you need to raise the temperature of m mass of a body by unity. Okay. So that is m times of C or m times of S. This is what we call as the thermal capacity. Unit calorie per Kelvin or calorie per degree centigrade. After this, the latent heat. What is the meaning of the latent heat? It is the hidden heat. Now the question is, listen all of you. Whose unit? किसकी unit बेटा? Unit बताए ना, calorie per degree centigrade या calorie per Kelvin. Heat capacity की ना? Yes, बताई तो सही. अब सुनिए सब लोग, सुनिए. I started speaking Hindi. Sorry. Listen all of you. English channel, English medium. Listen. Latent heat or hidden heat. Now the point is that if this is an object, okay, let's say this is ice. Try to understand by a graph. Okay, let's try to understand it with a graph. The graph is between temperature and heat. Okay. This is the temperature and you are providing heat to the body. Let's say the object was initially at minus 20 degrees centigrade. Ice at minus 20 degrees centigrade. Okay. Ice at minus 20 degrees centigrade. This is ice at minus 20 degrees centigrade. You keep on heating the object. If you keep on heating the ice, its temperature is going to rise until what level? Until 0 degree centigrade. The temperature rises. You are providing heat at a constant rate. The temperature raises up till 0 degree centigrade. Listen. Ice at minus 20 degree centigrade. Ice at minus 20 degree centigrade. Provide certain amount of heat to this object. It's going to increase. Okay. And it's going to reach 0 degree centigrade. Now, if you further provide certain amount of heat, so what's going to happen? the state of the body is going to change. The state of the body is going to change. Okay. That means at the same temperature, the state of the body has changed from ice to water. At the same temperature, the state of the body has changed from ice to water. Okay. At the same temperature, ice has converted into water. This is what we call as the phase change process. The phase has changed. Okay. So this heat is latent heat. This is sensible heat. This is sensible heat, latent heat. Okay, that's fine. After this, if you still keep on heating, the temperature rises till where? The temperature rises till where? The temperature rises up till 100 degrees centigrade. Okay. The temperature rises up till 100 degree centigrade. Yes, the temperature rises up till 100 degree centigrade. Okay. After this, what happens? If you further keep on heating, keep on heating this object again, the state is going to change. Again, the state is going to change. And this is what we call as the latent heat. This is sensible heat. Okay. So basically, what is the latent heat? Latent heat is the amount of heat that should be provided to an object so that at the constant temperature, its state changes. Getting? So let's say the mass of the object is m. So Q is equal to m times of L. Yeah, that's fine. That's cool. That's okay. That's nice. If I talk about L, latent heat can be of two types. Latent heat of fusion and latent heat of vaporization. Latent heat of fusion is the amount of heat that should be given. Listen, amount of heat that should be given to a unit mass of an object so that it gets converted into liquid at the same temperature, at its melting point. Okay, at its melting point. Okay, that means you want to convert ice at 0 degree, for example, ice at 0 degree into the water at 0 degree. Okay, this is called latent heat of fusion. What is latent heat of vaporization? You have water, heat it and convert it into vapor at 100 degrees centigrade. That means at the boiling point. Okay. Water, and this is steam. Okay. Getting the point, all of you? So here we go. Latent heat of fusion. What I said regarding the latent heat of fusion, Q equal to m into LF, the amount of heat that should be provided to a solid, at its melting point, okay, LF is Q by m. The amount of heat that should be provided to a solid at its melting point such that it gets converted into the liquid at the same temperature. Okay. This is what we call as the latent heat of fusion. Okay. After this, if you talk about the latent heat of vaporization, what is latent heat of vaporization? Let's say you have a liquid. Okay. So if you heat this liquid, it gets converted into vapors. It gets converted into steam. So the amount of heat that needs to be provided to this liquid at its boiling point so that it gets converted into the vapor at the same temperature. If we talk about water, it's going to be 100 degrees centigrade. Yes or no? Definitely yes. So what it's going to be? Q equal to m times of LV. LV is equal to Q divided by m. Okay. So here we go. Basically, what are the phase change processes? Melting. What is melting? Melting is the conversion of solid into liquid at a particular temperature. without the change in temperature. This is what we call as the melting. Boiling, listen, boiling is the temperature, the boiling point is the temperature at which the pressure of the liquid equals the atmospheric pressure, equals the vapor pressure, okay, above it. That means it's going to get freely converted into vapor state, okay. Evaporation within the whole mass of the liquid is called boiling. Evaporation takes place at every temperature. Evaporation takes place at every temperature, okay. The water keeps on evaporating at every temperature, okay, but at a certain temperature, the whole of the mass of the liquid gets evaporated. Simple. Evaporation is a surface phenomena. Boiling is a bulk phenomena. Evaporation is a surface phenomena. Boiling is a bulk phenomena. Remember this, okay? Remember it like this. Yeah. So what have we said regarding the evaporation? This is simply the conversion of liquid into vapor at all temperature. It takes place at all temperature. Greater the temperature, faster is going to be the evaporation. Okay. If you talk about heat of evaporation, evaporation causes cooling, because the moment certain amount of water is going to get evaporated, it's going to take some heat from the liquid. Okay. Getting the point? Yeah. So that's why it causes cooling. Okay, so here we go. Let's do some questions now. Let's try some questions. We have seen this diagram. I have given this diagram. Okay. This is basically the temperature versus the time curve. Basically, what do we mean by time? We are providing heat at a particular rate. Okay. So this is the curve in front of you. This is the sensible heating. What is going to be the slope? What is the slope going to represent? This, see, slope is going to represent the change in temperature divided by the heat provided. Okay. So you write, what do you write? You write Q equals to MC delta T. Okay. So Q by T is going to be MC. M is mass and C is the specific heat. Listen, all of you. Listen. Listening, all of you listening. This is slope. This is slope. This is slope. Okay. Q equals to MC delta T. So Q divided by delta T represents the product of M into C. Okay. Listen. Are you getting what I'm saying? All of you. Q equals to MC delta T. So Q divided by delta T is basically mass into specific heat. So the slope is inversely proportional to the specific heat. Can I say this? Can I say that the slope is inversely proportional to the specific heat? So comparing the slope, can we compare the specific heats? That's what the point is. Slope, there should be time instead of Q. Roshan, listen very carefully. Good question asked by Mr. Roshan. Listen. Roshan is saying that in the curve, this should be time instead of heat. Time makes no sense. By the time we say temperature time curve, but by time we mean that we are providing heat at a constant rate. Let's say at 1 second there was 10 joule of heat, at 2 seconds there was 20 joule of heat, 3 seconds 30 joule of heat. That means we are continuously providing heat. Okay. That's basically the rate of providing heat. Getting the point? All of you? Clear? Okay. Okay. So let's take the discussion ahead. So basically, what is the principle of calorimetry? The amount of heat lost by a body equals the amount of heat gained by a body. Okay, this is body number 1 and this is body number 2. let's say that the temperature of body A is greater than the temperature of B. So finally the temperature is going to be some common temperature T. Okay, body A is going to release heat, body B is going to get heat, isn't it? So you can say that the heat lost, you can say that the heat lost equals the heat gain. What is the heat lost? What is the heat lost? Heat lost is equal to MA CA delta T. That means TA minus T equals to the heat gained. That's going to be MB CB T minus TB. Yes or no? This is going to be the expression for heat lost and heat gained. All of you, is this point clear? Clear, 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 clear. Cool. Okay. So here we go. Let's figure out some numericals. Read this question, all of you. Quick. Read this question, all of you. What the question says, 500 gram of water, 500 gram of water and 100 gram of ice at 0 degree centigrade are in a calorimeter whose water equivalent is 40 gram. Okay. Okay. All of you. Ten gram of steam at 100 degree centigrade is added to it. Then water in the calorimeter is. Okay. Latent heat has been, it's a good example. It's a good example of, you know, the application of the discussion on calorimetry that we had. Read this, all of you. Let's begin. Three, two, one. The time starts now. All of you begin. Quick. Fast. Fast, all of you. Quick. Quick, 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 quick. Last 10 seconds. Last 10 seconds. Okay. Time up. What the question says? Question says that 500 gram of water are in a calorimeter. Basically, this is the calorimeter. Okay. How much water is there? 500 grams of water is there. Okay, that's fine. What is the water equivalent of the calorimeter? That's equal to how much? That's equal to 40 gram. Okay. So how much total mass we can calculate? This is 40 grams of water equivalent of the calorimeter and 500 grams of water is there. Okay, 500 grams of water is there. Okay. Okay. And 100 gram of steam at 0 degree centigrade are in the calorimeter. That's fine. That's fine. So what we need to do? Then the water in the calorimeter is. Then the water in the calorimeter is when you add this much amount of steam, if this much amount of steam is added, so how much is the total amount of water? That means some amount of ice is going to melt. Some amount of ice is going to melt. So that's what we need to figure out, that how much is the new quantity of water in the system. What is the new quantity, final quantity of water in the system? So let's figure it out, that how much heat is available. How much heat is available? That's going to be M, just a second, M C delta T, isn't it? M C delta T, M C delta T, the total heat lost is going to be equal to the total heat gained. Yes. So who is going to lose the heat? Who is going to lose the heat? Who is going to lose the heat? Tell me. Gained. Gained. Yes. Okay, cool. Who is going to lose the heat? From where the heat is going to flow? Clearly it has been given that 500 gram of water is there. Okay. So clearly you can say that this is how much total? 10 grams of steam. Okay. 500 gram of water. Water equivalent is 40. So you can write 500 plus 40, 540 into 10 ml. Okay. Plus what? Plus what? MC delta T. MC, this is how much? This is 5400. Plus do this MC delta T. How much is M? 100 into C into delta T, 100. So how much it turns out to be? 10000. Okay. So how much it turns out to be? This turns out to be Q available. Okay, this turns out to be Q available. Let's write it as Q available. So this goes into the heat provided to the system. Okay. I have multiplied additional 0. This is, just a second, this is 10 MC delta T. Okay. So this is going to be how much? Let's calculate it. Side by side. This is going to be 6400. This is going to be heat available 6400. Now the question arises that how much amount of ice it can melt. Where is it going to go? Let's say M amount of ice it melts. Okay. So latent heat has been given to you for the ice. Latent heat has been given to you for the ice. So equate it with M into L. That's 80. So how much it is going to be? Calculate it. Quickly. Quick. Calculate it. How much is it going to give? 80. How much is it going to give? 80. Yes or no? 80 grams. So how much is the total amount going to be? The total amount is going to be 500 plus 10 plus 80. Total amount is going to be 500 plus 10 plus 80. That means 590 grams. How many of you gave the answer correct? Quickly. This is the total water in the container. This is the total water in the container. Yes. Yeah. Okay. Okay, that's cool. So now we are remaining with thermodynamics. Oscillations and waves. So I think that it's going to take another 1.5 or 2 hours. Okay, so what we can do, we can cover this separately tomorrow or day after tomorrow in a separate session, or we can add that content with the 12th class marathon. Okay, so till now what scores are you having? Tell me. Hello Atulya Kumar. Very good, very good, very good, very good, very good. What is your name, sir? You don't know my name. You're studying from me, with me for the past 10 hours. Tell me about your scores, all of you. Yeah, by the way, my name is Kshitij Kanik. Okay. Neeraj Negi is continuously writing. I really appreciate, but not giving the answer. What's this? All of you, tell me, what are your scores till now? I said na that at the end of the session, I'll be writing your scores. Hello, Sameer, Arya. Hello, all of you. Good, 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 good. Okay. See, so the thing is that we will be covering the remaining portion. We'll be covering the remaining portion. Okay, separately. We don't have to rush. 3 topics are remaining. Thermodynamics, it's a beautiful topic. I don't want to just rush the topic. Okay, after that, oscillation, that's again a very good topic. And waves. All 3 topics are beautiful. And I don't want to just, do this very quickly. We should take certain amount of time for that. So anyways, I'll be separately taking these particular topics. So the leaderboard, what's the leaderboard? What is the leaderboard? Let's see. What's the total score of you people? Tell me. Oh, still 177 students are there. Oh my god. Students went and they came back. What is this happening? You people don't have to sleep or what? Okay. Varman 87. Varman 87. Adrika. And who else? Who else? Pratiksha. Okay, still I'm writing your name. Pratiksha. Virat. I said that you have to calculate your scores. Okay. Atulya. Atulya. Arun. Maryam. Cool. Okay. Very nice. Very nice. Very nice. Very nice. Good, 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 good. Okay. Aniket. Aniket. That's fine. Anyone else? Sakshi. Abhishek. Sakshi. Abhishek. Astha. Tanesh. Rohit. Shyam. Okay. Yeah. So that's cool. Let's meet in the next session. Let's meet in the next session. Until then, it was great having a session with you people. Subhanshu, Sudhanshu. Okay. It was really a lovely experience. And we'll be covering the rest of the topics in one session, no matter how long it takes. Okay. So until then, all of you take care. Goodbye I wish you all the very best, and we'll meet again soon. Keep studying, keep smiling, keep spreading positivity. A lot of negativity is there around us, a lot of negativity is there, you know, that's been spreading. So you have to be that source which spreads the positivity. Do something great for yourself, do something great for your parents, do something great for your teachers. Okay, earn a good reputation, earn a good name, and all my best wishes are with you. So we will meet soon in the next marathon. Until then, goodbye, take care, thank you, tada, see you soon, bye.